Before I proceed, I would like to make a humble request to everyone who are present over here to kindly switch off your mobile phone, or you can keep it on silent mode so that we do not have any interruption during the session. Thank you. Please allow me to introduce myself. I'm Kunga Chinde, Program Coordinator of Tibet House, the Culture Center of His Holiness the Dalai Lama, New Delhi, and I'll be moderating today's inaugural session. On behalf of Tibet House, the Culture Center of His Holiness the Dalai Lama, I would like to extend our warm welcome to our chief guest, Professor Avinash Chandra Pandeyji, Director of Inter-University Accelerator Center, New Delhi, our guest of honor, Venerable Geshe-Ngawar Samdila, former Vice Chancellor of the Central Institute of Higher Tibetan Studies, Sarnath, and our keynote speaker from quantum physics perspective, Professor Cecil Roy-ji from the National Institute of Advanced Studies, NIAS, Bangalore, and last but not the least, our keynote speaker from the Buddhist philosophy perspective, our director, Venerable Geshe Dorje Damdula, and our esteemed chairpersons, speakers, and the participants who are gathered here for the conference on Time, Subtle and Gross Matter, and Ontological Reality, Quantum Physics and Buddhist Philosophy, Series 7. Thank you very much. Now I would like to request our chief guest, Professor A.C. Pandeyji, Avinash Pandeyji, our guest of honor, Professor Geshe-Ngawar Samdila, and our keynote speaker, Professor Cecil Roy-ji and Venerable Geshe Dorje Damdula, to kindly come up on stage and light the lamp of wisdom. Ladies and gentlemen, I request you to kindly give a loud round of applause. Thank you very much. Thank you very much. Right. Now, may I request our director, Venerable Geshe Dorje Damdullah, to kindly offer the white scarf, khata, and the souvenir to our chief guest, Professor Avinash Chandra Pandeyji, our guest of honor, Venerable Geshe Samdullah, and our keynote speaker, Professor C.C. Roy, from the perspective of quantum physics. Ladies and gentlemen, Professor Avinash Chandra Pandeyji. Now we have Venerable Professor Geshe Samdullah. Professor C.C. Roy ji from the perspective of quantum physics. Thank you very much, Keshila. All right, now before I begin with the session, I would like to give you a brief introduction about Tibet House, the culture center of His Holiness the Dalai Lama. Tibet House continues to follow the vision of His Holiness the 14th Dalai Lama in organizing this one-day conference on time, subtle, and gross matter and ontological reality, quantum physics, and Buddhist philosophy, Series 7, wherein eminent scholars from various universities and disciplines will share the valuable inputs and address the session. Now, before we begin with the actual session, I would like to give you the insight of Tibet House. Tibet House, New Delhi was established in 1965 by His Holiness the 14th Dalai Lama of Tibet for the purpose of preserving the cultural heritage of Tibet at the time when it faced extinction in its homeland, as well as for providing a center for Tibetan culture and Buddhist studies. His Holiness the 14th Dalai Lama's recurring emphasis on developing a sense of universal harmony and compassion as its own effective antidote to global suffering, together with the needs for a meaningful exchange between different religious and cultural tradition, also had a profound effect on the purpose and its activities of Tibet House. Tibet House aims to bring together Buddhist masters and Tibetologists, people across different disciplines, students and practitioners, and the common man through its various programs and events. Tibet House continues to expand its objective in saving Tibet's heritage and in exploring and working towards Tibet House potential contribution to the ethical development of the modern society. Over a period of 5 decades since its inception, Tibet House has come to recognize as a significant institution for the dissemination of the Tibetan culture and for Buddhist studies. Now we have Tibet House has a library, a museum, various study programs on Buddhist philosophy, conferences, or interdisciplinary subjects such as neuroscience and Buddhist psychology, quantum physics, spiritual ecology, and universal ethics. A publication unit which publishes around 10 to 15 books a year, and program division which regularly organizes lectures, seminars, conferences, film screenings, and exhibitions. Tibet House also offers 4 different courses on Buddhist philosophy, psychology, and Tibetan language course. Firstly, the first batch of Nalanda Master's course, which was launched on 9 December 2016 on the occasion of 51st anniversary of Tibet House, New Delhi, in the gracious presence of His Holiness the Dalai Lama, along with Sri Kiran Rijiju ji, the Union State Minister of Home Affairs, and Sri Najib Jung, Lieutenant Governor of Delhi. The first batch of Nalanda Master's course was completed with 372 students from 44 different countries. Second batch of Nalanda Master's course on Nalanda Buddhist philosophy is already on the run, and we have enrollment from 54 different countries for the second batch of Nalanda Master's course. Now we have the Nalanda Diploma course, which was launched on 2018. 3 batches have been successfully completed so far, Nalanda Diploma course, which is a 14-month course. This course is designed specifically to accommodate people who are more seriously interested in Buddhist philosophy while being in the midst of busy schedule with other engagements and commitments. Till now, we have successfully completed 3 batches, and the 4th batch of the Nalanda Diploma course is already active. And I would also like to share a brief about the audience and the blessing of His Holiness His Holiness the Dalai Lama. On 2nd June 2023, close to 500 students who have recently graduated or are currently studying in the Nalanda Masters course and the Nalanda Diploma course offered by Tibet House, New Delhi, receive a gracious audience and blessing from His Holiness the 14th Dalai Lama and an oral transmission of J. Rinpoche's in praise of dependent arising. At present, there are more than 4,000 students from 98 countries enrolled in courses run by under the leadership of Venerable Keshadoji Damdula, Director of Tibet House, the Culture Center of His Holiness the 14th Dalai Lama, New Delhi. I would also like to mention that our Nalanda certificate course, which is for 3 months, the registration is open for it. So I would like to request each and every one of you who are interested to kindly register. And then we have Tibet House also offer Tibetan language course on a regular basis. There are 4 levels of learning offered at the very nominal fee with special discounts for students, and monastics are fully exempted from the fee. Till date, 25 batches has been successfully completed. For the new 26th batch, we have the registration is already completed, so we are about to begin with the 26th batch as well. Now, I would like to request our secretary, Mr. Tenzin Kunjabla, to kindly come on the stage and address the session. Thank you very much.
Good morning, everyone. Respected Professor Avinash Chandra Panditji, Director, University Accelerator Center, New Delhi. Our guest of honor, Venerable Professor Geshe Samdin La, former Vice Chancellor, Central Institute of Higher Tibetan Studies, Sarnath. Our keynote speaker, Professor C.C. Royji, National Institute of Advanced Studies, Bangalore, Venerable Geshe Doji Damdula, Director, Tibet House, New Delhi. All the respected speakers and chairpersons who are gathered here today, distinguished guests, and all the participants who are gathered here physically and watching live from our online platform. It is my honor to extend a warm welcome to you all to the 7th series of our conference on the captivating nexus of quantum physics and Buddhist philosophy. As our program coordinator have said, he gave a glimpse of the activities of Tibet House. We have been organizing such conferences from time to time where speakers from various disciplines of studies come together to present their views and gain new insights. The topic for today's conference is quite heavy. I know it's heavy because I've been a physics student myself and a learner of Buddhist philosophy, and I'm still at level 0 in both the areas. But we are very fortunate to have a distinguished lineup of experts and speakers with us who will guide us into the realms of quantum physics and Buddhist philosophy. His Holiness the Dalai Lama saw Buddhism and science as different methodologies with a similar aim to investigate nature and reality using knowledge gained to improve the quality of life. The integration of quantum physics and Buddhist philosophy offers a unique lens through which we can contemplate the nature of reality, the essence of time, and the fabric of our existence. As we immerse ourselves in the dialogue and discourse, let us open our minds to the possibilities that arise from this harmonious fusion of disciplines. May this conference serve as a beacon of enlightenment, fostering a deeper understanding of the universe and our place within it. Once again, I welcome you all and let us embark on this intellectual journey. Thank you.
Thank you very much, Tenzin Kunjabla, for the motivational words. Now I would like to give you a brief introduction about the book launch of the conference proceedings. On the conference proceeding on quantum physics, brain function in modern science and Buddhist philosophy, which was organized by Tibet House in 2018. So this book is a collection of insightful papers presented at the significant conference on quantum physics, brain function in modern science and Buddhist philosophy, like I mentioned, where distinguished scholars from the realms of science and Buddhism have participated. The focus was on the intersection between the quantum physics, brain functionality within modern science, and the philosophical tenets of Buddhism. These papers, authored by eminent figures in their respective fields, explore the connections and the correlations between these science and Buddhism. They explore into the parallels and potential harmonies between quantum physics and Buddhist philosophy, particularly in understanding consciousness, the mind, and the fundamental nature of reality. The collection is aiming to bridge the gaps between science and spirituality. Now, I would like to request our chief guest, Professor Avinash Chandra Pandey, to kindly address the gathering. And before, I would like to give you a brief introduction about him. Now, we would like to launch the book launch of the conference proceeding. And may I invite Professor Kaveri Gilji to kindly come up on stage and do the honor. Yeah. And ladies and gentlemen, please give them a round of applause. Thank you very much. Now I would like to give you a brief introduction about Professor Avinash Chandra Pandey. Professor Avinash Chandra Pandey was Director of Institute of Interdisciplinary Studies, University of Allahabad since 2016 before joining IUAC. He was the Vice Chancellor of Bundelkhand University from 2012 to 2015. He has earlier been professor at university from Allahabad after obtaining Masters in Physics, Mathematics, and Doctorate in Philosophy degree from University of Allahabad. As a principal investigator, he led to development of 3 new centers in Allahabad University. He has been member of governing boards and academic councils, courts of many institutes such as INST, Mohali, Aries, Nainital, Dr. H.S. Gore University, Saugor, and University of Allahabad. He is a member of many academic societies such as American Physical Society, Iron Beam Society of India, Indian Meteorological Society, Computer Society of India, IETE, Biotechnology Research Society of India. Now I would like to request Professor Avinash Chandra Pandey to kindly address the gathering. Thank you.
Thank you for the nice introduction. Honorable Geshe Dawang Samtenji, Honorable Geshe Dorji Damdul, the keynote speaker, Professor Shishir Roy ji, all the distinguished speakers, participants of this organization, this particular workshop. I'll take one example. When I was introduced to this subject, a conference was organized by Geshe Samten Saab at Sarnath. So I had an opportunity to meet His Holiness. So after the session, during break, I asked him that how could you decide that where you are going to get reincarnated? With a childlike smile on his face, he said, "Why should I tell you the secret of my..." But after that, he said, if you wish to go in detail, you refer this text of Shantideva, read that 14th poem, and the concept of the closed bracket which we used to study in mathematics, some kind of information was there. After that, we started working for universal ethics, in which we wanted to have how can we inculcate the concept of compassion in the students, the school-going children. So in that process, how to design course module, and many such instances are there that we are naturally having inherent compassion, which over a period of time when we grow old, that kind of compassion gets killed. So how to keep that going, that is again a challenge which under his guidance and also with the help of many volunteers in the country, we still pursue that part. I was introduced to have some connect with Allahabad University. So you might have heard about Schrodinger. Schrodinger is father of quantum mechanics. And he was about to join Department of Physics, University of Allahabad as head of physics. So why I am referring to this particular incident, that at that point of time, the ancient wisdom which we had, which had a very sound basis of understanding the concept of duality, which is very much required for understanding the indeterminate or indeterministic physics. So somehow that concept might have resonated in their minds, that we should at least go and understand how philosophically we used to understand the concept of duality. But unfortunately, because of the wars, the World War, he could not join. And you might have also heard about the famous Schrodinger cat experiment, which is well designed, and that is a kind of thought experiment. And the things which we cannot do, we can definitely think and we can design those thought experiments to prove them logically, which we used to do in our philosophical traditions. And none other than Indian philosophical traditions, they questioned about or they reasoned about the being of consciousness. Consciousness, where from this idea came, if you trace back, you'll find the roots in our ancient Indian Tibetan traditions, that we had something to explore. How can we understand the consciousness? So the famous experiment, it was a cat in a box, which you cannot see. There is a radioactive isotope kept there. Radioactive isotope decays. After a certain count, there is a pot in which a poison is there. And that again, thought experiment says that if the count reaches to this level, the pot in which poison is there, it breaks, poison is spilled. Cat may be in a state of awakened state or is sleeping. She may or may not notice the poison which is there. She may leak or not, but you don't know what has happened inside the box unless otherwise you open. That means before you open the box, both the possibilities exist. The cat might have leaked that poison, might have died, or unnoticingly she might be sleeping somewhere and still alive. So these kind of questions, through thought experiments, which we started working, and then the concept of meditation. And I'm having another responsibility as a director of Inter-University Center for Yogic Sciences. So the yogis, the monks, they meditate, and they reach to a stage where they have got a different experiential knowledge, experiential content which they have, which cannot be described, which beyond description. You cannot write your experiences which you have through your meditation exercises, but it has got some changes to be brought in your hardware, the mind, the brain, which you have. And the individuality, the uniqueness of a person, and how those neurons fire among themselves to bring you uniqueness. That is another area of a domain of expertise which need to be explored in detail. The other important experiment which is there, that you have an instrument in which you, every time you push one ball this side, other ball this side, which is white and black. So that is alternatively pushing balls. The machine is there. If you are here in local, it is happening inside, in front of you. If white ball has gone that side, you can predict that black ball will be coming on this side. So this is kind of local connectivity, entanglement of these two things, that these two observables which are there, which are connected, is local phenomena. But in 2022, and His Holiness also visited some of the scientists who shared the Nobel Prize, and he was very much, he was in conversation with many physicists to explore this idea, to explore and to understand what is mindfulness is. And during these discourses, he always used to challenge the physicists that you should come forward and study the brain, the mind, and then connect how we can explain the consciousness. So in 2022, the non-local phenomena, in which the idea which is going to get much of importance in quantum information, how two different phenomena are connected, entangled, how this information is teleported. This was demonstrated, and Nobel Prize was shared by 3 gentlemen. So this is one aspect which always keep us inspired to think of understanding the microscopic world, to understand the concepts which are there in form of quantum mechanics, and how different states exist, how they interact with each other, how do they interact with each other in terms of transferring the information. But this happens with us also. If we sleep, we dream, and sometimes dream may or may not come true. Sometimes we dream somebody who is far away, but next day we come to know that something has happened to that fellow who came in my dream. These are the questions which cannot be answered today, because the kind of instruments, the kind of equipment, the kind of measurements which we require are not possible. But down the line, definitely, we can understand what you are thinking, how you think, and this way the science progresses. But philosophically, we can always keep questioning ourselves with the logic, with the reasoning, with all available information which we have, and the journey towards knowing unknowns continues this way. I will not take much of time. I'm sorry I got delayed because there was some confusion. I landed in Tibet House. So Professor Shishir Roy is there. He'll be speaking more on the quantum mechanics side, and Buddhist traditions, the philosophical aspects which are there, which generally we cannot decipher because there is disconnect, and the audience is bright enough to connect these two. That is what is expected from this particular workshop, conference. I wish a great success, and this is what we are going to get if anything discernible comes out of this particular exercise. Thank you very much.
Thank you very much, Professor Avinash Chandra Pandey. Now I would like to call upon Venerable Professor Gishing Samdela. So before that, I would like to give you a brief introduction about him. Venerable Gishing Samdela obtained his master's degree from the Central Institute of Higher Tibetan Studies, Sarnath, Varanasi, and subsequently the Geshe Harampas degree, the highest Tibetan traditional degree equivalent to PhD, from Gandhi Monastic University, India. He worked as associate professor in the research department and later as a professor in the Department of Buddhist Philosophy in CIHTS. Thereafter, since 2001, he served as the director and the vice chancellor of the same institute for over 20 years. He served as a visiting professor in many international universities in US and Australia. He was honored with Padma Shri Award, one of the highest Indian civilian national awards, by the President of India in recognition of his contribution to education and literature in 2009. He was honored with Visak Saman in 2016 by the Government of India in recognition of his outstanding contribution to the preservation, development, and promotion of Indian philosophy, arts, and culture within and outside India, as well as his lifelong achievement in the services towards disseminating Buddhist studies and establishing academic institutions. May I call upon Venerable Professor Geshe Samdela to kindly address the session. Thank you.
Sarvadrishti Parhanaya Sadramam Adeshyat Anukambam Ubadaya Tam Godamam Namami. Respected Professor Avinash Pandey, respected Kishadorji Damdurji, respected Professor Sisi Royji, distinguished scholars and friends. Today, we are here to discuss on time, subtle and gross matter, and Buddhist philosophy. It has been quite some time, the last 3-4 decades, since this convergence of Eastern Indian civilization and particularly Buddhist tradition and Western science. So now we have reached to an extent that it is now flowing in various directions in terms of study of mind, in terms of philosophy, in terms of study of matters and things like that. So we can find the two great civilizations, this science in the West and philosophy and ancient science in the East. Here, particularly Buddhist science and philosophy. We have approached in the same direction in terms of finding the reality. The objectives are, not completely different, but the vision is different. The exploration in the West is confined to material reality, the physical world, whereas in the material reality and also to achieve and outcome of the material world and further development of the material world in the West. Whereas in the East, and particularly in the Buddhist philosophy, the exploration of mind and the physical world are meant for not for physical development, but for our own understanding of the world, which makes a lots of impact on our perception. That is the main purpose. That is how you can find in Buddhist philosophy different levels of philosophical schools which have made attempts to explore the world, physical world. Because the exploration of physical world is necessary because our senses are the doors through which we receive informations from outside. Our connection to the external world is our senses, the five senses, and how we perceive, and then what kind of understanding we have, the image that we have in our mind depends on how we understand the world. That is why in order to eliminate the gap between the reality and perception is very important in Buddhist philosophical understanding and also in spiritual practice. It is the belief of Indian philosophical schools in general, and also particularly in Buddhist soteriological understanding, that unless we are able to understand the reality out there, we are not going to make any substantial change within our mind, because we react on how we perceive the external world. That is why in Buddhist philosophical schools we have different schools starting from Vaibhashika, Sautantrika, Vijnanavada, and Madhyamika schools. And all of these schools have made attempts to understand what really the physical world is. So that is why the concept and understanding and exploration of time and matters have been a very important part of the exercise in all of these philosophical schools. This is not just for gaining knowledge, but to bring fundamental changes within our own perception and spiritual development. So Buddhist Vaibhashikas have, their own take on how we perceive and how the, particles exist and things like that. I won't go into detail because we don't have time. But they have also mentioned about the, particles, the smallest particles, indivisibility of the smallest particles, as well as the gaps between the particles. And those indivisible particles are, regarded as permanent, which were not acceptable for the higher level of schools. And then again, the higher level of higher schools refuted those ideas that no particles, no product, no Sanskrit dharma can be permanent in any case. So everything, every Sanskrit dharma, every product is impermanent. And also, when we look at those things, then at the level of Madhyamika, then everything dissolves into emptiness. That emptiness to the extent that there is nothing out there. So the nothing out there in a substantial, form. So because we need to for our spiritual understanding and spiritual development, if there stands anything out there as substantial entity, then that, becomes the foundation of our grasping, on the basis of which all the afflictions arise. So in order to reduce that, eliminate that foundation, the exploration of external world is, extremely important. So, in Buddhism, even though the method of exploration is very different, it is through thought experiments and through, mental experimentations, by using the epistemological kind of devices and systems which have been, developed for several centuries, over millennia in India, and then the logic, the systems developed. These are the the devices through which we reach to that conclusion. Whereas in the West, since it is the exploration of material world is based on physical entities that needs to be explored in a laboratory, and then now we have reached to such an extent, like quantum mechanism and the emptiness. They have very similar kind of the understanding of the reality, whereas in Buddhism, in the West, you see the ontological understanding that has given rise to wonderful technologies, which has been, which has made a significant contribution to transportation, to information and medical field and things like that. But at the same time, those technologies have also made some harmful contribution to the human, society. Now here in the Buddhist side, those explorations are, as I mentioned earlier, explorations are made in order to, reduce and eliminate the perception of having substantial entity out there which does not exist. It worked for the meditators. It worked for the philosophers, because they have reached to that extent through their exploration, mental exploration, and it worked. And experientially, that has worked, and it made, tremendous changes in a human mind and reached to that level. Elimination of afflictions and cultivation of compassion and altruism to unlimited extent is not possible unless we have the proper conviction of the world, reality of the world. That is why it is very important. Now these two, the one approaching from inside to inside and one approaching to outside, these two traditions are converging. And this conversion has played an important role now, bringing substantial changes in the global, civilization. And earlier, when we talk about compassion, then it becomes a religious matter. But now, many scientists are talking about religion, compassion, how altruism can be developed, how compassion can be developed, and this has become now a subject of science. So eventually, we can, by the convergence of these two civilizations, there will be certainly a very, significant kind of impact on global, global, say, education and global, health and global understanding of the world. So I was coming from just last week. I attended a conference in Emory University where we talked about the education, to bring education in school levels from kindergarten to 12th level, and also thereafter in the higher educations. How scientifically, as His Holiness always says, that the teaching of compassion should be based on, teaching of secular ethics should be based on scientific evidences and common sense. And this is what is happening now, that many of the countries, over 40 countries, have introduced this C-learning in so many thousands of schools. and it is making very substantial impact in the mind of the students, children, and which in turn helps their family too. So I think this, and also like, for example, now, since we have very little time, then there is, the time. Now, since this is time is a very important, subject that is related to our life, daily life, Buddhism has explored in this, field as not being an independent entity, but it is just simply a property of a Sanskrit Dharma product. Whereas in science, in the classical science we were discussing this morning, it is a separate, substantial, independent entity. And also in other schools, in Vaisheshikas and Nayayikas, it is independent, it is, substantial, it is permanent. But according to Buddhism, the time is impermanent, time is completely interdependent, and time doesn't have its own entity, independent entity, but it is a property of the product, the Sanskrit Dharma. So no need to go into detail, but these are meant to develop our own perception with respect to the reality out there, right? Either the reality of the inner world or reality of the external world. So if we utilize this, just as modern science is being utilized in technology, this kind of understanding is to be utilized for inner development and spiritual development. Otherwise, this becomes irrelevant. If we have a theoretical understanding and no application for inner development, it is irrelevant. Just as we have very good understanding of, the science, but if it is not applied in technology, then all these great, manifestations would not have been possible. So now, this convergence is taking place. Buddhism can take a lot from the science in understanding its own ontological, nature. And the science, as it is doing, can take lots of, informations and, the knowledge systems that Buddhism has in order to enrich its understanding and to make more contribution to the scientific studies. So with this, I would like to thank the Tibet House, particularly Kishe Tojidamdullah and his wonderful staff for inviting me and to be with you on this occasion. Thank you very much.
Thank you very much, Venerable Professor Gishing Samdila, for your wonderful words. Now may I request Professor Sisi Royji, our keynote speaker from the perspective of quantum physics and the convener of this conference today, to come up on stage and address this session. And before that, I would like to give you a brief introduction about him. Professor Sisi Roy is a theoretical physicist working on foundations of quantum theory, cosmology, and brain function modeling. He has deep interest in Indian philosophy and epistemological issues in modern science. He has published more than 200 peer-reviewed papers in various international journals and 15 research monographs and edited volumes in Clover Academic Publishers, World Scientific, Springer, Roulette Taylor, and Francis, etc. His recent monographs include Demystifying Akasa, Quantum Vacuum and Consciousness, jointly with Ralph Abraham, Epigraph, New York, 2011, Decision Making and Modeling in Cognitive Science, Understanding Space, Time, and Causality, Modern Physics and Ancient Indian Tradition, jointly with B.V. Srikantan, Rutledge Taylor, and Francis in 2020. He has visited many US and European universities as a distinguished professor and a speaker. Ladies and gentlemen, please welcome Professor Sisi Royji. Thank you.
Good morning. I'm indebted to my great friend Geshe-la Dorji Damdul for inviting me here, and many times I have been here and we are discussing many things since maybe 2000. I'm in Drepung Lojaling Monastery, and we spent wonderful time. And His Holiness Dalai Lama we met, and of course his encouragement and inspirations. I've been associated with Tibet House, then respected chairman, our chief guest, Professor Pandey, and chief guest, Professor Shamtenji. I know him for quite a long time. Now, special thanks to Geshe-la Damdul, because after long years he is able to publish the book and many discussions, many corrections, and after that it's a really very important event. Then for today's keynote speech, I like to mention one thing. I have many students, and I know many young quantum physicists in the country, around the country. The very important questions they ask me, well, is it necessary to study philosophy at all? Whether it will give some insights or something so that we can do our research in our own field. This is very important question, and not only by these young people, but if you look at the 20th century physics world, there are two very distinguished personalities. One is Steven Weinberg, who won Nobel Prize in Physics. He's very influential physicist in 20th century, and he was very serious physicist, not like comment something in philosophy. And another is Stephen Hawking. Stephen Hawking and Steven Weinberg are no more, and they passed away a couple of years before. So they raised very serious questions that physics, especially physics, in such a state that we don't need to study philosophy at this stage, because it contains huge number of data, like Hubble Space Telescope. It collects billions of data, and people are trying to understand modern cosmology. Even recently, Chandrayaan was sent by our Indian Space Research Organization. They are sending lots of data. In biology too, we have lots of data. So why do we need to study philosophy? This is very important question. And physicists are divided on this issue. Even Avinashji, he mentioned name of a great quantum physicist, Erwin Schrödinger. Schrödinger, in his Dublin lecture, he gave 2 lectures in Dublin, and now it is available in the book form. So the main objective of this lecture was whether we should look for our ancient wisdom. Is it useful? At that time, he was full professor in theoretical physics in Dublin Institute of Advanced Study. And then he told, how do I justify taking salary from the institute and speaking on ancient wisdom? At that time, he meant ancient wisdom means Greek philosophy. He tried to justify that both scientists and philosophers, they look around the world, outside and inside, but from their own perspective. And the concepts which we are using in both the discipline, both the paradigm, science and philosophy, they normally take it from Greek point of view, because he was not that time referring Indian wisdom. But if you look from historical perspective, Indian wisdom was much, much older than Greek thoughts. So he tried to justify why we should learn, we should study or investigate philosophy also. Now, one simple answer may be whether by studying this Indian philosophy, including Buddhist one, we can get some insights. And this is the questions we are raising to most of the conferences. We are asking the traditional scholars in Buddhism or Vedantin or some other disciplines, can you give some insights so that we can resolve the dilemmas, we can resolve the epistemological and ontological issues in science. Not only that, there is a big progress in technology. Whether we can discover a new technology by studying our ancient Indian wisdom. This is very, very important issue. And people should come up with some ideas who can read the original text in Pali, Sanskrit or Tibetan. Now, since the birth of quantum theory is a theory which describes the behavior of the microscopic entities like electrons, protons, photons, quarks, Higgs bosons, etc. What do we mean by microscopic entities? Because in physics we have a kind of division between microscopic entities, macroscopic entities. And microscopic entities are characterized by its mass, its length, and some other characteristics. So, quantum theory was discovered by people like Erwin Schrödinger, Niels Bohr, Louis de Broglie, Pauli, Heisenberg, and other people. One important issue was raised by Niels Bohr that unless you observe anything, you cannot say what it is. Suppose there is electron, a tiny microscopic entity. Unless you observe electrons through microscope or kind of instrument, you cannot say what it is. So, in a sense, reality here is observer dependent, or philosophically we say this is epistemic, reality is epistemic. But due to advancement of quantum theory, quantum field theory, again people are coming to the ontological issues. What are the ontology or substratum on which these theories are based? And especially it comes regarding the origin of the universe, like Big Bang, what is before Big Bang. One sensational news was published in New York Times a couple of years before regarding a certain experiments in quantum theory. The title of the news was Rashomon effect in quantum theory. What is Rashomon effect? There is a famous film, Rashomon, directed by Kurosawa, Japanese, internationally acclaimed film director. So what is the essence of that? One samurai was murdered and police was trying to look who was the real culprit. So they interviewed many people. And the different people, they give their different opinion. So the question comes, is reality observer dependent? And many quantum experiments have been done, and they say that it is observer dependent, which is compatible with Niels Bohr idea. But, well, there is difference of opinion. Now, this conference, we are using terms like time, subtle gross matter, and ontological reality. Now, how do you perceive the reality? Professor Shamtenji told that, okay, first is the perception comes through sensory organs like touch, eye, ears, etc. The 5 sensory organs are there. So, in science, what we do, along with sensory perception, sensory organs, we use instruments. Like to find the existence of the microscopic entities, you need very, very precise instruments by which you can look. Even the question is more deeper, like with instrument, we need instruments to look into the bacteria. So, bacteria are not at the same size, same mass of the microscopic entities like electrons, protons, or neutron. Or if you need to see the galaxy, or like quasars, or like faraway stars, we need telescopes. So, the question comes, what is the definition of subtle matter? What is the difference between subtle matter and gross matter? So, we use sensory organs and instruments. What people in philosophy, they talk about. They use the critical analysis like scientists, they use logic like scientists, but they normally don't talk about instruments. They say experience. Now we are stuck. As a scientist, it's very difficult to say what is experience. So the issue is, in both the paradigm, we use, we study, we construct hypothesis formation, and one, in science, one more is necessary called empirical testing, empirically verification. I mean, there may be two theories to explain one observation even in science. I can tell you briefly one story. In New Jersey, two great persons lived that time, one Albert Einstein and his neighbor Kurt Gödel. Gödel was a famous mathematician. One day, Gödel came to Albert, said, "You see, I have found a different solutions of your equation, mathematical equations." Albert told, "Okay, give me, let me see." And after 3 days, Albert went to Gödel and told, "Yes, your solution is right, but it's not physical. Means physically it is not verifiable. So I can discard your solutions." So this predictability is one thing, and to verify the predictions. This is very, very important in case of science and technology. Now, you are thinking, in Buddhist philosophy also, there is something, Samtenji was mentioning, like thought experiment. In science, we say Gedanken experiments, German word, Gedanken experiments. So, I am tempted to mention one thing called Payasi Sukto. Payasi was a prince, and he had a long dialogue with Buddhist monk Kashyap. It occurred after 200 years of parinirvana of Gautam Buddha. So, Prince Payasi, he was putting, 10 experiments, all thought experiments. And Buddhist monk, he was refuting these kind of things. So, this is a famous dialogue. And if you look at these 10 experiments, the first experiment was that what is the proof that vital force exists? You place a prisoner in a chamber, and after his death, before his death, you take the weight of both the chamber along with the prisoner, and after his death, you again take the weight of the prisoner. And if there is no difference, so how will you prove that vital force exists? But in each experiment, Buddhist monk Kashyap, he refuted. So, you can think of Payasi Sukto. He was a modern day scientist who believed in empirical testing. But I don't know what happened after that. Many thousand years have passed. Maybe my colleagues are here, the Buddhist scholars, whether these kind of thought experiments or Gedanken experiment have been performed. But in science, even in quantum physics, Avinashji, he was talking about Schrödinger's cat experiment. It's a thought experiment. And in science, mathematics, and I know in Western philosophy, there are lot of such Gedanken experiments. And I have little knowledge about such kind of Gedanken experiments in Buddhist philosophy. Only I mention Payashishukta. So my provocation to young people here, whether they can think of such or construct, even at the Gedanken level, which can be verified or cannot be verified, to show that the subtle or sukshma and gross sthula, whether these differentiations, what they talk about in philosophy and Buddhist philosophy, that can also be distinguished in the arena of modern science. If they can do it really, it will open up a new vistas. Like in physics, there are many, many such experiments. Schrödinger cat experiment, Wegener's faint, or started from Galileo's. So I try to conclude my lecture that the young minds here, please try to construct such kind of Gedanken experiment so that it will really give impetus to think of philosophy and science together.
Thank you very much, Professor Cicero-ji, for your inspiring and motivational words to the younger generation. And now we have Venerable Geshe Dorjit Abdullah, the director of Tibet House, the Culture Center of His Holiness the Dalai Lama. Before that, I would like to give you a brief introduction about him. Venerable Geshe Dorjit Abdullah is the director of Tibet House, the Culture Center of His Holiness the Dalai Lama, New Delhi, since 2011. Venerable Geshe Dorjit Abdullah served as the interpreter and translator for His Holiness the Dalai Lama within India and abroad. He is one of the chief editors and co-author of scientific, philosophical, Buddhist, and secular books with prominent professors in the United Kingdom and the United States of America, as well as with His Holiness the Dalai Lama himself. These books are being used as centers and institutes all over the world to study more thoroughly on Buddhist philosophy, metaphysics, epistemology, and science. He has translated several important Buddhist philosophy texts and has contributed various papers for national and international conferences. Venerable Geshe Dorjit Abdullah's profound knowledge of science and interaction with the world-renowned physicists gave him the unique ability to teach Buddhist philosophy with a modern twist that many of his non-Tibetan students appreciate. I would like to request Venerable Geshe Dorjit Abdullah to kindly address the session, sir. Thank you.
Respected Professor Pandeyji and respected Venerable Geshe Awesome Geshe Awesome Denla, and my very dear friend Professor Cicero-ji, and as Professor Cicero very clearly indicated, that our friendship is since 2005. I very clearly indicated. I very clearly remember that the he in those days he was so curious about the concept of relationship. Therein science or in reality. And he was not getting an answer as a brilliant physicist. So he thought, who must be the person who can explain this? Oh, His Holiness the Dalai Lama. Then he wrote his, Dear His Holiness the Dalai Lama, please explain to me how to explain the relationships. So then of course, His Holiness received thousands of mails. And the secretary, that time I just finished my Geshe degree. I went to England, Cambridge, came back, and then the office of His Holiness the Dalai Lama forwarded the mail to me saying that, Geshe-la, you give answer to this question. So I communicated with Professor Cicero. So this is how we became extremely close. And then I invited of course, I can sense that he's extremely brilliant, and that this concept cannot be discussed just through emails. And so we should meet. And then I asked if you have time to come to my monastery. So he and his wife, who's also the doctorate in physics, both of them came to Devon Monastery and stayed there for about 10 days, I think. And both of them were very fortunate to have met with my teacher, Venerable Geshe Namgyal Wangche Rinpoche, who passed away now, and received many instructions. And we had extensive discussions on quantum physics, relativity theory, Buddhist philosophy, and so forth. That was really a beautiful moment. So having said this, to make it very quick, this being the keynote speech, I'm going to touch on almost all the topics, but very briefly, and so that the more detailed the forms, I'm expecting you, the participants, to learn from the experts who are going to speak on each of these topics in more detail. First, we see that we talk about in quantum physics, the concept of the quantum decoherence, superposition of various possibilities. And in Buddhist philosophy, I don't want to go into the quantum physics side. From Buddhist philosophy, what do you find about the concept of, particularly concepts like the superpositions of the various possibilities and so forth? So we see that we have to see the things as the Geshe Ngawasandala very clearly indicated, and also Professor Cicero indicated, that the reality, what is the ontological reality there? What is ontological there? In other words, in another words, I can say, what exists there objectively? Or what's the ontological reality? What is objectively, this question? So from this, I'm sure that those speaking from the Buddhist point of view, they will give more detailed explanation how everything is mental construct, and yet having the need to conform to the functionality of this world, not denying, not defying the law of cause and effect, or the cause and effect, I would say. Albert Einstein, who would be more happy to talk about the determinism as opposed to randomness there. So we see the same object on two different levels. One, very close inspection, as Professor Cicero talked about the micro world and a macro world. So the relativity theory operates so well, can be applied so well on the macro world, but the quantum mechanics cannot be applied on the macro world as universally. Instead, it operates so well with the micro world. So we see that there's a discrepancy between the formulas, the rules, regulations, or the physical theories applicable to the macro and the micro as two different things. And Buddhist philosophy, the macro world represented by the conventional truth, and the micro world represented by the ultimate truth. So we see that these two truths explain the same object in two different points of view. So one is what is seen by the conventional, the mind, and the other is seen by the ultimate mind. So all the things that we talk about in this world, like for example, say how the electrons, they behave, manner in which Professor Panditji indicated, teleportation, the concepts, the entanglement. So all these, they fall under the category of the various levels of the behaviors of things on the conventional level, not on the ultimate level, how the electrons behave on the different levels, say how the magnetic effect, electromagnetic effect plays a role in this, how that operates. So with that, even within the conventional level, we see that there are various levels. Some operate on what Professor Ciceroy explains on the Newtonian physics. On that level, we see one reality, and then go a little deeper, we see the particles, they behave slightly differently, and then on the quantum level, they behave extremely differently. Yet the thing is that how you perceive them, how you perceive the independent of the observer, as Professor Ciceroy again said, picking up the Professor Niels Bohr's the reflection that independent of the observer, observed makes no sense. In other words, say things do exist so efficaciously and infallibly they operate very efficaciously, but the thing is objectively, what is the answer is there's nothing from the object. Things do exist so efficaciously on the conventional level. And then the convention, we keep in mind that it is many levels. So for example, how the electrons operate, unlike the quantum entanglement, so forth. So they behave, but on a different level. Within conventionality, we can see that there are various levels of perceptions. And beyond the perception, what is there? Then the Arya Nagarjuna very clearly indicated there's nothing really there. So with this in mind, some of the features that we need to keep in mind, like they say the conventional truth, the truth that is perceptible by the conventional analysis, conventional mind. So it can have like three aspects, what we call as the positive phenomena, affirming negative phenomena, non-affirming negation. But ultimate truth that we talk about, in fact, the same conference here, now the professor passed away from NIAS, Professor Cicero, you remember? The former director. Yeah. What is his name? He was the chief guest. So, no. Shirikandan, yes. In fact, here we talked about the ontological reality and as an ultimate reality. And Professor Shirikandan asked on this platform that how can you say that the ontological reality that you would see or physics would see, and that is the ultimate. So this question asked here is extremely pertinent question. Whether or not what we see as what is the demarcation of the ultimate truth. So we talk about the conventional truth and the ultimate truth. In a loose sense, I talk about the macro world, the truth on the macro world and the truth on convention, the macro world. So what constitutes the ultimate truth? And of course, that requires to be more discussed. They discuss more. And the ultimate truth, the final reality, of course we need to settle what constitutes ultimate reality, whether or not the ontology that we discovered, that explain, qualifies the ultimate, or there's something more. There can be greater possibility for something more than what we find as ontological reality. So for this ultimate reality, one thing is that the qualification that the aspect is that it should be non-affirming negation. Non-affirming negation. And of course, there's a very technical term, what constitutes, again, what is meant by non-affirming negative. And that why ultimate should be non-affirming negative. All these questions should be resolved. So in this connection, micro and the macro world. So in physics, what we see as the disparity between quantum physics and relativity theory, quantum physics is only explaining about the macro world, and the relativity theory explaining about the macro world. In Buddhist philosophy, macro are seen with the same object. Both aspects are seen depending on what perception you, or what the perspective you take, or what perception you employ. And then quickly talking about, so this is something which I touched earlier, about the non-locality and so forth. So this is very interesting. So in Buddhist philosophy and more metaphysical the level, we see that the mind and your energy. And then when I talk about the mind, it is not the esoteric mind, it's the empirical mind. For example, I personally believe that when you talk about when you have any discussions with the physicists or neuroscientists, it's so important for us to discuss those points which are only empirical, which is not something esoteric to be experienced later on and so forth. So this is something which usually when we talk about the self, the person, what is that empirical self? The self who wants happiness, who doesn't want to suffer, who doesn't want to experience the wars, war-torn zones. How many people are suffering so much? So the self is affected. The self. This is self, empirical self, which can be affected. We can have the potential to experience happiness. This is the empirical reality. These are the topics to be brought on the table to discuss, particularly having discussions with the physicists and the neuroscientists. Whereas if it's purely the psychological or purely metaphysical, that's a different story. So, but the point is that when you talk about the mind, which is empirical, so this mind will come to, if you study more deeply, we see that this mind, they operates on the basis of in connection with this some kind of energy. When I speak of the energy, again, it's not either the obscured something, the unseen, the thing, or energy, how we discuss in electromagnetic energy and so forth. No, it's actually none of these two. This is something which can be experienced, and yet at the same time, and logically we can explain it, and Professor Siroy made the distinction between what is predictable and what is verifiable. Although we can engage in prediction of something very precisely, but if it cannot be verified empirically, again, it is not scientifically proven as something solid. So with this in mind, when talking about the non-locality or quantum physics, this reminds me of when you train your mind. Non-locality, when it comes to that, is is applicable on the subtle, say the electrons, on the level of the electrons and quarks. On that level, then we see the behavior of these in the form of non-locality, quantum entanglement. These are all these behaviors seen on that level. So likewise, in the Buddhist, the study of the philosophy and psychology, we see that as a mind becomes subtler, if you train our mind, we can train. If you don't train, then our mind can become very subtle. At that point, you lose control. When the mind is grosser, you have to control. For example, now, whether you want to sit here or you want to go out to have a cup of tea, it's in your hand. You have some degree of control there. But in the dream, you don't have control because we are not trained. You have the mind, you can have the different dreams. You don't have the control. So, where some people who train themselves, and the training is not that difficult. It's not something the obscured, something with the blessing of some gurus and so forth. Only then these things happen. No, it's a matter of the practical reality. You train yourself to see the mind, even during the dream. Then you see that you can control the dream. So with this in mind, as the mind can be controlled more and more, then the mind on a very subtle level, we see that it operates alongside the energy. There's energy which you can feel. For example, say, when somebody says something nasty to you, you're being mentally, you feel there's some kind of energy flow there. We talk about the hormones and so forth, but there's an energy there which makes the hormones move. So that energy and the subtle mind, these are very closely connected. When that happens, then all these, what we call as the miracles, they happen on that level. When the subtle mind is activated, subtle energy is activated. So through training. So like just as with the quantum physics, on the macro level, then we see the different behaviors of the teleportation, quantum entanglement, non-locality, All these are the seen on the macro level, not on the macro level. Likewise, when the mind becomes subtler in a Buddhist psychology and philosophy, when mind becomes subtler, then the mind, you can see that mind can behave very differently, subtle energy. So, for example, it's very interesting. There's an anecdote at the time of the Buddha, that one monk who was just very ordinary monk, and later on, he was being marginalized by his own brother, who was a very senior, respected monk, and all the monks were invited for lunch, and this monk was not invited, and he felt so low, and the Buddha came and gave him some trainings, and through the training, he was able to activate the subtle mind, because of which he manifested like 1,000 times simultaneously, 1,000 at different places. So all these are they moved. Physically, there's no explanation how they communicate with each other. But this is what is happening. This is exactly what we call as the two electrons talking to each other, metaphorically talking to each other. Although there's nothing connecting the two. So likewise, there's nothing connecting the two things. The thousands of manifestations, all behaving differently. So these we see that they're on the subtle level, just as in quantum mechanics operating on the macro level, some very strange behaviors are seen. Likewise, on the mental and the subtle energy explained in Buddhist philosophy, the very strange phenomena of what we call as miracle can be seen. And everybody can perform this miracle if you're trained in this subtle mind. So we talk about the two truths, ultimate truth and conventional truth. This is a place we recently visited, the Vultures Peak Rajgir, where the Buddha taught this ultimate truth, what constitutes the ultimate reality or ontological reality. And so the essence of what the Buddha taught was this: form is empty, which means that the ontologically speaking was a form. There's nothing to be identified as a form from the object, but the subjectively, on the level of the observer, the form does exist. What is seen as empty objectively, subjectively it is seen as a form. All the, infallible cause and effect, these are all operating on the basis of the subjective level. And these two things, form is no other than emptiness. Form, which is the macro world, and emptiness, the micro world. These two operate not on two different domains, but they're operating within the same content of the object. And likewise, emptiness not other than form. These two operate on within the same object, depending on how you look at it. When you look at it on the subtle level, it behaves differently. When you look at it on the grosser level, it behaves differently. And then to understand, really get there, it's not that easy, of course. We require extensive studies. So we have like the explanation of the 5 levels of the emptiness, shunyata. And interestingly, the quantum vacuum, concept of quantum vacuum, again, this brings us to the understanding of the concept of shunyata, the emptiness. Vacuum has connotation to emptiness, is very interesting. Quantum on the macro level, and the emptiness again on the micro level. On the macro level, how they behave is like one in the form of vacuum and one in the form of emptiness. When we speak about the vacuum, quantum vacuum, it's not like nothing really there. You can discuss with the physicists, you'll see that, particularly I would say Professor Cicero, he would explain that in the form of innumerable or incredible or innumerable amount of possibilities, various possibilities there. How the Big Bang started, before the Big Bang, there was a quantum vacuum there. So likewise, emptiness is not like nothingness. So there is a tremendous potential to give rise to the whole universe operating so efficaciously in the form of cause and effect. And the causation, free will, and determinism. This is a very interesting topic, and of course, we would be most happy to see that the scholars are going to discuss on this part. The causation, cause and effect, and the free will. Are these two, do things operate on the cause and effect of the level, or there's some form of the randomness, or there's some form of free will, or causation, the causation leading to determinism, and then the randomness leading to free will, or that they can ever actually overlap. This is a big discussion, and of course, in the domain of science, particularly Albert Einstein, he's not happy with the randomness. He speaks about that the universe must operate on the basis of the cause and effect level, on that basis. So he's more like following the predeterminism, and whereas Niels Bohr, those on the side of the sheer the kind of physics, would be more happy to explain the randomness concept. So in Buddhist philosophy, what is this? In Buddhist philosophy, there is no contradiction there between the two. In fact, I remember one of my teachers, extremely brilliant scholar, and one of his students, the American lady, and whose husband was a physicist. And she was so keen that her physicist husband should become a Buddhist. And the physicist husband said that I will become a Buddhist right away if you give me an answer to one question. And then the wife thought that, oh, Buddhism is my area, he doesn't know Buddhism, so I'll be happy to give any answer. And if you can give me a satisfactory answer to this question, I'll become Buddhist right away. This was question. This was what he said. And he said, yes, I'm ready. Ask me the question. That Buddhism believes in the law of karma. Law of karma meaning cause and effect. And Buddhism also believes in free will. If you accept free will, where is the law of karma? If there's law of karma, where is the free will? Law of karma means what you do is because of the previous karma. That karma is because of the previous karma. If that is the case, it's determinism. Where is free will? If there's no free will, why should I have to freely join Buddhism? This was the question. So she got stuck. She didn't have an answer. She emailed me, even not me, emailed her teacher who was also my teacher, and who was a brilliant logician, philosopher, and who was actually a Geshe colleague of His Holiness the Dalai Lama, the final degree in philosophy, who sat for the same degree in the same year as His Holiness. And later on, His Holiness also received some teachings from him when he was in his last days of his life. So she was asking this question, and of course he doesn't check the emails. So she sent it to me. And looking at it, I was so intrigued as a young boy. I must be in my 20s. I was so intrigued. This is a question that I like to get answer. And now this right teacher, my teacher, he's the right person in this world who can give this answer. I was so great excited. I printed this out and went there and gave it to my teacher, and he read it for me. I read it, and I was just waiting for the answer. And he said, Dorji, give some answer. Right? Okay. So this was what happened. Okay. So the point is that they say the fact that in Buddhism, that the physical world is all operating, physical and the mental world, they are all operating on the basis of cause and effect, no doubt. This is an undeniable fact. Meaning that in Buddhism, if somebody distorts by saying that, oh, in Buddhism, free will is there, that it's not necessary that the cause and effect is operating on all phenomena, this is altering the facts of Buddhism. What you find in Buddhism, does it tell you the reality, the fact? If you say that, yes, everything in Buddhism is fact, this is chauvinism. This is chauvinism. So we need to make a distinction. What is taught in Buddhism is a fact or not? Put that into question mark. You don't accept it. But what is taught in the Buddhism should not be altered as taught in Buddhism. What's taught in Buddhism, you should be able to say that this is taught in Buddhism. That should not be altered. So in Buddhism, the fact is that the Buddha told all composite things are impermanent. Impermanent has a connotation of the cause and effect relationship. So all physical and the mental world should necessarily operate on this cause and effect according to the Buddhist philosophy. Having said this, that is all the causation, and there's nothing randomness. If that is the case, then where is the free will? This question. This is a big question, and I'd like to make it very quick. That free will and determinism, we cannot define it in our own ways. Free will and determinism is what we can see in the world. So we have to define according to how that is seen in the world. You cannot define it in your own ways. So free will, when I say that, okay, let's say will I drink this water or not? You will say it depends on your free will. It depends on you, which means that you're going to use your free will. If you said you will drink it, I'll not drink it, I'll keep it there. If you say you will not drink it, I'll drink it. I'm using free will. At the same time, say after drinking this, if you ask me, what did you drink? Just to challenge you. So challenging you is the factor, is a cause for me to deliberately drink it when you said you will not drink it. So that is the cause and effect operating. Meanwhile, there's a free will there. There's no contradiction there. So there's overlapping of the cause and effect and the free will. So all these, and of course, when I say this, you cannot deny what I'm saying. At the same time, you will not feel so comfortable. Or free will and free will and cause and effect, these two are just mutually exclusive. These two cannot be seen, the inclusive contained within the same object. How he explained, I cannot really deny him, but I'm not comfortable, right? So the real feeling of they becoming comfortable, the ease will come to us only when you know what is known as conventional truth, that things exist conventionally. So for example, if I want you enjoy this water, don't look at through electron microscope. If I look at the same object through electron microscope, I will not see the water. And if I like to enjoy the painting of Michelangelo, if I like to enjoy the painting of the Michelangelo, don't look at it through electron microscope. You will never enjoy this. You will just see atoms, electrons, protons. You will never enjoy the painting. So this painting is undeniable reality that this is painted by one of the most brilliant painter and sculptor in the world, Michelangelo. And yet, if you want to enjoy this, don't look at through the macro level, but through the electron microscope. So there's one reality which is undeniably existent. At the same time, you have to look at it through one particular perspective, not through the most minutest, most refined perception. So this is known as the conventional truth. If you don't understand the conventional truth, the disparity between the so-called disparity between the causation and the free will cannot be resolved forever. Okay, I know that there are many things there. Then they say the causation, and some people may say that in Buddhism, the free will is there, and then yes, free will is there, causation there. How is causation there? I'm going to cite some of the facts there. Thank you. Say, for example, the mantra, which is very popularly taught by Buddha, Ye dharma hetu prabhava, all phenomena arise from causes. So this cause and effect is taught there. And free will. And where is the free will in Buddhism? Where the Buddha taught? Again, this is where we see that the second verse says, ceasing from karma's afflictions is nirvana. Karma's afflictions arise from conceptualization. Sorry, there's some typos there, which in turn arises from elaboration. Elaboration ceases by the wisdom of emptiness. So karma is the intention. So this intention is the one. Karma means action driven by your intention. So this intention is the basic fabric of free will. So because of this intention, then you do good or bad is in your hand. So there's a Tibetan expression which says that if you want to know your past, you look at your body today, how healthy you are, how happy you are physically, how comfortable you are. And if you want to know your future, look at your mind. It does not say look at your body. It says look at your mind, which means that the free will. You decide to do good things, future will be good. You decide to do bad things, future will be gloomy and dark. So this is the free will. And this more detail, you will find this in the explanation of the wheel of life, particularly second one, karma, in the link. The 12th, this painting, this is not just arbitrarily that I brought it here. This is a painting which depicts the concept of free will in relation to the second, which is the law of karma. And then there are a few things like identity, individuation, non-locality, I don't have time here. And so I would rather stop it here. And finally, what I would say is that practically speaking, there are extremely brilliant ideas, concepts in physics, Buddhist philosophy, and so forth. Practical reality. Is there an end to the problems? Okay, problems like what? Look at the tears of the world. This is reality. After talking about the physics all the time, after talking about the Buddhist philosophy all the time, at the end of the day, you see the loss of near and dear ones. Tears flow. It's so painful. Just see in what way these studies help you. These studies, this exploration help you. Just see in what way you can help yourself to remove these tears. In what way you can help your family members to remove the tears. In what way you can help, if possible, your community and the whole world to remove the tears. Do these studies help us? This question. So in this connection, I would say that what is the benefit of all these reflections? Let us not be negative. Let's not be negative. Say, as Professor Gishingawa Samdinla very clearly indicated, that there's a soteriological purpose in exploring what constitutes the ontological reality according to the Buddhist Shakyamuni Arya Nagarjuna. It's not about making us a Buddhist. It's about removing your tears of the fear, tears of sadness in life. That is purpose. How? So, say, if you know the reality, that the reality is all constructed by your own mind, then the remote control of the whole world gets into your hand. When the remote control gets into your hand, then you decide. Why do you have to depend on others? When you depend on others, then the fears arise, whether things will happen the way I like or not. The fears arise. But the fears brings the tears. So, if you see that everything is just a matter construct, how the quantum physicists explain, the Niels Bohr said that observed makes no sense unless that is observed. So observer dependent. Observer meaning the subject, subjective existence. On objective, nothing's there. If you know this, then it is like waking up from the sleep of ignorance. You be in the sleep, the dream, nightmare affects you. So much of fear and anxiety. The moment you wake up, the fears dissolve. Why? To see that the dream is nothing but subjective real. Objectively, it is empty. So waking up, the fears in the dream stops. So this philosophy is not for the purpose of spreading ism. It's not for the purpose of competing with modern science. It's for the purpose of stopping us from having to shed the tears. Okay, just as this is from a sutra, just as in the dream of a young girl, she met with a boy and saw his death. Meeting with the boy, very excited, and seeing the death, so much of trauma and pain. Joyous was she at the meeting, and despair at his death. View all phenomena thus. If we want to stop shedding tears of life, then we need to see how the study of quantum physics and how the emptiness of objectivity, as explained here, discussed here, will make total sense to us. Okay, these brilliant thoughts, they developed in this place, Nalanda, now 1st century through to 3rd century AD. And then we have some suggested, okay, this is the old version, it's fine. So there are actually more reading materials, but there are two things here. Thank you so much.
Thank you very much, Venerable Geshe Dojud Abdullah. Now with this, I would like to conclude the inaugural session, and I would like to convey my heartiest gratitude and heartfelt thanks to our chief guest, Professor Avinash Chandra Pandeyji, our guest of honor, Venerable Geshe Samdila, our keynote speaker from Quantum Physics Perspective, Professor Sisi Royji, and our director, Venerable Geshe Dojud Abdullah. Thank you very much. And also, I would like to extend my heartfelt thanks to all the participants for being vibrant and so dynamic, and at the same time being, concentrated to the topic of this conference. Right. So now we would like to begin our first session of the day within 5 minutes, which will be moderated by my colleague, Ms. Tenzing Domala. And the sub-theme for the first session is Quantum Objects and Subtle and Gross Matter in Buddhist Philosophy. Now we would like to conclude this session, and we'll be back within 5 minutes. Thank you very much. Um, Professor A.C. Pandeyji and our guest of honor, Venerable Geshe-la, Professor Ciceroji, we would like to take a quick group photo. And all the chairpersons, speakers, I would like to request you, all of you, to come up on the stage, please. I would like to request our chairperson, speakers, and the student panel speakers, all of them to come up on the stage. We'll take a quick group picture. Please. Thank you. Thank you, everyone.
Good morning, everybody. Please remain seated. I'll be starting this first session in a few minutes. Good morning, everybody, those who are present over here and those who are watching live from Tibet House Facebook and Tibet House YouTube channel. Please allow me to introduce myself. My name is Tenzin Doma. I'm working as a program coordinator, Tibet House, New Delhi, and I'll be moderating the first session, which is on quantum objects and subtle and the gross matter in Buddhist philosophy. The concept of subtle and the gross matter has been discussed in Indian philosophy in general, and especially in Buddhist philosophy and the framework for many centuries, and it is related to the perception and the role of sensory organs and the human cognition. And later, the development of neuroscience and the quantum physics shed the new light in this direction. So here we have identified some of the important issues from quantum theory, which can be discussed by the quantum physicists, the speakers, and the Buddhist philosophers as a speaker. So therefore, under the blessing of His Holiness the Dalai Lama and the leadership of Venerable Geshe Dorje Damdala, we came to organize these series of conferences such as quantum physics and Buddhist philosophy today, and also we have been organizing the conferences on neuroscience and Buddhist psychology. So before further ado, I would like to request Professor Hirapol Gangnegi, former head of the Department, Buddhist and Tibetan Studies, Namgyal Institute of Buddhist and Tibetan Studies, Gangtok, Sikkim, the chairperson of the first session, and the speakers, Senior Professor R. Ramanathan, retired, Department of Physics, University of Delhi, and Venerable Dr. Pooja Dabralji, Assistant Professor, School of Buddhist Studies, Philosophy and Comparative Religion, and School of Language and Literature, Humanities, Nalanda University, Rajgir, and Dr. Abhishek Manji, Physics and the Applied Mathematics Unit, Indian Statistical Institute, Calcutta, to kindly come up on the dais and take their respective seats, please. Yeah. Thank you. And before I request Professor Gangnegi to proceed the session, I would please allow me to introduce you. Professor Hirapal Gangnigi has completed Master's, MPhil and PhD from the Department of Buddhist Studies, University of Delhi. And he has been the head of the Department Buddhist Studies University from 2014 to 2017. Later, he became the head of the Department Buddhist and Tibetan Studies at Namgyal Institute of Buddhist and Tibetan Studies, Gangtok, Sikkim from 2019 to 2023. Please, Professor Gangnigi, kindly proceed.
Thank you. It's a good afternoon. Without going to detail, no, I just straight go with this presentation. So this time topic is being assigned to us. As quantum objects, subtle and gross matter in Buddhist philosophy. When it comes to Buddhist philosophy, normally we talked about these two things. When the ontological concern comes on, when there's a matter and the mind, where it is a gross, subtle, or whether it is a ultimate or conventional. So they all are almost not other. No. I will quote one shlok from the Shunyata Saptati, where it says, Utpad Sthiti Bhang Asti Nasti Heen Samottamam Lokik Vyavara Tu Buddhen Ukta Na Tattva. So all these things, whether it is a Buddha has talked about the duration, origination, destruction, being, non-being, existing, non-existing means, and the low, moderate, and the excellent are free from worldly conviction. Buddha has not spoken it in the absolute sense. There are other texts which is very important, which I would like to mention it here, is that the Sandhi Nirmochana Sutra, in which the first, second, and third chapter deals with this ultimate reality as such. Wherein ultimately they say, what are those 5 characteristics? Even then the Asanga has mentioned into his texts, which is the 5 characteristics of the ultimate Paramarth Lakshana, inexpressible, non-dual. This transcends the argumentations, completely transcend the differences and non-differences. Then it is in everywhere with the one taste. This is the question of what one taste means. As in the 4 characters we talk about that, Nirvanam Param Shantam. Cessation of the suffering is the absolute reality. That means that in every state, this peace and the shamanona, that is the main objective of the Buddhist studies. So when we talk about the matter in the mind, matter is an ontologically, we know about that. It exists. And it is the 5 senses through that we see it. And as elaborately these 4 key speakers has spoken, the 2 distinguished scholars from Buddhist side and the 2 great distinguished scholars from the physicist side, they have amply and lucidly in terse manner, they have explained their point of view. Therefore, further we have 3 scholars, distinguished scholars, erudite scholars. They are distinguished in their own field. First, my right side, Dr. Pooja Dabral, now Reverend Pooja Dabral, and she is the distinguished scholar of Buddhist studies, especially Nagarjuna's philosophy. So I don't say much about that, her accomplishment and all these things, but she will present her paper. And the left side is the Professor R. Ramanathan from the University of Physics. He is a hardcore physicist. And in the corner side, we have the great scholar who is the Abhishek Manji. He is a mathematician as well as a physicist. So this time we have 1 Buddhist scholar and 2 physicists. I hope their presentation will benefit you, and we have been given the 10 minutes time. So within 10 minutes, I wish they should complete their presentations. And last, then the 15 minutes is assigned to the question hour session. So the young scholars and those who want to ask questions, please prepare the straight away questions, not having introduction, giving first their own introduction, ask question, pinpointed question. Okay, no explanation, nothing as such, making a preliminary remarks kind of thing. So with this, I don't spend much time now. We are already late by almost half an hour now. So we'll try to finish within the given time. I will request Professor R. Ramanathan, who is a retired professor from the university. So they have introduction is being given here now. In the brochure also it is given. So I'm not reading outside. Don't I, sir? So I will straight request him to give us his own viewpoint on this subject. Professor R. Ramanathan.
So, namaste to all my venerable friends and other friends. I'll be talking on a philosophical formulation which is there for quite since maybe in a very rudimentary form from very ancient times, but it has been, made more concrete in the last century. It's about what is known as not changing. Is it how to focus this on that?
This is on this.
Yeah. Next, this one.
So you change to this, that will go.
Okay. So, I'll be talking about panpsychism is a philosophical position adopted by generations of scientists and philosophers who claim that mind and matter are not two different and separate features of existence, but are a dual which exists in unison in all universe. In this presentation, I will elucidate on the idea and show how this offers an elegant model to resolve the mind-matter paradox. So, in the Sutta Nipata or the Pali Canon, there is a dialogue between the Buddha and his disciple. Of course, I read it many years ago, maybe 50 years ago when I was a student, but only from memory I'm telling you. I have not read it recently. In the Sutta Nipata of the Pali Canon, there is a dialogue between the Buddha and his disciple, the Venerable Malankaputta, where Malankaputta asks the Tathagata to tell him whether God exists or not, the soul exists or not, the life after death exists or not, to which the Buddha says that it is futile to know the answer. Better to utilize our lives to seek the path towards nirvana. Similar position is adopted by the Austrian logician and philosopher Ludwig Wittgenstein, wrote a very influential book which is the basis of modern linguistics and symbolic logic in the last century, who says in his book Tractatus Logico-Philosophicus, that was the name of the book, there he says, similar to what the Tathagata told his disciple Malankaputta, whereof we cannot speak, thereof we must remain silent. So it is So with that admonition of two great, or a very great Tathagata and a great logician, Ludwig Wittgenstein, I must say that we have to tread this area with great caution. Our perception of our existence and our basic awareness of ourself and the outer world is due to the consciousness we are endowed with from the time of our arrival in the world in our mother's womb. What could be its source? Is it unique to us, or is it a universal phenomenon? Is the answer to this an unspeakable one, the way Wittgenstein says? Many have asked these questions over the ages. The well-known physicist, late Freeman Dyson was one of the architects of the discipline of quantum electrodynamics. He, along with Feynman, Schwinger, and Tominaga, they constructed the theory of electrodynamics, quantum electrodynamics. And incidentally, Professor Freeman Dyson is the guru of my guru. Because my PhD supervisor, Professor A.N. Mitra, who passed away 2 years ago, his PhD supervisor in Cornell was Professor Dyson. And he has written he was a multifaceted genius, and he has published many books on philosophy of science. In one of these books, which is named Disturbing the Universe, that's the book, there in the introduction he says, the process of human consciousness differs only in degree, but not in kind, from the processes of choice between quantum states, which we call chance, when made by an electron. Quantum chance is better framed as quantum choice. Actually, you attribute the idea of choice only to sentient beings like human beings. But he says that the way the quantum is seen to behave, the electron is seen to behave in quantum electrodynamics is not very different from how we behave in acquiring knowledge about the external world. Only it's a matter of degree. The physicist David Bohm, in an earlier book, says the ability of form to be active is the most characteristic feature of mind. And we have something that is mind-like already with the electron. The English philosopher Alfred North Whitehead also wrote a book early in the last century, which is also called Tractatus Philosophicus. Also gave a detailed thesis on the pervasiveness of consciousness in all the universe, starting from the electron in his book, Science and the Modern World. The main problem arises from the dominant belief that matter and mind are two separate essences of existence. The animate and the inanimate are totally different in all aspects. This is partly due to the dominant Aristotelian separation of mind and matter that has influenced thought over the past 2 millennia. The 17th century German mathematician and philosopher Leibniz tried to solve this by postulating a mind-matter dual, which is called a monad, as being the base of all phenomenal world. He was perhaps one of the first panpsychic philosophers who tried to put it in a very logical scheme. In the Indic philosophical discourse of all Vedantic, Buddhist, and Jain schools of thought, matter was always conceived as some kind of projection of the mind. Though the connection was never clearly made, one could, however, with hindsight, view it as a panpsychic philosophical position. Our consciousness not only makes us aware, but also gives us the discrimination to sense information, which is possible only if there is a choice to be made, for which the prerequisite is the existence of a dual, a this and a that, a yes or a no, a 0 or 1, a Boolean doublet. This is a Boolean doublet. So it is possible that a complex discriminating consciousness could be built from a primordial rudimentary consciousness at the level of elementary matter. When the electron interacts with another electron through the quantum field, it makes a choice which a physicist calls a probability of interaction. As the physicist Dyson pointed out, this has all the features of a choice made by us in a more complex interaction. It is the quantum nature of the interaction that makes it possible to interpret the interaction of an electron as a choice. Otherwise, it would be a certain interaction with no choice involved. Choice making is what you call free will. But this aspect has been brought into being only because of the quantum nature of the elementary particles. This diagram is what is called Feynman diagram. This shows the black lines show the E represents the electron. This is just a diagrammatic, picturization of a real event of which we, as Professor Dandula said, we just can only picturize what could be happening at a microscopic level. We do not know what is actually happening there. But this picturization gives you what the electrodynamist Feynman, he invented this diagram. The two electrons interact through a gamma, which is a representation of the field photon. Now this is just a picturization. This is what one electron interacts with another electron by throwing out a photon. What is the basic mechanism by which a gamma photon is thrown out by an electron and it feels another photon, another electron? That is not known. But what this comes about because of the idea of a field concept. The field is a infinitely extended sea or ocean of what are called harmonic oscillators, and each oscillator for different fields has different kinds of oscillations. And basically these are the oscillations which come out of the field, and once actualization occurs, the photon becomes a particle. The quanta becomes a particle. That is how the field concept is introduced. Now the electron is bristling with field photons, and it is through those field photons it is able to see whether there is another electron or not in its vicinity. So this is the field picture. But actually that is how we also find out whether the external world exists or not. When we touch this table, we are doing it, the actual process is a electromechanical process. The electrons in our tissues, it touches the electrons in the body of this object, and they repel each other, and that repulsion is being transmitted through neurotransmitters to the brain, and we see the touch. And we are bristling with all kinds of fields, and it is just concentrated in because our senses are so gross, we cannot see that our bristling fields extend far above, beyond our bodies. But the concentration is limited to, in our visual field, it is limited to this body. So we are trillions of, cells gathered together. We continually amass material from the external world and also leave out material to the external world. So this is an organic system which continuously changes its content, but it remains the same as a whole as far as our, short-term perception goes. But we are all the time changing our content, and and all the material that has been amassed in our body was many, many billions of years ago in the core of some star. So we are also having the same, we feel the external world only through the same mechanism with which the electron also feels the existence of a neighboring electron. It's not different. But when the elementary particles are gathered in large numbers, in terms of atoms and elements and then cells and all that, the configuration makes its own, circuits, which result in a more complex kind of sensation. So that is the basis of the panpsychic hypothesis. In the scientific worldview today, we are an organism built out of the gross matter of the universe, and our consciousness and mind are an emergent phenomena arising from the assembly of atoms with their electrons in our bodies. From the information gleaned from the external world by science so far, it seems plausible that the panpsychic hypothesis is at the base of a conscious universe arising out of a quantum field, which seems to be the source of our consciousness at the primordial level. You may call it the shunyata of Nagarjuna, or just a field which is both material and conscious. There are groups of scientists around the world trying to devise experiments to test the panpsychic hypothesis, and hopefully it may emerge from a philosophical hypothesis to a scientific one in the near future. Thank you.
Thank you so much, Professor Ramanathanji. He has put together with matter and mind in Buddhist terminology, Nam and Ru, Ming and Zuk, how the one is ontological part, other is the epistemological part, and beautifully webbed and make it simplest possible way to make such as Buddhist scholars to understand about it. Thank you so much for making this presentation so much. It was so simple, easier. So in this regard, I use small quote now. Again, referring it to the Sandhi Nirmochana, where we should Mati ask the Buddha. Buddha replied, I have realized the ultimate, which is subtle, extremely subtle, profound, extremely profound, and difficult to realize, which is a character that completely transcends difference and non-difference. Probably what Professor wanted to say about that now. Thank you so much for making this so simple and easier. Now I will request Venerable Dr. Pooja Devralji. She will make her presentation, not giving much introduction about her. It's already given there. So saving the time, please go ahead with your presentation.
Thank you, sir. Okay, I would like to start by quoting Acharya Thiknak, who is also renowned as father of Buddhist logic. So in his text Pramana Samuchaya, the verse goes like this. Pramana bhutai jagat hiteshine pranamya shakhe sugatai tayane. So in these two lines in English it reads as the one who has transformed into the reliable guide, motivated by altruism to benefit sentient beings, the teacher Sugata and protector, to you I make prostrations. So in these two lines, Acharya Thiknak encapsulates the entire transformation of Prince Siddhartha into a fully awakened one, which is also known as a state of complete cessation of suffering and infinite bliss and peace. So, and then as my presentation goes, we'll see that in many of the sutras, Buddha taught about the matter and particles and the physical form. And then the purpose is indicated in these two lines, that finally the purpose of all the Buddha's teaching is twofold, which is to attain the state of complete cessation of fears or suffering and attainment of a state of infinite peace and bliss, which my previous panelist explained very beautifully. So before I go into my topic, which is matter form from the perspective of Buddhist philosophy, let me start by thanking Venerable Geshe Dorje Damdula and Tibet House for always being so kind, for giving me this opportunity to share my views. And also I feel very honored to share the dais with distinguished experts in their respective fields. And also it gives me immense pleasure to present this paper in this particular panel where Professor Hirapol Gangnegiji, who I have a very long association, who accepted me first as his PhD student, then as a senior colleague, being head of the department, and also always being a kind well-wisher. So now the topic of today's talk is matter form from the perspective of Buddhist philosophy. I'm so sorry for the formatting, but as we can see, and the time is very limited, only 15 minutes, so I have to jump, but I would like to give more sources for scholars to have some comparative study. So as we can see in the Rupa Sutta, the sutra name, or sutta in Pali and sutra in Sanskrit, Buddha said, monks' forms are inconsistent, changeable, alterable. Then in Arya Vinaya Vinishya Upali Pariprachana Sutra, Buddha said, various delightful flowers blossom and the sparkling supreme golden abode stands so alluring. For none of these is there a creator. They are posited by the power of thought. It is through conceptualization that the world is imputed. And also in Dhammapad, which is the collection of Buddha's words in Buddha's sutras in verse form, Buddha said, all forms are unreal. One who knows and sees become passive in pain. This is the way that leads to purity. So finally, this extensive explanation of the form, matter, and what constitutes the form is to attain the purity, which is, as I said, and the previous great teachers and scholars mentioned that the purpose is to attain the state of cessation of suffering and happiness. Now, before I go to the topic, let me just give you a broad perspective of where this topic lies. So as we know, anything that exists is known as phenomena. And then there are different ways of classifying phenomena. In fact, in many of the Buddhist sutras and later commentaries, there are different ways of classifying. One way is, as it comes in, the Buddhist scholars would know, the entire Abhidhamma Pitak has 7 texts. And one of the texts, Dhamma Sangani, you will see the presentation of, and also in Acharya Buddha Ghosh, Vishuddhi Mak, as well as in Acharya Vashubandhu's Abhidhamma Ghosh, you will see how the phenomena are divided into 2 major categories. The phenomena in Pali they call Rupa Dhamma and Arupa Dhamma, in Sanskrit Rupa Dharma and Arupa Dharma. And the distinction is the forms or the phenomena, the form that have some physical matter, whereas those phenomena which do not have physical matter. So from this we have to learn that whatever we experience around us does not only confine to the physical matter. There are phenomena or things which do not have any physical matter. Then another very interesting way of classifying phenomena is into 2, impermanent phenomena and permanent phenomena. And impermanent phenomena means the phenomena that undergo change, can further be classified under 3. form, mind and mental factors, and non-associated compositional factors. So the category which I'm going to speak on is the form, whereas we have the category of phenomena which are not form but do exist, such as mind and mental factor, all the mental experiences. Then the non-associated compositional factor, which is a very interesting category. It simply means those impermanent phenomena which does not belong to form and mind. For example, the self, the person, time, and many other. Okay, now the form. So how form is defined in Buddhist treatises, in sutras, as well as many commentaries. So I picked up the definition from Acharya Chandrakirti, who is a great 7th century Nalanda master. In his text, in his well-known formulation by the name Madhyamika Avatar, the entry into the middle way, which talks about the Shunyata extensively, he defined the form as such. Form possesses the characteristics of that capable of materiality, and those who are from the Buddhist philosophy side, they know sometimes it is defined as form is something which is suitable as a form. So then what is the meaning of something being capable of materiality or suitable as a form? So this explanation comes in further commentaries, such as in Acharya Vasubandhu's Abhidharma Kosh. So he explains that capable of materiality means something which is capable of being induced to change when it comes in contact with different particles. So now, in simple terms, the form means something that is constituted of particles, and also we can say that something that is constituted of material substance in a very simple language. Now, this form can further be classified under two major categories. Again, there are different ways of classifying form. One very comprehensive way of classifying matter is into the four great elements, the elementary elements, and then those that are derived from these elements known as element derivative. In Sanskrit, Mahabhut and Upadaya. And these are the sources that I cited where you can find this, where does this come from Buddhist treatises. For example, Dhammasangani, one of the major texts from the 7 texts of the Abhidhamma Pitaka, and also in Acharya Buddha Ghosh Vishuddhimagga, you will find this classification of form in two categories, primary element and the mental derivatives. So now I'll quickly go through them because the previous panelists already mentioned about them, that primary elements are the 4, earth, water, fire, wind, and these are the ultimate constituents of all the physical world that we experience. And then, okay, so if somebody wants to know where in sutras these 4 elements are taught, and then in many sutras, Sanskrit, Pali sutras, you will find where Buddha taught these 4 elements and their function, nature, and how they come together to make the macroscopic world in detail. Some of the sutras, Mahati Padopamam Sutta, then also in Pragyaparamita Sutra in 25,000 lines, and also in Mahasatipatthana Sutta. So these are the 4 elements and their essential nature and functions as explained in Buddhist scriptures. So we can see that they are becoming progressively subtler: earth, water, fire, and wind. And then the essential nature of earth is to give some solidity to the object, and then function is to support. Water to moisten, and function is to bind. Fire to have the warmth, and function is to mature the object. And then wind element, the essential nature is lightness, and mobility is the function. Okay, and then when these elements, these 4 great elements, they come together in different configuration, then the element derivatives come into being. So whatever physical that we experience around us, as we discussed in the part of the inaugural session, there are different kinds. For example, the objects of the 5 senses, the object of the 5 sensory consciousnesses, such as visual objects, sound, smell, taste, tactile objects, as well as the 5 sense powers, the mediums through which we experience these objects. These are also physical matter. And besides this, there are something called, although they are the objects they are known as mental objects, but they have a very subtle physical form known as non-revealing form, and also the form that one acquires through meditative concentrations. So they are all physical forms and are derived from the 4 great elements. And then to the question, as I mentioned, that how the macroscopic world comes into being from these 4 great elements. In many of the sutras, such as Lalita Vistar Sutra, in English, Extensive Display Sutra, and as well as Acharya Vasubandhu's Abhidharma Kosh, there is a mention of the principle of agglomeration of particles. also known as atomic agglomeration. And there it explained how these different particles, they come into being in different configuration, and then the macroscopic objects come into being. And then in these sutras, I'm not going to read because it will take time, but there are many interesting specifications, such as the size of a sunray particle, size of a dust particle, size of snow particle are being described. So finally, what I find very interesting to share here, that all Buddhist schools, as the Venerable Geshe Nawang Samtela mentioned in his inaugural speech, that there are 4 major schools of Buddhist metaphysics, Vaibhashika, Sautantrika, Chittamatra, and Madhyamika school. So they have their own unique presentation of what is the matter and particle, and how this material substance is presented in their philosophy. So now when it comes to the particle, so what's to school, Vaibhashika and Sautantrika, also known as foundational Buddhist schools, they accept that finally all the physical world, all the physical matter is reducible to the most fundamental, irreducible constituents, which they call partless particles. So this comes from Acharya Vasubandhu's Abhidharma Ghosh, where it says, a partless particle, a syllable, and a single moment are the smallest unit of matter, of word, and of time, respectively. So in simple terms, Vaibhashika and Sautantrika school, they believe in a particle which is partless in nature. And this is the ultimate constituent of all the macroscopic physical objects. So what is the nature of such a particle? This comes in many commentaries, and one of the very renowned work known as Mahavibhasha, attributed to Katnayaniputra, and this explanation comes. In fact, this is a very important text which summarizes the essential subject matter of the 7th text of the Abhidharmapita. Here he explains that this partless particle is the finest or smallest constituent of matter. It has no spatial dimension, means it has no parts in space. It never exists on its own, but only in combination of other particles. And it consists of at least 8 substances. What are they? The 4 great elements and the 4 element derivative, form, smell, taste, and tangibility. So now this is the presentation. That was the acceptance of the partless particles, means a particle which does not have any further parts is something confined to the first 2 Buddhist schools, also known as foundational Buddhist schools, Vaibhashika and Sautantrika. Whereas when we come to the higher Buddhist schools, and as you know, when we say higher Buddhist school, it doesn't mean that they are higher in any other reason, but the reason is that they present the most subtle and a very profound ontological reality. So the 2 higher Buddhist schools, Chittamatra and Madhyamika, they refute the existence of such a partless particle. They accept that the physical objects are composed of particles, but they do not accept the existence of a partless particle. And then where is that formulation where that has been rejected? So there are many Buddhist texts. For example, Acharya Arya Deva's 400 verses, Chatushtaka Shastra Karika, and also in Acharya Vasubandhu's well-known text, Vimshika, in English 20 stanzas. There is one verse where he uses a logical assertion to explain that how such a partless particle is not possible. So I'll read it for everyone here. Because of being simultaneously surrounded by 6 other particles, the central subtle particle is found to have 6 parts. If these 6 parts have the same spatial dimension, a massive object will conflate into a size of just a minute particle. So what Acharya Vasubandhu is arguing here is that however minute a particle is, should have parts. In other words, there is no partless particle. And then he says that if that is not accepted, we cannot really account for the macroscopic world. So what is the reason behind it? Because he says that let's say even any object, physical object such as this mic, this is constituted of particles when we go at the elementary, at the subtler level. And then this pool of particles, so any particle that you pick up must be surrounded by several other particles. So let's say 6 other particles, and why 6? Because 4 in 4 cardinal direction, 1 above, 1 down. So then this 6, if we say that this central particle does not have part, then the side of this central particle, which, okay, we can use this diagram. This does not come from the text, but I used to explain it. So central particle, if it does not have any part, if we accept that, that reason, then the side of the central particle which faces or which meets the particle in the north should be the side which faces the particle in the south. So then the particle in the north and particle in the south, they two will meet. And if they two will meet, then the central particle will disappear. If that is accepted, then all the particle will keep on conflating and disappearing. And then one cannot account for a massive object such as a mountain. So he's explained that we make a distinction between a mountain and a flower on the basis of the size. But if the particles of the mountain, they keep on conflating into each other, we cannot account for a massive object like mountain. So therefore, he explains that however minute a particle is, it should have six parts, at least 6 parts within. So this is the presentation accepted by the higher schools like Chittamatra and Madhyamika, who do not accept the partless particle. But do they reject particle? The answer is no. They accept that the physical objects, they are made up of particles, but these particles have further parts. Okay, so now coming to the Chittamatra school. So the foundational philosophy of Chittamatra, as it is taught by Buddha Shakyamuni in Dashabhumi Sutra, Sutra of the 10 Bhumis, it says, it is thus, this world of 3 realms is mind only. So their foundational philosophy is that everything is the nature of mind. That's why the school is called Chittamatra, the mind only school. So when this school presents the philosophy that everything is the nature of the mind, and when they ask that what is their take on physical particles or the physical objects, then within the Chittamatra school, the scholars differ. The part of the Chittamatra scholars, they maintain that since everything is just the nature of mind and nothing exists external to the mind, and it is only due to ignorance that we see things external to the mind, finally, physical objects do not have any physical substance, or they are not constituted of physical particles. They are just the nature of mind. Whereas the other part of Chittamatra scholars, they maintain that no, there is no contradiction in accepting the physical objects having particles, made up of particles. At the same time, having the nature of as the nature of mind. So they maintain that physical objects, they are composed of physical particles. At the same time, they are the nature of the mind. Then coming to the Madhyamika school, and within Madhyamika school, because the limitation of the time, I'll confine to the Prasangika Madhyamika. So these are coming from the Arya Vinaya Vinishya Upali Pariprashana Sutra, where Buddha clearly mentioned in dependence on light, the eye sees visual forms, both pleasing and unpleasant. Since it sees depending on the right condition, the eye in fact never sees anything intrinsically. Pleasant sound that are heard never actually enter the ear. Their entry is not observable. Sound occurs through the force of concepts. In short, all these phenomena have explained using words to label through mental conceptualization and account for them. So in this, we might get confused that do Prasangikas, the highest Buddhist school, do they accept physical matter or not? The answer is yes, they accept physical matter, and they accept that physical objects are made up of particles. But when it comes to the nature, the true, ultimate or ontological nature of these physical matter, even the visual forms, they do not have any intrinsic nature, or they do not exist from the object side. So the general understanding, in a very vernacular sense, when we talk about the substance in the conventional world, we think of something which exists from the object and not by the subject. So when it comes to this understanding of substance, this school is very unique in terms of rejecting the substance which is purely existing from the object. So the school, Madhyamika school, particularly Prasangika Madhyamika, they deny the objectivity at all degrees, at all level, and therefore they deny the particles, the material objects to have any intrinsic substance or intrinsic nature. So therefore, here, if you really want to understand how Madhyamika explains, or particularly Prasangika Madhyamika, they explain that the particles are composed of, the physical matter is composed of particles. At the same time, these particles have no intrinsic nature or objective nature. One has to understand the presentation of the two truths, how the conventional, all the particles, be it gross physical objects such as this mic, this hall, this podium, or the elementary particles like, electrons, protons, neutrons, when we do not analyze them through ultimate analysis, going deeper into analysis, through closer inspection, we'll continue to see their conventional nature, which I explained and accepted by all the Buddhist schools, that they are impermanent in nature, they have specific mass, charge, spin, but when it comes to their ontological reality or ultimate nature, this school confines that, okay, when you analyze them, going through closer inspection, then you realize that, okay, none of these particles, be grosser physical objects or the elementary particles, they do not have any intrinsic nature, or they do not exist objectively, but they are purely existent, they exist purely through mental projection. So this is the Madhyamika school. And then not only sutra system, but also in the tantric treatises, in Buddhist tantric treatises such as Sri Kala Chakra Tantra, there is an extensive explanation of the form, and particularly very subtle form, where they explain the existence of the space particles, on which basis they explain the destruction of a universe, and also it's coming after coming into being through space particle giving rise to grosser particles. Okay, and then so finally the conclusion from my presentation is that within the Buddhist schools, there are four major Buddhist schools of metaphysics: Vaibhashika, Sautantrika, Chittamatra, and Madhyamika. So Vaibhashika, so when it comes to talking about the material substance or the particles in terms of something constituted of physical matter or particles, this is fairly accepted by all the Buddhist schools. Whereas when it comes to the material substance, understanding of the material substance in the context of something as external to the perceiving mind and not being the nature of mind, this is something which the Chittamatra school of Buddhism does not accept, because they maintain that everything is the nature of mind. And then when it comes to understanding of the material substance in a very vernacular sense to mean something from the object and not projected by mind, this is something not accepted by the Prasangika school, Prasangika Madhyamika school. So with this, I conclude. Thank you very much.
Thank you, Poojaji. So thank you so much for making this presentation so interesting, and you have surveyed from the gamut of the Buddhist onto a metaphysical standpoint, coming down to even the Vajrayana Buddhism, Tantric Buddhism, and such. But here, since he has quoted this thing, I will also quote that in the Guhe Samaja, it says, Sarv Bhav Vegatam, Sakand Dhatu Ayatana, Graha Graha Gvarjitam, Dharam Niratame Samtaya, Swachit Adya Upannam, Shunyata Swabhavam Iti. This is something, it's all those phenomenal things, existence of those. And the second dhatu ayatan means objective, and this base of objective, and the grasp and grasper. And because of this dharam niratamya, substancelessness of the phenomenal thing, all things are being seen. Probably as such, Professor was trying to say how the particles and touching with this, how they interact with them. Because dharam niratamya samta means all things I know it's substantive. So therefore all are the same. So swachit adyatpannam means oneself is primordial. Then this is the nature of the shunyata. Shunyata gives ample space, as our the key speakers have very elaborately stated about this thing. Thank you so much, Poojaji. You have made it so clear about this, giving all the four tradition of these Buddhist studies, what they think about this ontological and epistemological viewpoint. Thank you so much. And with this, I don't spend much time, and straight away go to our third scholars, who is erudite scholar in his own field, who is, as I said, is a mathematician as well as the physicist. He will make his presentation. Without spending much time, please make a presentation. Dr. Abhishek Naji.
How to make it full screen?
This is full screen.
So can I change the slide?
Yeah.
Hello everybody. Thank you to the coordinators for welcoming me here, inviting me, and giving the opportunity to talk here. So let me directly go to my slides and save some time. Is time completely relative in relativity? Okay, so this is the topic of today's talk. The talk is very short and I'm going to finish within 10 minutes, I think. Okay, so this is just a prelude to what I'm going to talk about. We have been discussing today a lot about this matter and time, which is the theme of this conference. But if you see physics, which is my background, in 1905, a paradigm shift came into physics. So before that, there was only one concept of time which was practiced in physics, and that is known as the Newtonian physics, or that started from Galileo as well. That is, time is same for all. Okay, so that's what I'm going to talk about. That's what I'm going to tell as absolute time here. And in 1905, Einstein came in and he changed the perspective. There were other scientists as well, like Lorentz and Poincaré, but I'll talk about Einstein only. So what are these formulas? Let me not go into the details of these mathematical formulas, but it is just a presentation of what I said in words. So if there are two inertial observers, that is you and me, moving with a relative constant velocity, so that is a pair of inertial observers, then before 1905, the mathematical formula was T prime equals to T. And then what Einstein gave was this following: T prime equals to T by root over of 1 minus V square by C square. So now you can clearly categorize time into two types, that is absolute time and relative time. One is pre-1905 and one is post-1905. And the general conception is either time is absolute or time is relative, as taught in physics. So the question arises, and that is what I'm going to analyze: is Einstein's reasoning completely free from the use of absolute time? Okay. So, well, you don't need to read through all this. This is just to convince you that I'm not bluffing around here. This is an excerpt exactly from the English translation of Einstein's 1905 paper on the electrodynamics of moving bodies. And here, this is the relevant expert which I took, where he talked about time and explained it in terms of simultaneous events. That is, if you say that Abhishek is speaking on the dais right now, and the talk started at 12:15 p.m., then you must be comparing my presence here and the cognition of the time in your watch. So this is what Einstein called as simultaneous events. I'm going to visualize all this through pictures, okay? But let me just go through one of these things. And then he explained that, okay, so when we are far away from each other, for example, I am now in Delhi and my family is in Kolkata, then how can they know that I am talking here at this time? Then we have to communicate through some signal. That's what we do through phones. Okay, so here we are going to talk about light signals. At that time, there was no phone. So, okay, so, but the most important thing is that while comparing things, we need to synchronize our clocks first. Otherwise, there is no point of talking about time. Okay, so this excerpt which you are seeing, it is about the definition of synchronous clocks, which was given in the introductory section. This excerpt is from the introductory section of Einstein's article. And while defining these synchronous clocks, Einstein concluded with this sentence written in purple: we assume that this definition of synchronism is free from contradictions. So while I was teaching in ISI in the last few years, I used to teach special relativity. So this bothered me a lot. So why did he need to assume that there are no contradictions? Okay, if there is none. So certainly there are some contradictions. But if there are those contradictions, what are those? Because those are not written in any textbooks. And this you must trust me. You can open any textbook, the standard textbooks of special relativity, they don't explain those things. So I had to go into Einstein's paper and analyze that. So this is the analysis in the next two slides, which I'm going to do for you. This is just the visualization of what was written in that dirty excerpt. Okay, so at first Einstein started like this. So the concept of time arises for an observer from simultaneous events, as I explained. So occurring in immediate proximity. Okay, so that is what I said, that we can talk about simultaneous clocks here or synchronous clocks, but far away from here we can't talk about it. So this is Einstein's explanation. So suppose the train arrives at the station and the position of the hands in our clock, it points to the 7 o'clock, for example. So we say that the train arrived at 7 o'clock. But a lot of processes are going in here. Okay, I have to look at the clock, I have to look at the train. So there is a time spent there. So there is a sense of uncertainty going on here. Okay, so what Einstein did was that he approximated this whole concept, which is happening within a region and it itself taking a lot of time. He approximated this as a point, okay, a region to a point, and that is what we see in Google Maps when we actually zoom in and zoom out. That's what we do. It's scale dependence of phenomena. So what he did was that he approximated this as a region, the region as a point, say P, and associated with this point an observer OP, a clock CP, whatever clock you are wearing or holding, and then a concept of time P time. Okay, that is for each one of us personally we have a concept of time which you determine by watching our clock, and suppose the ant is crawling on your table. So at this point of time the ant is here, at this point of time ant is here. Okay, so this is your sense of time which is given in your proximity. Now what Einstein did was that he introduced two observers who are now at far away places. So this is an example I have given here so that you can understand in terms of numbers. So a region which is approximated as a point A, which contains an observer OA, a clock CA, and let us name that personal time or exclusive time for that observer as A time. Okay, and suppose this observer OA holds a light source like a torch or a laser pointer. Okay, and then there is another point B, which is again in a different region, which is very far away from A. But there is an observer B holding a clock CB, and the time which observer B has is B time. And this observer B has a light reflector and at the same time a light detector, that when light comes it can detect. Then Einstein made another assumption. CA resembles CB. So I already assume that the clock which you are holding, it resembles mine. Okay. And then he said A time and B time incomparable without further assumption. Okay. Now my question is, who compares or knows this resemblance and these assertions like it is incomparable or not? Okay. Then he goes on and says, okay, let us assume now that there is a common time for OA and OB, which I am naming we time for convenience. So again the question, who is we, if you take my name, or slash, what is common? Because just now I have said that we can't compare A time and B time. Well, Einstein has said it. So that's why these questions have come. So now then he performed an imaginary physical experiment. These are his words, imaginary and physical. It was written like that. So perform imaginary and physical experiment. And what is that? So suppose at A time TA, the observer at A throws away some light or light quantum or whatever you say, or puts on his torch. So the light goes and travels to B, and at B the observer receives that light at the B time TB. Why I am saying A time B time? Because B does not know when A has put his switched on his torch. Okay. So at that B time TB, the light is also reflected and it comes back and it is received by observer A again at TA prime. Sorry, this should be T prime A in the picture. There is a mistake. And then with this experiment, now Einstein assumed the following. That is, this we time or the common time which he assumed, this is now equated to these personal times which are not comparable. That is delta T we A to B, that is the time taken by light for traveling from point A to point B, it is equals to TB minus TA. Okay, and for the time taken by light for coming back from B to A is delta T UI, B to A equals to T prime A minus TB. So now there are two remarks which I have added, and these are the curiosities, of course, that incomparable A time and B time compared by assumption. Okay, and then common time, that is delta T UI, these are related to these exclusive or personal times. Okay, because these calculation can't be done by either OA or OB, because it is impossible for them to know what each other is doing, either of them. So then he defined what is meant by synchronous clocks, which we trivially take as an assumption that we know what is there in your clock and what is going on. And the synchronous clock's definition is that CA and CB are synchronous if and only if this delta T UI A to B equals to delta T UI B to A. That is, the time light takes for going to A to B is the same for the light to come back from B to A. And that is given now in terms of these personal times, or which are exclusively known in, by A and B. That is TB minus TA equals to T prime A minus TB. Then finally he concluded with this assumption that we assume that this definition of synchronism is free from contradictions. So I think this reveals Einstein's awareness of the contradictions, but the question is why we should say that these are contradictions. Why don't we categorize and admit that time is neither relative nor not relative or absolute? It is somewhere in the middle. We can't assert to a particular and fixed permanent logical statement that this is that and this is finished, it is absolute. It's not like that. It is somewhere in between. So, and this goes on as well for we. The self is neither personal nor impersonal, and that is what we always talk in Eastern philosophy. So these were my observations, and I think I have tried to make it as clear as possible with this short talk. So this is my take from my zero knowledge on Buddhism. I am not a philosopher, but whatever I have done and read, so this is my conclusion. The middle way asserts an assertion can be true or either true or false. Neither true nor false, both true and false. So similarly, we can conclude from these observations that what we mean by we can be either OA or OB, neither OA nor OB, both OA and OB. It's already done. And finally, time can be either relative or exclusive or local. This is a very particular term which is used in quantum physics, but whatever I have discussed, it has nothing to do with quantum mechanics. This is just experience and, if I may say, self-inquiry, that what I mean by, okay, so what I say. And of course, yeah, relative or it can be absolute, common, global, neither relative nor absolute, both relative and absolute. And since there is no conclusion, as you can see, my humble reasoning is empty of itself. So, thank you.
Thank you so much, Dr. Maji ji, Abhishek ji. You have made it so simple. कहाँ चले गए? अच्छा इधर हैं. इतना simple बनाया आपने. Even I don't know anything about this physics or quantum physics, but you made it so simple. Whatever you talked about that. The issue is that now whether the ultimate and the conventional reality or truth is relative or ultimate is as an absolute. What is discussing with the Puja ji. But if it is the absolute, what you call ultimate is, then it is depending upon the conventional reality. So how that can be absolute? If it is not absolute, then we need to have something in between position. So is that something, which can say that it is because absolute and this relative are related to each other and they have been something, same in nature when you talk about that, because it's subject to the consciousness. If it is so, then this ultimately this Mayan text says they have to transcend about even the conventional and ultimate reality as such. You have to transcend that. After transcending, what will you going to gain it in? That is something which is suchness as such. because suchness is a common thing which is going to link between the conventional reality and ultimate reality. So this has to be realized, as I said, referred earlier. No? Dharam niratamya samte. Because all the phenomenal things are having the same nature. If it is same nature, means that whatever you have in nature, ultimate sense, in the sense last. So the material thing is also having the same kind of thing. Yes, why not we can put together and ultimate with cessation. Okay, sorry, time is so short now, it has gone. Question hour is very important in Buddhism because Nalanda tradition is based exclusively on the question hour session. Buddhist teaching is also about the questions hour. If you go to the Buddhist texts, literary texts now, you can see Bodhisattva was asking question, Buddha is responding. All are in question hour sessions. So therefore, now, good student means who have a curiosity, who ask the pariprashna, ask the question and counter questions. So I request the young scholars to make their query straight. I'm told that there's only 2 questions we can have it. So who will decide these 2 questions? So please, any 2 questions? Simple and straight. कैसा बताऊं आप मैं? This is very difficult question. हाँ जी? Sir, that's actually this question hour session is exclusively designed for the young scholars. We would love to listen to you. Yes. पहले किसने उठाया? First, ladies first. One lady is out backside.
Always ladies first.
Yes.
Greetings everyone, my name is Jikmet and I'm a third year student from forensic background, forensic physics actually. So my question is to Dr. Pooja. You explained it very well, ma'am, thank you. But you mentioned about this non-associated compositional factors. Like I wanted to relate it with what Geshe Damdula had said, that he mentioned that form is not other than emptiness and emptiness is not other than form. So I wanted to relate to that. Thank you.
पूजा जी वही खड़े हो जाओ ना यहाँ ये लो यही करना नहीं
Thank you for this question. It's a beautiful question, and I'm very glad that you noticed that part, which I did very fast. So yes, so let me put it technically first. So non-associated compositional factor, if you can go to the slide back, it is a part of the impermanent phenomena. So, and as I explained, why it is called non-associated compositional factor. Compositional factor means something which is composed of particles, right? So it's impermanent phenomena. But then why non-associated? What does it mean? So it means some impermanent phenomena which is not associated with form or mind. So it's, first of all, it has to be impermanent, and secondly, which is not form and not even mind, then which category of phenomena they fall. So all those phenomena which are impermanent in nature, at the same time not physical matter and not even mental experiences, they are known as non-associated compositional factors, such as the self, person. For example, yourself, you have body, you have mind, you have form, you have mind, but you are not form and you are not mind. So what is this self like? So this is impermanent in nature because it changes. Yesterday you could be very angry, today could be very compassionate. So it's this self changes, but at the same time this is not form and not mind. It has form and mind. So what is it? This is a non-associated compositional factor. So this is one of the example. And then on the other side, Venerable Geshe-la explained from Heart Sutra, Pragyaparamita Hridaya Sutra, those 4 very popular line where it says form is empty, emptiness is form. Form is not other than emptiness, and emptiness also not other than form. So there it talks about form. Okay, so particularly, of course, the whole sutra has the emptiness of many other phenomena, even non-associated compositional factor, how these are also explained to be empty. But in this particular 4-line formulation, form it talks about the 2 truths of the form. How this form on the conventional nature, it has, or conventional truth level, it has the many attributes which we explained, and then what is its ultimate nature? If you see through the ultimate analysis, then this form is empty. And then from the same emptiness of form, which is the ultimate nature, there is a possibility that this form, because it does not have any intrinsic nature, it to have a relative nature, a nature by dependence on the projection of mind. So therefore, this talks about the 2 truths of the form, whereas that is particularly about the one category of impermanent phenomena. I hope I have answered and not confused you.
Now the second question is, आइए कहिए आप अपना नाम पहले बताइए. दो क्वेश्चन और लेते नहीं, because they are young scholar. It is meant for them, after all.
So we
If
can
we are
use,
speaking much,
yeah, we can use that in the lunch break or a tea
young
break.
people are full of questions. They should have. They should be respected. दो क्वेश्चन और लेते हैं. Lunch लेट होगा बाद में.
Yeah, so myself, Kishore.
Kishore.
Yeah, to put my question very short, basically I'm quoting a statement by J. Krishnamurti where he states that mind is time and mind is suffering, and to live within the field of time is suffering. So what is implied in this statement? Because Buddhist philosophy talks about the nature and the essence of suffering, and is it possible to go beyond suffering? So how these three aspects, mind, time, and suffering, is related? Please.
Whom you want to answer?
Any of the guest speakers,
Is anyone
or
else?
maybe anyone in the house can respond to this?
Is it? Mind, time and suffering. इसमें तो mind है तो suffering तो होगा ही. Time is the,
Why is it implied that mind is time?
mind is time.
Yeah, this was the statement because,
Buddhism में तो ऐसा नहीं है, mind is time.
yeah, sure.
It's okay. Yeah, please you identify yourself, sir. पहले अपना identify कीजिए so that people will.
Thought is time. Thought is time because thought is a material process happening in the brain cells, and it creates the psychological space in which it moves and also creates the psychological time. So without thought at the deeper level, you cannot suffer. If you are suffering, it means thought is involved, mind is involved, otherwise there is no suffering.
Is it okay? नहीं हाँ बाद में कीजिए आप, because this is very kind of a abstruse or kind of a very abstract kind of question. No answer is not so easy to give us. Anyone else? Yes, you please. एक और लेंगे हम, दो एक लेंगे एक और. Yes, please.
Ben.
Whom you want to ask question? Ramanathan ji.
Then please introduce yourself before.
My name is Ben Cantor. So my question is, from what I understood from your talk, which might not be correct, so please correct me, is that Dyson posits the pervasiveness of the mind and the matter on the basis of the quantum choice, which is similar to the free will and so forth.
Questions are question.
Huh?
Straight.
Yeah. So my question is, how can the pervasiveness of the consciousness be posited on the basis of the choice? Because the mind also has the experience. So is the experience equated to the choice of free will? And if so, then why? Thank you.
The point is whether elementary particles behavior, quantum mechanical, quantum electrodynamic behavior of an elementary particle can be whether it can be related to the kind of consciousness that we exhibit. The statement of Dyson is that the quality of consciousness of human beings is the same basically as that of a quantum mechanical electron. That is the statement. So, but our consciousness also generates, memory. As he was asking, how is without memory you can't suffer. So time and memory are related, but that is going to a higher level of consciousness. The elementary particle is not having memory. It has, but a very elementary memory. It is not big enough. For example, a computer with a bigger memory can do much more things. You see, for example, the touch screen cannot be operated on a mobile phone which was 15 years ago. because the memory of that generation mobile phone was 1,000,000 times smaller, because to go into higher levels of memory and consciousness require a much bigger, entity. But at a rudimentary level, the consciousness of an electron is of the same quality as the higher consciousness of the human being.
Thank you.
That is the claim.
So good.
So that
Partly you also got your answer to that, probably. Yes, last question. Which gentleman over there last? कौन ये सर कौन है? हाँ, वो last one.
Hello. Hello. My question to Abhishek Maji, Dr. Abhishek Maji. Does time is a human-made concept to help us understand and organize our experience?
Can you repeat the question?
Yes. Does time is a human-made concept to help us understand and organize our experience?
I think physics is human made, and if you were taking the time which I talked about there, you already showed that it's human made and how it is constructed. Yeah, so it's human made. That's the answer.
So time is exist only for human.
Well, as I am a human being, I can only talk about human beings, and if I stick to my experience, so it's human made.
Okay, thank you. Okay.
Thank you so much. Thank you so much for Ticket House for giving us this opportunity. Possibly thank you for our 4 keynote speakers whose presentation was so beneficial for us, and also 3 of our distinguished scholars who have made their presentations. Thank you so much for the people who are persons, young scholars who have asked questions. And it is not necessary you must be satisfied with the answer. कोई बात नहीं, ये सिलसिला चलते रहना चाहिए, ठीक है? But keep asking questions. अपने लिए भी औरों के लिए भी. Thank you so much for everybody.
Thank you so much.
Thank you so much.
Please remain seated, professors and speakers. Yes, please remain seated. Yeah, so thank you very much, Professor Gang Ningiji, and very generous of you to take the 4 questions and 2 more questions. and to all the speakers on the dais for your profound teachings. And now I would like to request Professor A.C. Pandiji, the chief guest of today's conference, would like to offer the kata and the sohuna to the respective chairperson and the speakers. Professor Gang Ningiji.
Thank you.
Professor R. Ramanathan ji.
Thank you.
Venerable Professor Dr. Pujala. Thank you, and Dr. Abhishek Manji. Thank you very much, Professor A.C. Pandiji. Now we will recess for a lunch, and before we recess, I would like to make a humble announcement that This morning we have inaugurated a one Tibet House publication book, which is Quantum Physics, Brain Function, Modern Science and Buddhist Philosophy, that we held in 2018. So this is for sale, and today if you would like to buy, our publication has mentioned that it is 50% concession, and it is at the reception. And the lunch is at the Jargaran Hall, which is opposite to this hall. And first we will respectfully allow the speakers and the chief guests and the guests of honor, keynote speakers, to have the lunch, and then the participant can join.
Thank you.
Thank you.
And ladies and gentlemen, one last announcement. We have a student panel discussion also, which is really exciting. So I would like all of you to kindly wait for the last session as well. And we will begin with the third session after lunch. Thank you very much.
And we will keep the 1 hour lunch break, and we will return back at 2:30. And the next session, my colleague, Mr. Tinzin Rabiang will be moderating on the second session on non-locality, quantum correlation, and philosophy of relations in Buddhist logic. Thank you.
Which one is it, sir?
This is not mine. Second is Puja.
Oh, okay.
Or they might have pasted it here.
Ah, there it is. Is this yours? VP something. Let me just take this.
Good afternoon, everyone. So we'll start our session in 2 minutes. Thank you. session. I hope you have a great lunch. I extend a warm welcome to the second session of the conference on the theme Non-locality, quantum correlation, and philosophy of relations on the Buddhist logic. I'm Tenzin Rabia, IT staff at Tibet House, and I'm honored to be your moderator. For this session, our privilege is doubled with the presence of Professor C.C. Roy-ji as our chairperson, along with our esteemed speakers, Dr. Utkarsh Mishra-ji and Venerable Keshidoji Damdula, and our Professor Atul Kumar-ji. Following their insightful presentations, there will be 15 minutes question answer session. May I now kindly request our respected chairperson and speakers to join on the stage.
Chairperson,
yes.
How much time I can speak?
Chairperson,
10 minutes. Okay. You give me one. Okay.
Thank you so much. As my colleague, Mr. Kungala, has already introduced our chairperson, Professor C.C. Roy, let me save time and take over, and let me save time and request our chairperson, Professor C.C. Roy-ji, to take over the session. Thank you.
Good afternoon. And after such a good lunch, I think most of the people might sleep here. And I would request the speakers to make it such a presentation so that they will wake up. Now, let me start the session. And we have 3 speakers. So the topic, as it is mentioned, non-locality, quantum correlations, and metaphysics of relations in Buddhist philosophy. Quantum correlations or non-locality has become a very important topic and important phenomena in understanding the behavior of microscopic entities. Basically, roughly the idea is that you take at least 2 entities, and between the 2 entities there is a kind of relations, and this relation or quantum correlation is different from what we found in classical domain or classical mechanics. Why we have clubbed together with these quantum correlations and the physics of or metaphysics of relations in Buddhist philosophy? Because apparently they seem to be a different kind of phenomena, but if you look in a deeper way, that because of non-locality there is a kind of relations between 2 entities, So, issue is that whether how far this relation is real, or this relation is real in the sense that whether they can be verified, as I told in my keynote address, experimentally. It is found that in quantum teleportation experiments, this kind of correlations or non-locality has been verified experimentally. So, in physics, we have a relation which is real, in the sense it is testable in lab experiments. Now, in Buddhist philosophy, Dharmakritti, who wrote a book called Metaphysics of the Sambandha Pariksha, or examination of the relations, and he wanted to show that in the ultimate sense, the relation is not real. It raises a lot of debates among other logicians and philosophers from different Hindu schools, Bhartahari, Utpalacharya, then even Jain scholar Prabhachandra, he also involved in this debate. So now some quantum physicists from Switzerland and some European physicists, they are also become interested from philosophical perspectives. But they don't, most of them, they told me they are not aware of Eastern traditions. They tried to analyze it from Western traditions. But in Buddhist philosophy, as I told, the Sambandha Pariksha or philosophy of relation plays a very important role. So today's session raised a very intriguing questions. On the one hand, in quantum physics, we have a relation. Relations means it has to satisfy some of the propositions. But it is real in the sense it is testable. But what? The main problem is that, as discussed by some other people, that what is ultimate reality? We physics or in science, we don't know what is ultimate reality. We have different layers of reality. One layer may be in the classical world, another layer may be in the microscopic domain or quantum world. But when we are able to say that this is the ultimate reality, and how we can reach there, whether through using causality principle, we can reach to ultimate level. We are not clear at all, and we don't know. Maybe a single debate, a big debate can be arranged that what is ultimate reality in science itself. So let me ask the speakers if they can shed some light. I mean, so that they will present in such a way that it is very important phenomena in quantum physics or microscopic domain, but it has a characteristics of relations. And then we have, of course, eminent speaker like Kesela, who might shed new light whether how far it can be compatible with Dharmakritti's idea or, other Hindu scholars. So maybe let me request Dr. Utkarsh Mishra. And I think it is already written, so I will not spend time at all. Let me request him to speak.
Oh, yeah. So, hello everyone. My name is Utkarsh and I work at the University of Delhi. And so first of all, I would like to thank the organizers and Professor Roy for giving me this chance to speak in front of all of you. And so my topic is quantum many-body sensors, and it means that we are using quantum mechanics to estimate certain physical quantities very precisely. And it is something that we sort of, it is related to estimation, which we all do in our daily life. For example, when I was coming here to this venue, I asked asked the program coordinator that how far it is. It was like, oh, it will take 1 hour or something like that. So this estimation is something that we do in our everyday life. But for more precise things, like giving a more precise value, we use physics. And physics also tell us that you can how precise you can measure it. So there's a limit of precision that we can measure certain quantities like temperature or the frequency. And this is determined by the laws of physics. This is something that I will talk about in this talk. So before that, let me just give what is the quantum metrology. So my talk is about quantum sensor, which is quantum metrology. So quantum metrology is about parameter estimation, and metrology is also science of measurement. And the ultimate limit of precision in this task are determined by physics. And the ultimate physical theory is quantum mechanics. So the ultimate limit of precision is governed by the laws of physics. So while preparing this talk, I found few sentences which I like, that the progress of human civilization in some sense is a progress of improving the precision of measurement. For example, we have become more globalized, and we use trade in which we sort of measure like how far things are, in which direction things are. But also in medicine, we are now able to diagnose the thing quite early, detect them quite early, and so that we can provide treatment well beforehand. And the progress is quite well now, because we earlier used, let's say, to measure lens, we use certain way to measure lens, for example, like foot, hand, steps. And now we use more sophisticated tool like vernier calipers, microscope, laser ranging devices, etc. And the philosophy, as some of us were talking about, that improved our life. So in same fashion, the knowledge that how precise we can measure now things has greatly improved the life of the people as well. So this is just an example that why we need more precise measurements. For example, trade is an example where we sort of need to standardize the thing. So what is the meaning of, let's say, kilo, or the distance, or the volume? These are now the standard definition for that. Earlier it was not there. So for example, many devices earlier were used to, let's say, measure the time, the temperature, or the chronometer for the navigation. Certainly they were not very precise earlier, and now we certainly have a more sophisticated devices. So these are, for example, is the atomic clock, which uses the oscillation frequency of cesium atom to measure the time, which is basically the definition of 1 second. So in this experiment here, this is trapped cesium atom, which is basically the wavelength, and which defines these many oscillations of the cesium atom between the two ground states, between the ground state and the excited state. And these oscillations are so precise that it defines that what is the definition of 1 second. Similarly, we have now to measure temperature the radiation sensors, which can measure the temperature as well. And also we have the GPS system, which can give us a hint to navigate from one place to another place. So they are more precise. So this is basically a general picture. Now, why we use quantum mechanics to make sensors or sensing devices? So one of the property that also have been talked in this conference is that the quantum systems are very sensitive to any small perturbation, which somebody termed as decoherence. They're very sensitive. It means that so this picture is not actual picture of atom, but this you can think of as a cartoon of an atom where there are electrons surrounding the nucleus. They are orbiting around the nucleus, and this is a quantum system. I'm calling atom as a quantum system, which is true. So so these atom are very sensitive to any small perturbation, and therefore we can use them as a sensor. For example, here we have a lot of atoms which are moving and which determine the temperature of this room. So if we have a quantum sensor here, which will detect the motion and give us the temperature. If the room is hot, then the atoms will move faster. So we can use quantum sensor here as well to measure the temperature more precisely of this room. So let's consider a two-level system. So two-level system means that we have some, the atom is in the ground state and the atom is in the excited state. So these are two levels of these atom. And the E is the energy difference between these two levels. And H cross is the Planck constant and omega naught is the frequency. So in general, this atom can be in the 0 state or in the 1 state, as well as in the superposition of 0 and 1 state. However, if we have some signal that we want to estimate, it is coming from, let's say, temperature or the frequency or the field, then the state of the system will change as this way. So there will be theta here imprinted in this state. And how we will access this theta is our task. So our task is that we want to access this theta here. And because we don't have a direct way to access theta, we have to perform this experiment many times and collect the data. And this data is collected in terms of the probabilities. So here P is the probability that we have the state of this form, while if there is no perturbation, then we have a state without any theta. So it is just the ratio of these two events. And P is also related to theta, as like 1 minus cos theta over 2. So delta theta gives us the limit by which we can measure the precision of this unknown parameter. And n is the number of times we repeat the experiment. So you can see that since n is not infinite, we don't have infinite resources, we have finite resources. So there is a limit in the estimation of this unknown parameter theta. So this gives us the limit that we cannot measure any parameter like temperature very precisely. There will always be an error in the measurement, and that error is coming from the is not that our instruments are very badly built or we are very ignorant. It is just the theory that we are using has this property that we cannot precisely estimate the probabilities, and in turn we cannot precisely estimate the unknown parameter that we want to know. So so earlier we used one atom. Now we have many atoms, let's say, all in the ground state, and we create an entanglement between the atoms, and then we start using sensing. It turns out that so if we ignore these details, it turns out that the error in the estimation is quite improved. It means that now, because of this presence of entanglement, we can now measure the theta with a precision which goes as 1 over n, where n is the number of atoms that we are using. So earlier it was 1 over root n, which is slower than what we have now is 1 over n. So it shows that the presence of quantum entanglement can certainly give an advantage in the precision of measurement. So we can overcome the limit that was earlier. Earlier we had a limit in the error, which was delta theta goes as 1 over square root of n, And now, because of entanglement, we are able to overcome that limit and gives this precision delta theta is equal to 1 over n. So yeah, this is the ultimate precision that quantum physics can give us in the measurement of some unknown parameter. So these techniques has been used, for example, in making atomic clocks, magnetometers. So people here are aware of MRI, which detects the anomalies in our brain. So they use this, the magnetic field detection. The magnetic field resonance is a mechanism by which the anomalies in our brain is detected in medicine. So there are sort of application of this field also in the medicine direction, also in the gravitational wave detector. So people have used entangled state and they have gone to very high precision. So these are the few applications that I have listed of quantum sensing. So please tell me when my time is over, because I have a lot of slides. So so the theory of quantum sensing is quite broad, and the limit, so these two great people, Kramer and Rao, so Professor Rao has passed away recently, but he is a great statistical physicist, mathematician, who has contributed greatly in the direction of parameter estimation. So the quantum Kramer-Rao inequality, the first line tells us that we cannot exactly estimate any unknown parameter. There is always a bound, and this bound is given by the Kramer-Rao inequality. So the quantity in the right-hand side is called the quantum Fisher information, which tells us that how much we can know about the unknown parameter. So it means that the higher the quantum Fisher information, if we have higher this quantity, then we know a lot about the parameter. If we have a lower Fisher information, we don't know anything about the unknown parameter. So this characterizes that how much we can know about the unknown parameter. Now, in general, we have a quantum state, which is basically have all the information. But what we can access is not the quantum state. We can access the classical measurement. So we measure the system and we get the information. That is very general rule. You interact the system, you get the information. But this will limit us our ability to determine the unknown parameter even more precisely. So this classical Fisher information, FC, is less than the quantum Fisher information. So what we know, what quantum mechanics can give is a lot of things, but what we can access using an actual practical implementation is much lower than what the actual theory gives us. So these are two limiting cases. One is the Heisenberg limit, where the quantum Fisher information scales as n squared, so it's faster. And the standard quantum limit, where the quantum Fisher information scales linearly, which is like slower. So always, if we want to infer the unknown parameter more precisely, we want that the quantum Fisher information scales quadratically with the number of atoms. Unfortunately, the story is not always easy. I mean, even we have entangled state, there is a decoherence. As we increase the number of particles, the system will no longer remain entangled. The decoherence will destroy its quantum nature. And therefore, the advantage that we might get in quantum metrology or quantum sensing or parameter estimation using entangled state may not be always experimentally accessible. So what is the challenge now? The challenge is now that theoretically we know that this state can give us very high precision in the measurement in medicine or in the fundamental physics or in making the atomic clocks. So the challenge is that we engineer a quantum state which is free from decoherence. That is the current state of the art in quantum information science, that we need such entangled state free of decoherence. We don't need any decoherence to perform any important task. So with this, I would like to just thank my collaborators who were contributing in our work. And the picture that I showed were taken from internet, so they were not drawn by me. So thanks to the internet as well. So thank you all for your patience.
So thank you, Utkarsh, giving some ideas regarding the role of entanglement in technology. But let me change the program in a little bit, because as we are, many people are here who will be interested in philosophy of relations. So let me request Dr. Atun Kumar So he will be able to tell you exactly what is meant by correlations or relations in the domain of quantum theory. Then I will ask Geshe-la to speak from. So you have 15 minutes time.
Thank you. Okay, so again, let me start by thanking Tibet House organizers, Tamdulji, Professor Roy, for inviting me to address this August gathering. It's always fun to be part of the conference in Tibet House because you get a chance to listen to different people from different perspective, right? So thank you again for that. Just a little bit of advertisement of from where I come. This is IT Jodhpur. So this is the campus, the first on the top left. And when you enter IT campus, you'll see this brain tree, which signifies life as well as technology in the campus. And then, of course, a little bit of wildlife in the campus. Going back to the title, I'm going to talk about quantum entanglement and non-locality. Okay. So, as in the morning session, it was told that 1925, Schrödinger introduced quantum mechanics as his wave theory, 1926 basically, and 25 it was introduced as a matrix mechanics by Heisenberg. So it was a completely new theory and it puzzled the physicists that time, and you would have heard a lot of times statements like God doesn't play dice, right? Or for that matter, Schrödinger said that if this entanglement thing is true, I regret that I have contributed towards it. Feynman even said that I can safely say that nobody understands quantum mechanics. Okay. So in case you're not able to understand, you're there. Okay. And he also said that if you're not perturbed by the findings of quantum mechanics, you have not understood it. So in case you're being perturbed, please be ensured that you're on the right path. So let me start this. I think Utkarsh has just told about the states of an atom. He has shown you in terms of energy levels. I'll talk in terms of a coin, right? Let's go back to our day-to-day experience and think in terms of a coin. How do we say that an electron can be spin up or spin down, right? So if you have a coin, right, it can either be head or a tail. When you toss it, in general, I either get a head or a tail. Quantum mechanically also, there is not much difference. The only thing that we do is we put this head and tail into a bracket, okay, and we say that it's a quantum state. That is what we do. So whenever you are seeing that bracket, that means it's just representing a quantum state. So in terms of the spin of an electron, it could be either spin up or spin down. It's a two-level system. Only two possible states are there. But the only difference between quantum mechanics and our classical day-to-day experience is in terms of statistics, the probabilities associated with it. What we say is that the coin can also be a linear superposition of both head and tail. Okay, so how can it be possible? Say, for example, I had this coin, I just borrowed it from one of our colleagues, Abhishek. Okay, so this is the coin, right? It could, if the coin is in my hand, I don't know whether it is head or tail, right? But the moment I perform a toss, right, and it lands into my head, I know whether it is head or tail. So till it is in my hand, I don't know anything about it. Probably coin also doesn't know if it's a quantum coin. But the moment I perform a measurement, when I throw it in the air, I'm forcing it to take a stand. I'm asking it a question, are you head or are you tail? It tells me an answer whether it is tail or head. gives me a deterministic answer, but there is a indeterminacy involved until and unless I perform a measurement. So what I am representing it here is the coin before the measurement, it doesn't know whether it's in the head state or a tail state, but when the measurement is done, you can see it is either a head or a tail. So what we represent it, how do we represent it? We say that it's a linear combination of both head and tail at one point. Say for example, if I toss the coin, classically it's only head and tail, but what if it stands on the surface like this, right? Like this, right like this. I don't know now whether it's a head or a tail. In general, we say there is a 50% probability that you get a head and 50% probability that you get a tail, right? Now that probability comes if you do infinite number of such measurements, create a statistical data for yourself. If and this is how we perform the measurement. Say, for example, we don't have to go into detail of this. This is a Stern-Gerlach experiment coming from Stern-Gerlach experiment. You pass the electrons through a non-homogeneous magnetic field, and depending on whether it is revolving into the clockwise direction or anti-clockwise direction, a translation force acts on this, which takes it either up or down, depending on whether it is revolving into clockwise or anti-clockwise direction. Now, if it was not confusing enough, let's make it more confusing by involving one more particle. Right? That is where the interest comes. That is where you define quantum entanglement, non-locality. You need at least two particles in general to define that, right? So let's go to two particle system. If I have two coins, then the only possibilities are head-head. If I toss both the coins together, the only possibilities are head-head, head-tail, tail-head, or tail-tail. Classically, these are the possibilities that exist, right? And as we have already seen for single particle system, quantum mechanically, we can also represent it as a linear superposition of all the four possibilities. Linear superposition is just adding some coefficient to one possibility plus adding another coefficient to another possibility and so on. The states are normalized. Let us not go into those details, but this is it, that a 2 qubit or 2 particle state, 2 particle system can be represented like this, right? From here we will try to deduce what quantum entanglement is. So the question that we are asking here, say if we are saying 2 particle states can be entangled, so is it that all such 2 particle states which can be written as linear superposition of all the 4 possibilities, are they entangled? Is linear superposition always lead to entanglement? So there are different possibilities that I have written. Let's look at the first possibility. It says head-head, the first possibility, plus head-tail. So here I am assuming that both C and D are 0, only A and B exist. So in that case, I can write it as H times H plus T, basic factorization, right? That we have learned into our elementary school. Now here, if you look at this state, when you are looking at the right hand side, the first coin has a distinct state that it is in head state. The second coin also has a distinct state that is standing right on its edge. Right? These are the identities of these 2 coins. One is in head state and one is standing right on its edge. In the second case, it is exactly the role reversal. Now the first coin is standing on its edge and second is showing you either head or tail, but they have their own distinct identity. Right? In the third case here, when you are taking all the possibilities, HS plus ST plus TH plus TT, still it is H plus T multiplied with H plus T. So first coin is also standing on its edge and second coin is also standing on its edge, right? They both have their distinct identity. They both are standing on their edge. They know what their state is, right? They are standing on their edge. Now let's look at some different kind of possibilities. Now if you have a state which is HH plus TT, now if you look at the first coin, on the left hand side of plus minus, the first coin is either head or tail. Second coin is also either head or tail. Now you cannot separate these 2 particle like coins, right? Because I am not able to factorize it into the state of the first system and the state of the second system. In this case, the coin, both the coins doesn't know whether their state is head or tail. It's like they're keep flip-flopping between head and tail until and unless you ask a question. The moment you ask a question, it will tell you whether it is head or it is tail. But in the first case, irrespective of how many times you ask the question, if you prepare the similar kind of state, every time the first coin tells you that he is in head state, the second coin will also tell you that he is also in head state, and so on. Similarly, all other cases, one by one, I do not want to go into that. The point is, when you are talking about an entangled state, the individual particles, they do not have their own identity, right? It is like they do not, their individual existence does not exist. The state as a whole is defined, but when you are looking at individual particles, it is not defined. In quantum information and computation, we call states as pure states or mixed states. Pure states are states with maximal information, that these are all 2-qubit states, and mixed states are states with less than maximal information. There are certain degree of uncertainty associated with that. Those are the states of individual coins here, because the individual coin doesn't know whether it is in a head state or a tail state, so that contributes towards a degree of uncertainty towards the state of one of the subsystem. So that is this kind of states where you cannot write the state as a state of the first system and a state of the second system. That means the individual particles do not have their own identity. As a whole, they are defined, but as individual identities, they are not. That is where we call that the state is entangled. Right, this is the algebraic representation of that. Let's not worry about that. Alternately, let's look at a different picture. Let's think about two balls. One is orange and one is red. Let's also think that we have two boxes, right? And in both the boxes, we'll put one of these balls, right? But every time what we do is, we put one of the ball in one box and one in another and send it to Alice and Bob. But we ensure that when we are sending the box, both the box has same color of the ball, right? Either both of them are having orange or both of them are having red. So this is what we are doing, and then we send it to two persons, Alice and Bob. Now Alice and Bob, before opening the box, they don't know. They know that the color of the ball could either be red or it could be orange. But before they measure or observe the ball, they don't know whether it is red or orange. We know about it because absolutely clear about it, because these measurements are predetermined for me, because I know I have prepared those boxes, I have put those balls in the boxes. So they will open the box and they will know that they have got some color of the box. But every time they will find that if somebody has got an orange ball, the other person has also got a orange ball, and so on, right? But this is very classical, right? Now, when you talk about atoms, atoms are also entangled, as we have talked about. Now think about putting two atoms in these two boxes without knowing what are the states of those atoms, what are the colors of those atoms, right? I'm just making some vague statements, colors of atom and all, just trying to take the analogy from what we have discussed. So we are putting these balls into the boxes, sending one to Alice and one to Bob. Now I also don't know what is the color of the ball in that box. In fact, the balls also doesn't know what is the color of the ball until one of them opens it and finds that if it is red, the other one is also red, and if it is orange, then another one is also orange. And that's quantum entanglement for me, right? So this is what puzzled everybody somewhere during 1935 when Einstein, Podolsky and Rosen, they published this famous paper about EPR paradox, right? Einstein, Podolsky and Rosen paradox, where they questioned the quantum theory as a complete physical theory. I'm not going into the detail of the argument that was given. It was a brilliant argument to summarize. but it was based on locality and realism. Locality means that if you're performing a measurement here, it should not affect in any way another particle at some distant location, right? And realism means that when you perform a measurement to know something, when you observe something, you see something that was existing before you were trying to measure it, right? Like Einstein said that does the moon not exist if I don't look at it? So this was the paper that was published by Anselm Podolsky and Rosen based on their assumptions of locality and realism, and which was countered by John S. Bell. Basically, he borrowed the same hypothesis of Einstein, Podolsky, and Rosen based on locality and realism and gave an inequality which was bearing his name, Bell inequality, right? But whatever time I have left, let us just focus on what do we mean by non-local correlation in that case. I'll just try to give you one example. Again, this example I'm taking from Nicholas Jessen's book, Quantum Chance, which was shared by Professor Roy with me long back. So, in order to understand the difference between these local and non-local correlations, consider that there are two persons, Alice and Bob, who are living in a community, and there is one restaurant where they go and eat every night, right? So what happens that every night they end up eating exactly the same meal. Now, how do we explain that? We can explain it in a way that when Alice goes to the restaurant, Bob also comes. Whatever she orders, Bob also copies and orders the same, or the other way around, right? So it's like one event influencing the other event, right? But let's make it a little bit more interesting. Let's separate Alice and Bob to two different towns, two different countries, or two different galaxies, such that they cannot influence each other's choice. Now, assume that there is a restaurant, right, where Alice goes, and there is a restaurant where Bob goes. Now, ultimately what happens is that every evening, although they are in two different galaxies, they end up eating the same menu. Now, how is that possible? Now they are not influencing each other, right? Their choices are not influencing each other's choices. Now, this can be explained by a local common cause. We can still assume that both the restaurants are part of the same chain where the menus of every evening are decided. The menus of every evening are different, but every evening the menu in both the restaurants are same because they are part of the same chain, right? That's also a local explanation because there is a common cause which is propagating from point to point continuously to both the chains, right? So there are two ways in which you can explain that. First was event influencing the other event, or with a local common cause. Okay. Now think about a situation, because they do not have much choice, right? We said that there is only one restaurant in both the galaxies. Consider there are two restaurants, one on the right and one on the left, to both houses. So Alice can choose randomly that I want to take food today in the left restaurant or in right restaurant. Similarly, Bob can also choose the same. Now, one evening they both go to the left restaurant. They end up with the same menu. Okay, you can still explain with the common local cause that both the restaurants are part of the same chain, right? One day Alice decides to go to left, Bob decides to go to right. They end up having the same menu. Now, this could also be possible if we consider the same local common cause, that this right restaurant on Bob's side also has the same menu. Now, Alice goes to right and he goes to left. Again, they end up with same menu. That means all the restaurants have same menu if we are thinking in terms of a local common cause. Now, but the problem is when they both choose to go to the restaurant on the right side, they end up with different menu. How would you explain that? right? First three can be explained by a local common cause, and if that local common cause is to be true, when they both go to the restaurant on the right side, they should also end up with the same menu, but they are not ending up with the same menu. They are actually having the different menu. This cannot be explained by any local kind of a correlation. The meals of these two people are now not correlated by local correlations. The only way you can explain it by assuming something which is not local, right? Not local. Non-local is something which is a negative assertion. I don't know what non-local is, but I know that this is something which is not local. When we say non-local, what we mean actually is not local. So it's not local. So it cannot be explained using local theory. Based on that, this simple game is described here, where X, you can say that Alice, and Y is Bob, and 0, 0 is that X is equal to 0 means she goes to the left restaurant, Y is X is equal to 1 means that she goes to right restaurant, and similarly for Bob. And whenever they choose left, their menu is same. Whenever they choose left and right, their menu is same. Whenever they choose right and left, their menu is same. But whenever they choose right and right, their menu is different. Exactly the same game as I have just described. Yeah, I'm done actually. So these kind of effect can only be explained using effects which are not local, and that is what we call as non-local correlations. That is where you can differentiate between local and non-local correlations. And non-local correlations in general, they are originated because of the entanglement between the particles. So, okay, I hope it would have made some sense. Thank you. Thank you very much.
Thank you, Professor Atul Kumar. Let me briefly say how it is related to philosophy of relation and what's the problem. I mean, that will be easier for Geshe-la. He told that the two entities, they make a whole, and the two entities, they lost their individuality. So in a sense, the whole, entangled state contains more information than the individual entities. So the issue is, if you think in terms of the relata and relation, relata is plural, relatum, two entities, so they are relata, and relation, the relation means between the two entities. So issue is whether the relation is as real as relata. First issue. And second issue, relation in the final analysis, Dharmakirti said it is not real. But in our case, in physics, as it has been tested in lab experiment, we say it is really real. And the third issue, how the two entities make a relation. The Prabhachandra is a Jain logician. He entered in the debate and he said the two entities have kind of propensity to make a relations. So he told it is not reflected in Dharmakirti's work. I am not that specialist in Dharmakirti's Sambandha Pariksha. He debated with Buddhist scholars. So we have a lot of these kind of issues come up, though they tried to explain technically, but these are the issues the philosophers should take care, and I hope Geshe-la will take care of these issues. Geshe-la. And I don't think he needs any more introductions.
Thank you, Professor Sisirji. and all the my two colleagues here, and all the participants. So basically, the concept of relation is extremely important in every respect. And Buddhist philosophy, Buddhist logic, attempts to articulate what the relationship is like. So we see that the reading the different traditions like Dividiums, he talked about, say, the things, how the things related in ways of the resemblance, and then contiguity and the causal relation. And he himself is not too happy with, say, the predicting the future on the basis of what is today, what is current, or what is the events seen before. And the, say, Nyaya tradition, Vaisheshik tradition, the non-Buddhist traditions in those days, that a great debate amongst these traditions and the Buddhist logicians pertaining to what the relationship is like. So when I speak about, say, the whole thing comes into being, yes, of course, the relationship plays a very important role for the account of the memory, how you account for the memory, again, the things that happened, that what you remember today, what happened in the past, there should be some connection there, some relation between what you remember now and the past event. So, and likewise, we see that, for example, say, what I earlier this morning I explained as a great painting of Mona Lisa painting. And there is a painting which is an undeniable fact, and we can't say this is just a bunch of atoms. This is extremely expensive, the painting, and it can cost you like millions of dollars. Undeniable fact. Yet, if you go more closely, we see that it's just made of atoms. So where is that painting, this question? That was bothering all these, the logicians. Where is the painting? They are undeniable. If it's just the bunch of atoms, then for most of us, we should know that the atoms, okay, the resonance, those who are below 30 years old, resonance, below 30, okay, below 30, and okay, let's say 30 plus, right? Okay. So below 30, when I say below 30, those who are below 30, you are a little proud. Okay, we are young. Right, we are young. And plus 30 means we are not too happy, right? Okay, so the point is that we are nothing but the age is related to your, I'm not saying age is a number, age is related to your body. Now the body is made of atoms. And the atoms which constitute who you are today, and if you are 30 plus, atoms which constitute those with 30 plus, those who are 30 plus, and atoms which constitute those who are 30 below, age of the atoms are same, 15 billion years old. So on that level, where is young, where is old? Okay, how many agree with me that with atoms there is no the annihilation of the atoms? Atoms, they can, at the most, they can change that the energy can convert into atoms. They will never annihilate, resent. If you know this, if you accept this from the physics point of view, then we have to acknowledge that all the atoms which constitute the body, they are all as old as 15 billion years ago. They came from the Big Bang, 15 billion years ago, which means that we are all on the atomic level, we are all same age. We are all 15 billion years ago. And more than the atoms, there's nothing to be identified as you as young or old. There's nothing. That's a reality. So on that level, the atoms which constitute your body and the atoms which constitute the Mona Lisa beautiful painting, there's no difference. So Mona Lisa painting is extremely expensive, and it was a painting of the ordinary person like my painting, painting which I do, is very cheap. So, but on the atomic level, there's no difference there. So, what is that reality which is so expensive as the Mona Lisa's painting? And you as a human being is so precious as the, say, if I damage a rock, no problem. If I damage a human life, you'll be going behind bars. So there is this, the infallible reality there, reality of something which is expensive, something which is good, bad, cheap, and so forth. So where are these? This question. So on the atomic level, we see just they are just the same, but there's something which is more than that. Where is it? Is it atoms are this, or are they laid? Are they just like, for example, like this cloth, or let's say this clock, watch, and the cloth covers it. So there's something the different that the cloth which covers the clock, the watch. These are two different entities, and they're still related in that sense. Or no, it's just the same object seen in two different ways. So what is that relationship? There's a relationship there between these atoms which constitute the Mona Lisa painting. What is that relationship? This is a huge discussion, debate going between the different Buddhist, the different logical traditions in the past, particularly Acharya Dharmakirti and his counterparts like the Nyaya tradition and the Vaisheshika tradition and so forth. So as Professor Cicero indicated, that said that relation between the Mona Lisa painting and what constitutes the atoms which constitute the Mona Lisa painting, that relationship is something not as not as substantially real entity, but when you speak about it is not intrinsic or the intrinsic, this is something we have to study in more detail of the different philosophical traditions, Buddhist traditions, and of course this is something not confined to Buddhism, non-Buddhist also, but I think that we really need to peel off the different layers, understanding what constitutes objective reality. So with this in mind, so this, when talking about the relationship, is primarily discussed in Acharya Dharmakirti's text, a 7th century great Indian master. So there, he talked primarily of the two kinds of relationship. One is the causal relationship, and the other one is the same entity relationship. And of course, this relationship per se is unlike the relator and the relation. Unlike the relator, the things which are involved in this relationship, for example, like let's say the atoms which constitute that the painting of Mona Lisa, and the painting per se, the painting of Mona Lisa, and the atoms which constitute the painting of the Mona Lisa, what's the relationship? The relationship, we see that to speak of the relationship, there are two things. One is the atoms which constitute the painting of the Mona Lisa, and the other one is the painting of the Mona Lisa, which is on the macro level, and the individual parts, like the atoms, on the macro level. So there are two things there. These two are the relator, and then what connects the two is the relationship. So what is that relationship? So the relator, according to Acharya Dharmakirti, there is something very substantial there. We can see the Mona Lisa painting there, and I think that like maybe a few years ago, that Mona Lisa painting, it said that it was lost. It was stolen away by somebody else. And so it was completely there as an objective reality from the Acharya Dharmakirti's point of view. And then likewise the atoms also there, atoms which constitute the painting. These are also the object, is substantially there. But the relationship between the two, that is something not as substantial as the relator, the two things involved in the relation. So what is that like? So for the Nyaya and the Vaisheshik, this is amazing how the different philosophical traditions, they speak about the relation. Yes, the paintings are undeniably there. Atoms are undeniably there. So what is the relationship between them? Are they like the same entity, or they're like two different entities? Like, so my hand covered by the cloth, these are to remove the cloth and my hands are intact there.
So likewise, remove the painting and the atoms are left there. No. If you remove the painting, the atoms are gone, or the atoms are removed, the painting is gone. So the two are not seen as two distinct entities. Whereas the Vaisheshiks and the Nyaya, they cannot conceive of anything existing, the independent, anything existing as the dependent on the mind. Things should be so solidly there, because of which, and for them, it is their philosophical position, logical assertion, that the two things, they are related in ways as two distinct entities, not as the same, the single entity. Whereas Acharya Dharmakirti says, no, this relationship is purely mental designation. The Mona Lisa painting is there, and the atoms are there, and the Mona Lisa painting is not different from the atoms. These two are the same entity. And these two are related in ways as the same entity relationship. It's not as a different relationship. And the more discussion is about what exactly is this relationship, this phenomena of relationship. Is that something as substantial as the relator, or it's more non-substantial? Answer is, of course, non-substantial. And non-substantial doesn't mean that it doesn't exist intrinsically. Because for Acharya Dharmakirti, according to Acharya Dharmakirti, anything that exists should necessarily exist as intrinsically, but not as substantially real. So for Acharya Dharmakirti, the phenomena, they're classified into two categories. One is substantially existent and one is empirically existent. Empirically existent doesn't mean that things exist devoid of intrinsic reality. What exists should necessarily exist as intrinsically, and for Acharya Dharmakirti. But for Prasanga, that's very different. Okay, so with this in mind, we see that there are two kinds of relationship, and which is totally not acceptable to David Hume. In fact, for David Hume, why I'm bringing this David Hume is because that when I was in Cambridge, there was one, it was very interesting, the story, that a lady was always coming on the same bus as I was, the bus which I catch, and then the Britishers. Is there any Britishers here? Their style is very different from the Americans. Americans, they will just laugh and smile at you, and the Britishers, they remain very reserved. And all they're like almost for 1 month we're together on the same bus, but they never talked. And suddenly one day I was on the seat, and then that same lady who was a little older, maybe like 10 years older than me, sat right next to me, which is so unconventional. And I was a little stiff, and she said, "Are you Geshe Damdil?" And I was shocked, little shocked. I said, "Yes." Then she said, "My husband wants to invite you for a cup of tea." Who's your husband? I said that he's a professor of philosophy. And later on, I came to discover that he was the chief editor of the Encyclopedia of Philosophy of Cambridge University. Amazingly humble, extremely learned. And then I asked him, it was just my initial exposure to the outside world. After completing my Geshe degree and then sent to Cambridge, and obviously meeting with lots of professors and experts, physicists. And then I asked him, if I were to read Western philosophy, which book should be the first book to read? And he said, David Hume. And he so kindly gave me his own personal copy of the David Hume's, the book. So there, reading that, I see that the David Hume's presentation very different. He doesn't really accept in things that we can predict in the future, that what's going to happen in the future on the basis of what we can see today. So he doesn't really accept any of these things. Of course, similar of this kind is what I find presented in Buddhist the logic as well. So, in other words, they say there's mention of the causal relationship, which means that the results, they come into being, but depends on the earlier causes. These two are related, just to connected, related. And then like the same nature, meaning the two related existing at the same time, the painting of the Mona Lisa and the atoms which constitute the painting. Okay. Okay. And then for example, yourself and your body, your mind, these were related in the form of same dependency, the same nature. Next one is something which is very unique of Prasangika. Prasangika talks about the phenomenon of dependence, the phenomenon of support, and the phenomenon of contact. These are seen as the same. So our job is to see if these three, which Prasangika presents as in the form of the phenomenon of dependency, which of the two things, or do they go in that direction, but may not necessarily be one of these two, the causal relationship or the same entity relationship. And then so one thing that I would say is that of the two relationships, one is a causal relationship. We see that one is the law of karma, which is extremely important. Why the causal relationship, this causal relationship is so important is on this basis that many of the important concepts of Buddhism, not only Buddhism, even physics, even Western science, or in the systems of Hinduism, Jainism, or Christianity even. So many of the concepts are built on a concept of the cause and effect relationship. And the law of karma, which we talk about in Hinduism, Jainism, Buddhism, is all on the basis of this concept. And then the concept of rebirth, how we can account for the rebirth. So it's again postulated on the basis of this. And the next thing is about the same entity relationship. In this connection, we see that for example, the non-locality and so forth, which I presented this morning session also, is that where on the micro level, the relationship, your same nature relationship, particularly with your energy and your mind, subtle mind and subtle energy, these two are related in ways of same nature, which is not acceptable in the Sutra system. Whereas in the Tantra system, that is something which is so unique, but the physical body and the mind, physical body in the sense of the energy, and the mind, which is totally cognitive, these two, or experiential form, these two actually exist as the same nature. It is on this basis that all these non-locality, the behavior of non-locality on the macro level, when he trained in the subtle energy and the subtle mind, then all these strange behaviors can be seen, can be made visible, also on not only training in the micro, but the behaviors can be manifested on the macro level. Okay, so basically, to make it quick, relationship between karma and the habit. This is a very complicated thing, how your karma and the karma which is purely mental with your physical body, the physical abode. This can best be explained only when you understand the mechanism of how the energy, which is the subtle energy, which is not visible even to the science, subtle energy, how they can affect the physiological energy on the physiological level. So which is visible to the neuroscientists or neurologists, and then from there can then affect the physical external body. This can affect the external world. So this is how best can be explained from the point of view of the subtle energy and subtle mind in the form of the same entity relationship. Whereas if these two are totally different, then how the karmas, they connect you to the respective world systems and so forth, this becomes a very complicated thing. Then training the subtle energy and the mind for super-mundane, simultaneous, diverse activities, meaning non-local activities in different locations. And then finally, our job is what we say the mind and the energy and your subtle mind, these two have incredible potential if manifested in its true form. You don't have to have any fear. The fear, all these things are attracted when the mind which feels a fear, it takes a very different form, affected by external factors. When you see that, you can train the subtle energy and subtle mind so well so that it can manifest in its true form, then external factors cannot affect you at all. It is at this point that your mind will be liberated, that you experience infinite happiness and total fearlessness. Thank you so much.
Thank you, Geshada. We have many philosophical questions related to this. So let us go to the young scholars. We have any questions?
Wait,
Please raise your hand. Okay, go ahead. Yeah.
Hello, everyone. So I have one question regarding let's take the example of Schrodinger's cat. It's not directly related to the quantum entanglement, but maybe you have some thoughts. So when you take Schrodinger's cat, for example, we say that we close the box, and then after a while, we say that the cat is in a superposition state. But for us, he's in a superposition state. The cat itself probably knows, doesn't know, but inside the box, the cat knows, like, either alive or dead, right? So my question is, from a quantum physics point of view, can we say, or is there a mention that for one person who doesn't know the information, the cat is in superposition, but from inside where you have the information, there is no superposition. So how can one cat be both in superposition from the outside, but not in superposition from the inside? This is my question.
Sure. I can.
See, when you look at the particles and at microscopic level, that's what I said, that when you're talking about an electron, right? An electron can be in an arbitrary linear superposition of 0 and 1. So if you could see, electron also doesn't know whether it is 0 or 1. Like you said, cat knows whether it's dead or alive, right? In macro world that happens. Cat knows whether it's dead or alive. As an observer from outside, I don't know. Or the example that I have given you for the red or orange boxes, right? The balls in those two boxes. Alice and Bob doesn't know. They might be thinking what color that they are going to get, but I know, right? And in this case, what you're talking about, if it's an atom or an electron also doesn't know until unless you ask that question. When you ask that question, you are forcing the electron to take a stand that whether it is spin up or spin down.
Okay, so any other question? Yeah, go ahead.
Yeah. So many psychiatrists and many psychologists have done research on reincarnation. For example, Ian Stevenson, Jim Tucker, and they were able to scientifically validate through many cases this phenomena of the law of karma or rebirth or reincarnation. And this is one of the central tenet of Buddhist philosophy as well. Now, is it possible that we can relate these phenomena with the idea of quantum non-locality, in the sense that things of the past, which has no, spatial present now, can impact me as a human being? So can that be considered as no?
The forms are different. All the entanglement and the physics are based on the physical body, material body. Based on material body. The whole system is based on physical body, and the rebirth system is there are two different physical bodies. So unless you have a concept of mind, when we talk about in tantra, the subtle wind and things like subtle senses and things like that, that's a different thing. But in general case, it is a mental continuum that goes from one life to
Yeah, just to respond, just in
Okay,
two statements.
okay.
Is not the body essentially a projection of the mind? I mean, in terms of physics, we say that, the mind is the field part and the body is the matter part, but the fundamental aspect is the mind. So body is essentially the projection of the mind. The body and mind are essentially the aspects.
Continuity from previous slide to this slide.
There's no physical continuity.
There's no physical continuum.
No, even,
This slide
yeah.
body ends. The next time's body starts from there. Only the mind, is the factor, the element that continues.
So if I may ask, is the body housed in the mind?
In terms of the physics, it's very difficult question. We don't know what mind is.
Right.
Okay. Yeah.
Here in science, brain.
Yeah.
Brain stops here and new brain is formed.
One of my very good friends is a world famous neuroscientist called Pribram. He passed away a few years before. He used to sit next to my office in USA. So every week he used to come to my office and he asked me, where is my mind? We don't know. I mean, whether it is in neuronal architecture or where, we are not able to locate it till now. So any other question? If not, I have something for my clarification, of course, from young people's clarifications also. Like you are talking about causal relations. But here, the non-local relations in quantum theory, they are acausal. They are not causal relations. But again, the question comes, how do you define causality? There are two ways, one in Einsteinian sense, which means that according to Einstein's special theory of relativity, the speed of the propagation of the light is constant and maximum, 3 into 10 to the power 10 centimeter per second. So based on that, we formulate a causality principle. This is called Einsteinian causality. And according to that formulation, the non-locality, which makes a correlation or relation between two entities, are acausal. But as Nicolas Gichot, you know him, he suggested that maybe this kind of phenomena have an explanation if we change the concept of space-time is different from Einstein. So whether, my question is to you, whether a causality also may create a relation. Yeah. No, a causality. A causality, whether that is also a kind of relation.
Okay. So basically, we talked about the two kinds of relation. And then so one thing which the non-locality or the quantum entanglement, which is being discussed, this is something which I said that it would for sure fall under the category of the conventional truth, but not in form of ultimate truth. At the same time, we see that these two are connected. Although physically these two are not at all connected, still we see that these two are connected in ways. So therefore, which I think some of the physicists would describe that as a spooky action at distance. So these two are connected, but then physically speaking, there's nothing to say that these two are connected. But then these two are connected, so teleportation. So the idea is that they say that as I said earlier this morning, that when you train your mind on the subtle level, then even the physical body can be affected. And this cannot be explained in ways that they are like the physically connected in ways of, for example, say what is happening there in the other part of the Milky Way galaxy. You can see only through the medium of the light. There should be the medium to connect the two. So likewise, do we require such a physical entity to connect the two things, that the two things are related? So of course, on the training or the very subtle, the mind and subtle energy, then the actual manifestation can happen on the macro level. that the two things can manifest as totally unconnected, but they're connected. Physically not connected, but connected. So this, of course, requires training in the subtle mind. So these phenomena are actually there. For example, Acharya Dharmakirti, who explained the two kinds of the relationship. So he acknowledges this phenomena. So there, then as you said, so now the question comes, so if, like Acharya Dharmakirti, a brilliant logician and psychologist, and accepts this phenomena of the non-locality on that level, that the two things are not connected physically, but still they behave connected. So how to explain this? So then the answer comes in the subtle mind. So as you said, what is mind? Nobody knows. So this is where we have to know what mind is. So there is this phenomenon mind. Without accepting phenomenon mind, then even the neuroscience, you will come across many shortcomings, crises there. For example, in the 2019, we had a huge conference on consciousness organized by one brilliant neuroscientist, a very senior neuroscientist, and attended by many neuroscientists, physicists, psychologists, and I was invited there as one of the presenters from the psychology point of view. And one neuroscientist talked about the free will. And the question simply bombarded this lady neuroscientist that if you talk about the number one neuroscience, the word free will, on the other hand, you're talking about the workings of the mind, reduced to the workings of the brain. In other words, if you take the reductionist approach of the workings of the mind to the brain, then how can you explain the free will? Because on the level of the brain, purely mechanical, it is to be deterministic. There's no room for free will. Then all these debates, she was just attacked by all the questions. It's all because that one fails to account for many of the phenomena which actually exist. Only when you accept the phenomenon of mind, then these can be resolved. You don't accept this. If you reduce everything to the brain, then you will be left with the explanatory vacuum and the gap. So the next question is, what is mind? So for this, we have to have, again, and the thorough studies, as explained by Acharya Dharmakirti himself, what the mind is. This is all very thoroughly explained. It will be good if we can have such conferences on, what is the exact mind? There are two empirical explanation. Not like, there's a mind, we cannot experience it. Not like that. Something which we can explain empirically. So that is something which is required for such conferences. Yeah.
Okay, thank you. Once again, all the speakers. Now, we are finishing the session now.
Hello. Thank you so much. Sir, I'll just conclude. Sorry. Thank you. Thank you so much, Professor Sisiroiji, for chairing the session, and our speakers for your very insightful presentation and answers. With this, we have come to the end of the session. So I would like to invite Venerable Professor Geshe-la Samdala to the stage to kindly present the souvenirs and kata to our esteemed chairperson and speakers. Thank you. Professor C.C. Roy-ji, our chairperson. Venerable Geshe Damdula. Professor Atul Kumar ji. And Professor Utkarsh Mishra ji. Thank you. Yes. Thank you, everyone. With this, we are done with this second session. Now, the next session will be moderated by my colleague, Ms. Kama Zumbala. So please be seated, and the next session will be resumed shortly. Thank you.
Yeah, yeah. Eliminate legend. No more eliminate. Rabkaj, kaina hai. Rabka. क्या कर रहे हैं? Here, your talk is this one. What is Arvinda?
Opening?
Yeah, this. So, hi. Excuse me, how to pronounce your name? Arvinda, right? See, it's simple, okay? I'll help you when it starts, okay? You are the first set I'm going to talk, okay?
Yeah.
Hello. Okay. Good afternoon, ladies and gentlemen, esteemed speakers and honored guests. Welcome to the third session of our captivating series on concept of time in quantum theory and Arya Nagarjuna's philosophy. I'm Kama Zumba and thrilled to be your moderator for this insightful and inspiring event. For this session, we have an excellent speakers along with our chairperson, Professor Kauri Gilla. non-resident senior fellow at the Center for Excellence in Himalayan Studies, School of Humanities and Social Science, Shiv Nadar University, Delhi, professor and head of department, followed by our speakers, Assistant Professor S. Aravindaji, Mr. Lotus Namgela, and Dr. Dinzi Rabanda. Our distinguished speakers today bring a wealth of knowledge and expertise on the table. Now I would like to welcome them on the dais. Our chairperson, Professor Kavi Gilla, Assistant Professor S. Aravindaji, and Mr. Lotus Namgela. Thank you. Now please allow me to briefly introduce our chairperson. Okay. Sorry for my mistake. Actually, Dr. Kavira is not an head of the department. Sorry. Okay. Now please allow me to briefly introduce Professor Kaveri Gilla. Professor Kaveri Gilla is non-resident senior fellow at the Center for Excellence in Himalayan Studies, School of Humanities and Social Science, Shiv Nadar University, Delhi, formerly professor at the Department of International Relations and Governance Studies. She gained her doctoral degree from the University of Cambridge, United Kingdom, and subsequently taught there. By invitation, she served as the principal of the Dalai Lama Institute for Higher Education, Bengaluru, from 2021 to 2022. Kaurila has actively studied Nalinda Buddhist philosophy for the last decade. And on 2nd June 2023, in a convocation ceremony presided over by His Holiness the 14th Dalai Lama, received an advanced postgraduate diploma, Nalinda Master's course in Buddhist philosophy from Tibet House, New Delhi. In addition to courses in her discipline of political economy, Kauri Gilla has taught three editions of an undergraduate course filled to capacity entitled Secular Ethics for Millennials, based on His Holiness' idea of universal ethics, and focus on teaching the importance of practicing wisdom and compassion in daily life. Now I request Professor Kaveri Gilla to lead the session.
Tashi Dele, good afternoon. So I would like to thank Venerable Geshe Dorji Damdullah and Tibet House for asking me to chair this session. Actually, I'm standing in for Professor Rana Purushottamji. So it's a great honor to be here and part of such a profound conference talking about so many things that are so central to our experience as sentient beings. So this panel is going to be on the concept of time in quantum theory and in Arya Nagarjuna's philosophy. So when we look at the notion of time, it is so central to our lived experience, and as I said, our sentience and even our suffering. For example, as the Buddha Shakyamuni said about aging and death. Geshe-la was making jokes about our age, but I think when we confront things like, for example, the death also of loved ones, near and dear ones, our entire experience relates to time. And on the positive side, we can also think that, had we lived in the time of Buddha Shakyamuni or Arya Nagarjuna, and by some accounts, they are still there, always there at present, but all of these relate to the notion of time. So when we think of a standard working definition of time, which we can debate again as in so many sessions, so I think something that we could accept is that perhaps we can think of time as a gap between two consecutive non-simultaneous events. In the morning, Professor Geshe Nawang Samthinla spoke about time, the notions in non-Buddhist schools and in Buddhist schools. So again, within the Buddhist schools, the Vaibhashika and Prasangika Madhyamika, so the lowest school and high school, again, as explained by Venerable Choing, not because of any other thing, but because of their understandings of, ontological reality might be subtler as you go along these schools. But these two schools agree that the three times are impermanent and they are functional phenomena, whereas the other schools in Buddhist philosophy, the Chittamatra school and Sotantrika, they believe that the past and the future are permanent, whereas only the present is impermanent. So there is debates about that within the Buddhist schools. And then, as Professor Samthinla said in the morning, that for the Buddhist schools, time is not an independent, substantial reality. Rather, it is a quality of product. He used the Sanskrit term for it, I think Sanskrit Dharma. So look, Sanskrit scholar as well as being, of course, a Nalanda scholar and Tibetan proficient to high excellence. So product which can also be taken as composite phenomena. So it is a quality, time is a quality of that. Whereas the non-Buddhists might say that time is an independent, substantial entity of its own. So Nyaya, Vaishashika and others. And I will just touch upon, because our first speaker, unfortunately, Professor Nilsala, is not able to be here. She was not well. She was going to talk about Arya Nagarjuna's philosophy, perhaps the greatest interpreter of the Buddha's words on the nature of ultimate reality. So just to touch upon how time may be understood from the perspective when he interprets about the Prasangika Madhyamika's understanding. So we heard throughout the morning about conventional truth and ultimate truth, the two truths. And if we start looking for time at the using ultimate analysis, as Geshe Dorji Damdolla's slides showed, when we look at the ultimate truth, we are using the frame of ultimate analysis, and when we are looking at the conventional truth of our everyday lived experience, it is through the lens of conventional analysis. So if we go looking for the three times, if we go looking for the present, no doubt we all have to accept that the present does exist. We are all sitting here in a Tibet House conference. Events of Gaza and all are happening as somewhere else in the world. All of this, the present moment certainly exists. But if we go examining more deeply, how does it exist? We cannot find it. So if we think about, if we just do this simple exercise, and Arya Nagarjuna said, so when he's talking about the ultimate nature of things as opposed to the conventional nature of things, if we go closer to examine that, what is the nature of time, for instance, so he cites that if the mirage were to be really water, then why not those close to the mirage sea water? So if we go into the ultimate analysis of going closer to the object and trying to find where is this present moment, we are not able to come up with a concrete moment. So so therefore there's a discrepancy between our understanding of how things appear and how they actually exist. And when there's such a discrepancy, then they may be termed illusion-like. So if we think about, if we go searching for a present moment, if we take an instance of 1 second, every moment of time, it must have a beginning, middle, and end. So if we take it as 1/3, 1/3, 1/3, we then have to break up each moment further into a middle, beginning, and end. This goes on ad infinitum. So you cannot actually pinpoint something called the present in this ultimate analysis frame of going closer, closer, and trying to see what really exists there. If the referent of this present moment is not findable, then of course the past and the future doesn't make sense because they can only exist in reference to this. So then what you're saying is that the three times are illusion-like because there is a discrepancy between how it exists and how it appears. Something that does not exist the way it appears, it is illusion-like a mirage. So in this instance, time is illusion-like. Therefore, everything that exists in time, including our minds and everything else that we experience as sentience, also is illusion-like. So with that small little introduction, and pardon all my mistakes because this is just a little bit of last-minute thinking for this session. I really look forward. We have excellent speakers with us. And as I shared, Dr. Nilza could not be here today. So our first speaker will be Dr. Arvind, who has a PhD degree in the area of foundations of quantum mechanics, 3 postdocs in quantum information theory, quantum many-body theory, etc. Currently, he's a faculty at the Department of Physics, the Indian Institute of Technology at Tirupati. He works in the area of quantum information theory, quantum computation, and quantum matter. So welcome, and you have 15 minutes. Yeah.
Thank you. First of all, I would like to thank
No, the screen, it's not showing it on the screen.
Thank you. Thank you. First of all, I would like to thank Geshe Dorji Damdulji and Professor Sishir Roy for inviting me here. And thank you. From the morning, there are so many interesting talks. And we begin. In this talk, I am going to briefly touch upon what is, how do we perceive time from the perspective of a quantum physicist. And I might be able to cover 1 or 2 topics briefly. First of all, when we say the time, we all know that we experience time at whatever the level we are in. That means there is a past, present, future, we get old, and this is a very, very nominal understanding of what time means to us or any common people, and most of our economy, sociology, everything depends upon this one unidirection of the time. So then, from the perspective of a quantum physicist, does such a unidirection of concept of time, is it exist, or if it doesn't exist, how are we able to see that unidirection of time? These are some questions which was bothering me from a few years, and I would like, recently I was able to tackle these questions in a related way. These are the two of my collaborators, and this is the technical paper, Levitch. So, okay, there is a difficulty in understanding the quantum theory. I know that, but I try to introduce the quantum theory in 1 minute. So imagine there is this is an experimentalist. Okay, there is an experimentalist doing his experimentation in the laboratory, and a nice theorist enters, and experimentalist asks the question that what can you say about by looking into the tabular column, that means by looking into the probability distribution which I am giving to you. I have a sheet of whatever the inputs I have done, what and all the experiment I have done, and I give these sheets to you. And what can you say about what system I have used in the experimentation? I am not allowed you to open this box. Can you say anything about the system which I have used in this box? So this question is very prominent in the sense that this is this setup one framework. This setups a framework which we call as an operational theory framework, and in fact it has an origination from John Bell. Professor Atul has explained everything in detail about the probabilities and the Bell's theorem, and in fact it has origination. What do I mean by? So we in this slide, in this picture, I am proposing a idea that whatever we study is an operational theoretic perspective, and quantum theory is a mathematical formalism of a minimal descriptive formalism of whatever we observe. In a simple example, if I wanted to model the entire traffic of Bangalore, sorry, I know Bangalore very well, so I'm using the Bangalore example. If I wanted to study the traffic structure of Bangalore, I have a data of all the buses at all the locations, and I wanted to bring up the easiest, simplest theory which will exactly predict at this time where the buses will be. This is what my interesting stuff is, and quantum theory is able to do that at the subatomic stage, and from last 130 years, it's not even a single experiment is able to disprove the predictions of the quantum theory. So what are the basic elements of the quantum theory? It's always there is one preparation, something which you are preparing a state, and then you are evolving something, you are transferring, and then ultimately the most important aspect is that you are making a measurement and you get the probability distribution. So this is what one does in an experiment, and what you are trying to develop is a mathematical formalism for this explanation, and quantum theory is a mathematical formalism. This is the 1 minute introduction to quantum mechanics. Okay, so now the concept is what is time? When I ask the what is time, the frog answers that don't you know about the second law of thermodynamics? So most of you people at least heard about the concept called entropy, which basically says that time is flowing in one direction, or we are all aging. Okay, so once from the morning we had a breakfast and now nice lunch also, and I can't go back to lunch. Even in the lunch, Dorji offered me a nice sweet, but now I am planning to eat that, but I cannot go back and do that. So essentially the second law of thermodynamics says that you cannot go back. That means there is a direction. Well, but the dynamics in the quantum theory is perfectly reversible, in the sense that if the governing laws of nature is quantum theory, then the laws at the fundamental level, at least in the quantum theoretical level, which is what I'm more focusing on, are reversible. That means, then there is two fundamental questions emerged. One is at the microscopic description. What do I mean by microscopic description? I have a cup and then I throw the cup and the cup shattered. So and then you cannot make a cup back. Okay, so this is the one direction. The time has flown in one direction, but the dynamical laws are reversible for each and every particle. It is not, but in a emergent, if I use the words, in emergent phenomena, it is moving in one direction. Now, where does these laws come from? So this was the question is being bothering and bothered from approximately from 1900. So when Ludwig Boltzmann formulated the statistical mechanics, currently the foundations of statistical mechanics is trying to understand how does this emergent unidirection of time emerged from a kind of time directionless unitary dynamics of quantum theory. So that is the question, and that question is people have been asking, and there are various answers, debates. This is nothing to say that this is the end of an answer, whatever I am proposing, or it's not like that. There are various answers, debate, because it's a century-old problem. But for this, let me define let me again tell you again, what is the question is that at the subatomic level, you can kind of say that there is no time. So because there is no unidirection, but at the macroscopic level, you are seeing the unidirection of time. So where does this comes from? This is the question. So for that, don't much worry about the mathematics which we have defined here. I am a theoretical physicist. I have to show one equation, otherwise I am not satisfied. So I have to put an equation. So I put this. So basically, this is what is called observational entropy. This is called the observational entropy. Originally proposed by von Neumann in 1930s, but recently people have started to look into this entropy. This is one kind of entropy. The major problem is that in physics, in quantum theory, we don't know how to define an entropy. Like classical very well defined, but quantum there are problems. Okay, so you can think about what do I mean by coarse graining. There is one concept you need to remember in the whole discussion in this slide, which is what is called coarse graining. What is coarse graining? For example, here I have 1, 2, 3, 4, the 4 boxes, and these are all the probabilities. If I throw the particle in these 4 boxes, what is the probability which you are going to get the particle in the box 1, box 2, or box 3, or box 4. These are the perfect. I can perfectly know if I throw this one, what is the probability with which I can find out. My instruments are so perfect. Okay, so what? Now, there is two types of coarse grainings, which I have defined here. Means two types of observations in a very naive way. Here I am in the C, in this one, I am able to distinguish whether the particle is in the 1, 2, 3, 4. Any of these 4. Whereas this is another type of coarse grain measurement where I don't have the complete understanding. I don't have the complete capability to say whether the particle is in 1 or 2 or 3 or 4, but I can definitely say whether it is in the left half. That means either it is in the 2 or 1 or 2 or in 3 or 4. That means my measurement ability to distinguish is being reduced. So this is what is called the coarse graining. That means I am increasing my coarse graining. In other words, my measurement incapability is increasing. So there is a beautiful theorem which says that as the entropy increases, as the coarse graining is increases, my entropy increases. So what is so different with that? Why should I need to bother about them? So this, whatever the form which is showing here, which is a coarse grained, this is the coarse grained entropy, this is von Neumann entropy. What you need to know about this one? The black color one says what is the uncertainty about the preparation, whether I am preparing a red ball, blue ball, or whatever this. So what is my uncertainty? And the red color one is saying that what is the uncertainty which is coming due to my measurement incapability. I don't have the capability. My instrument doesn't have the capability. And the beautiful thing is that this difference gives the measure of irretrodictability. This is the one concept which I wanted to say clearly. What do I mean by irretrodictability? This comes from the probability theory called the Bayesian analysis and other things. So let us go very briefly that I have a forward direction, that is x and y. These are the two things. What I mean by forward direction is that the event x happened now and y later. Okay, so this is the forward direction, and there is some event happened, and I know by looking into the event x, what is the probability of y? I can predict that. This is what is called the prediction. So another one is retrodiction. That means after happening this event, what is the probability with which I can retrodict the past? Both things are very common in physics. For example, retrodiction is very common into looking into your astronomical data. You are able to retrodict what has happened some 100 years ago or other things. And also prediction is very common, as you already know that. So this is a common thing. So what is this is what is called forward probability and reverse probability. And this is giving measure of irretrodictability. Means given the current situation, how well I can retrodict the past. How well I can, in other words, this irreversibility, whatever I am dropping the glass and then it's broken out and I cannot get back the cup, is kind of how difficult is to retrodict. This entropy differences is giving me the measure of irretrodictability. So why it is so? So the entire thing I would be able to express in this 3 picture. So one is, the answer to this question which I have raised in the beginning is that one is because of coarse graining, That is, I don't have the control over all the details, each and every atom's control. This is the one thing, which is what termed as the coarse graining, measurement incapability, and associated with something called chaos. You must have heard about that. You cannot, the system is so chaotic, you cannot determine its initial position. Even though it is deterministic kind of thing, it is not possible. Such coarse graining, and which gives rise to what is called irreproducibility, along with chaos, gives rise to the concept of the whatever irreversibility, what we call in the macroscopic world. That means you can see a direction of time. Time is flowing in one direction. So it is moving from here to here. So in effectively what I mean to say is that, so the time kind of emerges from the timelessness due to our observer's incapability associated with systems chaotic nature. So that's one thing I could say. In fact, in this way, actually in the morning, Geshe Samtenji, as whatever his words, if I quote, that nicely fits it. Time is the property of the product. I would also extend, time is the property of kind of observation, property of the process. So, but ultimately, at least in this type of understanding, I would say that time is an emergent phenomena of an observer. So it is emerging. The time, quote unquote, the time of one-way directions kind of time is the property of an observer. I don't take more time, so just 2 slides. This is not my work, so I've been just doing recently the Bruckner's group. This is the relativity of the time dilation. You must have all know that, for example, if this guy is the rest frame and this is the rocket which is the moving frame, there is the 2 events. This is one event, differentiated by some time window. So, and then for a rest frame, this time window is one thing, and then if it is moving, it time delays. That means it reduces. This is what one concept from special theory of relativity, which revolutionized the time, which Abhishek put it in the morning. But if these things, if we instead of if I imagine this, the entire frames of reference as a quantum, the whatever he was explaining, it is the classical level. If we assume everything is a quantum, what would happen? So, for example, here is a sitting rest frame, and the frame which is moving is in a superposition. The entire frame which is moving in the superposition. Then what happens to this time delay? It is kind of interesting that the time delay itself, there are the 2 time delays. That means the time delay is in the superposition, what Professor Atul was telling. So you have already seen the superpositions. So like that, now not only the properties are in superposition, the entire time delay is in the superposition. That means the time delay itself is indeterminate. So there are further many interesting features about time, causality, and other things which is recently is happening. I just wanted to show these are the 2 things which how dramatically changes our concept of time from the quantum theory. Thank you.
Thank you, Dr. Arvind, for such a lucid presentation and for making accessible to us what quantum theory has to say about time. And it has to be said that since the morning, if we look at each of the sessions, the discussion on the microscopic and macroscopic reality, what is conventional truth, what is ultimate truth, what is the role of the subject, what is the role of the object, and then as you have also given an added definition of time, that it is actually also a property of the observer. You've highlighted what Arya Nagarjuna's entire philosophy is about in terms of his exposition on the Prasangika Madhyamika view, which is about 100% subjectivity and observer bias in that sense, a creation. With that, we turn to our next speaker. So we have Mr. Lotus Namgyal. He's currently a senior research fellow in the Department of Philosophy at Punjab University, Chandigarh, pursuing his doctoral research work in the field of Buddhism and modern science, especially the literature concerning dialogues between the two disciplines. Before joining the PhD program, he used to teach Indian philosophy in Delhi University's college as an assistant professor ad hoc. He pursued engineering for his bachelor's degree from NIST, University of Delhi, after which he did his Master of Arts in Philosophy, and since his college days, he has been studying Buddhist philosophy at Tibet House through its various programs under the guidance of Geshe Dorji Damdula. Over to you.
Thank you so much. Thank you so much. Good evening, all the respected scholars. It is indeed a great honor for me to get this opportunity to speak in today's conference on quantum physics and Buddhist philosophy. I wholeheartedly thank Geshe Damdullah and the entire Tibet House team for organizing such an insightful and interactive conference. With the dynamic advancement in modern science regarding the outside world, we have stumbled upon a unique turn of events in the form of quantum physics that has completely mesmerized the world with its charm to unlearn, unsee, and relearn many things which we always took for granted. This unlearning, which is in fact a new learning in itself, provides us with a new platform to relook into the treasures of age-old knowledge but with newer flavors. Such a mind-opening unlearning, if I may call it as, was taught by Arya Nagarjuna as well, wherein he taught us to challenge our conceptual constructs and views, thereby motivating practitioners to see beyond conceptual dualities. I call it unlearning because Arya Nagarjuna made us question the rigid concepts. His philosophy helps us break the molds of our own views. Well, my endeavor today will be to carry out a critical analysis of time, especially under the light of Arya Nagarjuna. A critical analysis of notion of time for me is indeed a very, very complicated process, because for this I have to step beyond the usual comprehension of notion of time. In the usual within this usual comprehension, we have the idea of an arrow of time, as everyone was, Professor Arvind was also telling us that there is an arrow where there is an idea of past, present, and future. Though quantum physics and theory of relativity has revolutionized commonsensical understanding of nature of reality, Buddhist scholars, I think, seem not to be too surprised with these findings, because they have been discussing such debates, they have been discussing such intense debates since time immemorial, through Nalanda tradition that was very much refined in Tibet by great masters. The 19th chapter of Mool Madhyamika Karika, Arya Nagarjuna takes a very thorough discussion on notion of time, first by considering the possible relation between three phases, the past, present, and future. The chapter employs reasoning to ascertain that the three times have no nature. I will try to explain my limited understanding with minimal technical terminologies. In verse number 1 and 2, there is refutation of the possibility that present and future exist in dependence on the past. The first verse goes like this: if the present and future depend on the past, the present and future exist in the past. Well, it is argued that if present and future exist depending on the past, then present and future would be the past. In other words, Arya Nagarjuna explicates the absurdity of the fact that the entities that are existing now and the entities that will exist later have both existed in the past. A rough representation of the first verse would be like, if present and future depends on the past, then past equals presence. Past equals present. That is, present is not only present in the present, but also in the past. Secondly, past equals future. Future is not only present in the future, but also in the past. In yet other words, if it is accepted that present and future is dependent on past, then it is somehow same as saying that everything that is happening in today's conference had been held in the past. As it is happening now, as we can experience it, and it will a complete replica will happen in the future. This is absurd. If more so, someone is watching our conference from say a distance of 1 light year from this conference room, he will experience this present now after 1 year. So our experience of the present moment and his experience of the present moment of the same event are different. Therefore, an objective present moment is again questioned. Then comes the second verse, which goes like this: if the present and future do not exist in the past, how can the present and future be dependent on it? as the presence of present and future in the past was shown to be absurd in the first verse, one might as well argue that present and future do not exist in the past, but then such a dependence does not exist. It simply means that both the relator of the dependence must be present, or else dependence is not feasible. A somewhat similar argument has been forwarded by Arya Nagarjuna while rejecting causality as inhering a swabhav, causality as inhering an intrinsic nature, wherein it is argued that one of the relata of causality, be it the cause or the effect, is a conceptual construct, because when the cause is there, the effect is anticipated, and when the effect is there, the cause is supplied by the memory. Arya Nagarjuna is not refuting the conventionality of causality and time, but he is refuting the swabhav that is said to be there within causality and time. He is refuting the intrinsic nature of time, intrinsic nature of causality. Arya Nagarjuna then shows the dependence of present and past on the future at conventional level in the very next verse. If present and future are not dependent on the past, neither of the two would be established. Now he is showing the conventionality. If future, for instance, is an independent part of time, then it will never become present or the past, which is not true, because at one point of time, future becomes the present as well as the past. Therefore, present and future are not established completely independent of the past, because time is conventionally experienced and explained as an arrow, where the present and future is always subsequent to the past. Conclusively, present and future can neither be established in dependence nor independently of the past. Therefore, present and future do not exist in a real sense and are not intrinsic features of time. Well, to contextualize the next verse, the fifth verse, I would like to draw the attention towards the most famous theory of relativity. Everyone was talking, Dr. Majhi was also talking. Just like the notion of absolute notion of time is challenged by Arya Nagarjuna, we find instances of this in modern science too. If today's conference, let's say, if today's conference were to happen in a spaceship traveling at a speed of light, let's say 80 or 90% of the speed of light relative to Earth, then for a person observing from Earth, it would take more than 1 day for the conference to finish. This is beautifully explained as twin paradox, which shows that time appears to pass more slowly for an observer in motion with respect to a stationary observer. It shows that time interval depend on the relationship between object and the observer. This challenges our intuitive concept of time as a universal constant. Duration of time, therefore, I guess, lacks inherent existence. On this, Arya Nagarjuna, in the fifth verse of the chapter 19 of Mool Madhyamika Karika, states that a non-abiding time cannot be apprehended. An abiding time that can be apprehended does not exist. And how is a non-apprehended time conceived? This is interesting because for me, Arya Nagarjuna's chapter on examination of time in Mool Madhyamika Karika, which otherwise is very hard to visualize, becomes a little more visualizable and easier with, at least for me, to grasp from inputs like Einstein's special theory of relativity and other scientific achievements. That's why I think such dialogues are very, very important. I'm positive that more research in the domain of quantum physics and theory of relativity or quantum gravity, I think they will provide even more insights into the notion of time, and such dialogues will definitely fulfill the dreams of His Holiness the Dalai Lama. Let's move to the last verse of the chapter of Arya Nagarjuna. It is said, it is said that within the Copenhagen interpretation of quantum physics, particles exist in superposition of states until measured, but upon measurement, wave collapses and a specific state is realized. The definite properties of the subatomic particles then get defined. Before that, there is no definite definitions of space-time of the subatomic particles. The temporal characteristics also get defined after the measurement. This brings us to the measurement problem that has been obviously widely described around the world, and even the philosophers of science have been discussing the measurement problem at various instances and trying to bring different conclusions. But my concern here is whether the evolution of probabilities depicted over time in Schrödinger equation prior to measurement infers the objectivity of time, especially in the absence of measurement. This thin line where a definite space-time properties of subatomic particles cannot be defined prior to measurement except for the mathematical formation in terms of probabilities has a lot of philosophical concern regarding the nature of reality. The debate that whether this is how the nature really is, or is it some human limitation, or there is some more things to be unveiled with more advancement in technologies or human knowledge. This debate will go on and go on forever. In quantum physics, we have also learned that the reification of intrinsic nature, causes various logical inconsistencies. This brings us to the next argument of Arya Nagarjuna notion of time. If time depends on things, then how can there be time if things do not exist? And since there are no things at all, how can time exist? Arya Nagarjuna then argues that if time is based on entities, it is once again fallacious because entities are also empty of inherent existence. Arya Nagarjuna has shown the absurdity of such claims that entities exist essentially in different other chapters of Mool Madhyamika Karika and in other texts as well. It is once again interesting to note that quantum physics has also challenged various classical concepts, but still, those challenges and new discoveries are mostly expressed in classical language because we comprehend classical language very easily. And most of the instruments also doing the experiments are somewhat classical in nature. I find a similar concern in Arya Nagarjuna's Two Truths, where he speaks that without relying on the convention, the ultimate cannot be shown. The idea is not to assert that quantum physics is the ultimate truth, which Geshe Damdullah was also explaining, but the analysis done in quantum world are at various instances similar to the ultimate analysis done by Buddhist scholars. Well, at the end, I'd like to bring up a simple rhetorical question for today's participants to think upon, which will help us to question the nature of time, because for me also, the analysis of time is a very complicated process. I think, therefore, this question can help one in one way or the other to start the analysis of time. The question goes like this: Is it possible that you yourself are the clock? And this reminds me of a verse from a poem by a great poet, Javed Akhtar, a contemporary Indian poet. I'll read it in Hindi. The translation is here. क्या ये मुमकिन है कि सारी सदियां कतार अंदर कतार अपनी जगह खड़ी हो, ये वक्त साकित हो और हम ही गुजर रहे हो? मैं सोचता हूँ क्या ये मुमकिन है, सच ये हो कि सफर में हम हैं, गुजरते हम हैं, जिसे समझते हैं हम गुजरते हैं, वो थमा है, ये वक्त क्या है? Although this poem as a whole seems to suggest presentism, which is not what Arya Nagarjuna is suggesting, but I'm sure that it will serve as a food for thought for everyone to start analyzing the notion of time. I would now conclude here and hope that all of you will go back home and try to relive today's conference, even though it has already passed. But what we carry forward is some good imprints and the good merits we have accumulated, somehow bringing us back to the very question I started: does time exist? Thank you, Tibet House.
Thank you so much, Lotusla, for your very courageous covering of Arya Nagarjuna's chapter 19. I'll take the privilege of the chair just to share a few thoughts I've had, because this panel is actually brilliant in the sense that we had Dr. Arvind try to show, as Geshe said in the morning, that at the microscopic level, the reality that we see at the level of ultimate truth, which is seen through ultimate analysis, comes closest to quantum theory. And Dr. Arvind just explained, what are the issues when you try to relate that to the macroscopic level, where you do see unidirectionality of time and all, but this is not perceived at that microscopic level, and what are the challenges that quantum theory is trying to bridge. And as you try to have shared with Arya Nagarjuna, of course, he going back to the morning sessions where Professor Samtinla brought up, Professor Ciceroji brought up, that I think at that time, first century scholar who is using the Buddha's words and analyzing through thought experiments and logic is coming very close to what quantum theory is now, centuries later, talking about. So I think Arya Nagarjuna's work, Mool Madhyamika Karika, of course, is not directly so accessible because it is pretty succinct. All the chapters are very succinct and very, very profound. And I think, therefore, the entry point is often Acharya Chandrakirti, and you need to access through other scholars who have attempted to interpret it, because if we take it literally, then as you ended, we start going perhaps towards nihilism, and that acquisition has been there. But I think, as was said often in the morning's presentations also, that, we do accept conventionally what we are experiencing, which all of us do experience time, we are experiencing it. We have to accept that that exists. And I think one of the beauties of Arya Nagarjuna's philosophy and that of the Prasangika is how to completely, go with conventional reality, accepting that reality, while also being able to see the ultimate nature of things, right? Because if we start interpreting the ultimate level as nihilistic, because we cannot correlate it to the macroscopic level or the conventional level, then there's a big danger there. And but as I said, very brave attempt. And I think, so exactly what you're saying, that Arya Nagarjuna is not refuting the existence of past, present, or future. It's just that through the frame of ultimate analysis, if we go looking for where is that present moment at that deeper level, it is unfindable, which is not to say it does not exist, because with the frame of conventional analysis and at the macroscopic level, definitely it exists. We are all aging and getting closer to death as I keep talking. So with that, we will turn to our last speaker, who is not here with us, but has sent a video recording. Dr. Tenzin Rabga is a postdoctoral scholar in the Department of Physics at Seoul National University. He currently studies the phase transition dynamics in Bose-Einstein condensates of rubidium. Born and raised in India, he's a graduate of the TCV school Selakwe and the Mahindra UWC of India. He completed his undergraduate studies in physics at MIT and continued his graduate education in atomic and nuclear physics at Michigan State University, graduating in 2020. For his PhD dissertation, he conducted experiments with radium atoms to probe sources of fundamental symmetry violations in the atomic nucleus. Aside from physics research under the guidance of Venerable Geshe Dorji Damdullah, he also dedicates his time to the study of Buddhist philosophy. In particular, he's interested in the discussions between Buddhism and science and the philosophical implications they have for each other's worldview. So, over to his presentation. Thank you. Presentation.
Good afternoon, everyone, and thank you for attending this afternoon session. I'd like to say what a tremendous honor it is for me to be speaking here today. And I would like to thank the organizers, especially Venerable Geshe Dorji Damdullah and the Tibet House India in New Delhi, for providing me with this opportunity to share some of my thoughts on today's topic of discussion. In person, I very much share the underlying spirit and the sentiments of now what is a growing and a continued dialogue between physics and science in general and Buddhist philosophy. With that in mind, I would also like to pay my warmest greetings to the panel of speakers, as well as everybody else in attendance, both in person as well as online. And thank you for taking your time in order to gather here and contemplate on some of these topics, which I think are both very interesting as well as quite important. And so today I've been asked to talk about the nature of time as understood in physics, and I'd like to do that in the following manner. Beginning with time as understood within the Newtonian framework, where time was assumed to have this absolute and uniform nature, and I'll explain what each of those terms mean. We will then turn to Einstein's revolutionary idea at the turn of the 20th century, where in his seminal work on special relativity, he fundamentally changed how we think of time, how we conceptualize time within our physical theories, which has since become the standard way of thinking of time in physics. And to illustrate this radical departure from the Newtonian framework, I will explain the now famous twin paradox and show how time behaves in a manner that is quite strange and peculiar, and something that is impossible to infer from the assertions about time within Newtonian physics. Now, it's also quite natural then to ask whether quantum theory, with all its bizarreness, as we have heard throughout today's conference, has anything interesting to say about time. And so I'll provide some remarks in that regard, and then conclude my talk for today. Now, it is difficult to overstate the importance of time in understanding reality, which is why philosophers and physicists alike have spent a great deal of time thinking about it. And Isaac Newton, for instance, was also very concerned about some of these questions about time, such as questions about its nature, whether or not it's a physical entity, and whether or not time depends on things external to time other than time for its designation, or whether it has its own independent existence. Now, within his scholium to the definitions in his seminal work Principia, we see that Newton identifies two different forms of time. One he calls the absolute or the true time, and the other the relative or the apparent time. So by the absolute time, he's referring to time which exists by its own nature, independent of things external to it, and it flows equably or uniformly in the background while things happen in it. By apparent time, he's talking about, or the relative time, he means time as we experience it. In this sense, we don't have direct access to the absolute time, but we can infer that there is an absolute time that is flowing in the background from the motion and the changes in things that are external to time. So we infer time from, let's say, the changing seasons, or from the passage of night into day and into night, and from the motion of the hands on the on a clock, for instance. So in this sense, he also defines a relative time. Now, it's important to keep in mind that by relative, we mean time that is designated in relation to changes to things that are external to time. In other words, the time that we actually measure, right? And this is not relative in the sense that will come up in special relativity later on in this presentation. Now, this immediately implies then, since Newton accepts the existence of this time, this absolute time that is independent of everything else, that uniformly flows in the background, this then necessarily implies this idea of an absolute simultaneity. What we mean by that is, it is possible then to say things such as, at this very moment in time, we can then specify what each and everything in the universe is doing, where it is, its position and its motion. And everyone in the universe agrees that all of these things are happening at the same time. So time in this sense is common and is something that we all agree on, or this notion of simultaneity is something that we can all agree on. So we can, as illustrated in this figure here, we can make these simultaneity slices where we can define all of space at a given time, and everybody agrees that this is all of space at a given time. Now, Albert Einstein, in his seminal paper on special relativity at the turn of the 20th century, fundamentally rejected this notion of an absolute simultaneity. He asserted that simultaneity is relative. What we mean by two events as being simultaneous is observer dependent. It does not make sense to say that two events are simultaneous with no reference to an observer or an observer's frame of reference or its state of motion. So as a result, it becomes very difficult or untenable to hold on to a notion of an absolute and uniform time if the very notion of simultaneity becomes relative. And that is exactly what Einstein said. He said our long cherished and innately held ideas of absolute time in the Newtonian sense has to be abandoned, has to be given up in favor of a time that is now relative in the sense that when we say that a certain amount of time is elapsed between two events, between two things that happens, the amount of time that has elapsed is not universal, is not common to all the observers, but is dependent on the state of the motion of the observer. It is observer dependent. So in this sense, Einstein's idea of relative time is a fundamental departure, a radical departure from the Newtonian formulation. Now, to emphasize this point a little further, let me give you an analogy. Generally speaking, let's say there are two events, somebody departing from Delhi and arriving at Dharamshala. And given these two common endpoints, we would agree that the amount of distance somebody has to cover in order to get from the start to the end depends on the path that the person takes. Now, this is generally accepted wisdom. In special relativity, it is not only the distance, the physical or spatial distance, but also the temporal separation between two events that is path dependent due to the relativity or simultaneity that we just spoke about. So therefore, the amount of time that has elapsed between two events has no meaningful absolute sense, and it really depends on who is measuring it. In other words, it really depends on the trajectory of the clocks that are measuring the separation, the temporal separation between these two events. So now let me give you an illustration of some of the abstract things that we've been discussing so far. And so we're going to discuss the twin paradox, and nothing really challenges our innate notions of an absolute time like the twin paradox, and in some sense it highlights some of the crucial features of Einstein's arguments in his new theory with regards to relative time and his dismantling of our widely cherished, long cherished notions of an absolute uniform time. So we start off with two twins, X and Y. One of them, twin Y, decides to take off on an excursion on a rocket with speeds dangerously approaching significant fractions of the speed of light. Right. After given a certain amount of time, twin Y decides to turn around and head back towards Earth. And so they eventually meet on Earth, and to their amazement, they find that one of the twins, twin X, who's always remained on Earth, has aged significantly more than twin Y, who's just returned from his round trip around the galaxy. But then you might ask, wait a minute, so how much time has really elapsed between these two events, between the two twins meeting? Can we in any sense answer that question? But we know from relativity now that there is no absolute answer to that question. It is a relative statement when we say a certain amount of time is elapsed between two events, as is evidenced by the biological aging of these two twins, that the biological clock, if you will, registers the amount of time that has elapsed between these two events differently based on the trajectories of the two twins, on the different trajectories of the two twins through this fabric of space-time in which everything happens. And this is, in a sense, the remarkable feature of Einstein's theory that is fundamentally different and is a radical departure from our innately held ideas of how time behaves, how time flows or our innately held assertions about the nature of time, that it is in fact very, very strange and not something that we're innately programmed to perceive or even comprehend. So this, in a nutshell, is an overview of how our notions of time have evolved from the Newtonian conception of an absolute and uniform time to Einstein's radical departure and assertions of a relative and a more dynamic time. Now, some of us might wonder, given the inherent strangeness of quantum theory, whether or not it has anything significant or interesting to add with respect to the nature of time. Now, as far as the standard formulation of the theory goes, in my limited understanding, I don't think there is anything remarkably significant that it has to say with respect to time. As it happens, generally speaking, given the regime in which the theory is operating, whether we are dealing with systems that are relatively non-relativistic, we usually adopt the notion of time as is present in the Newtonian formulation, driven mostly by the need of the hour, practical needs of the hour. But when things do become fast enough, when relativistic effects become important, then necessarily we have to make our quantum theories compatible with special theory of relativity. And in that sense, the relativity becomes important, and this gives rise to what is called quantum field theory, which is the backbone of pretty much all of our particle physics. But nevertheless, by and large, the notions of time that are present in quantum theories are what are already present in pre-existing theories in classical physics. So quantum theory by itself does not have anything, does not appear to add anything new, at least at that level. Nevertheless, I think we can ask certain interesting questions and bring them up for discussion with respect to how quantum theory does or does not treat time, right? For instance, within the classical framework, which are by nature deterministic, we can assign temporal designation to objects. We can talk of their past, future, and present, and we can very clearly infer a continuum, a causal continuum, deterministic causal continuum between these three temporal events. But this becomes quite difficult in the quantum framework because within quantum mechanics, at the moment of measurement, at least in the standard formulation, at the moment of measurement, indeterminacy creeps in. So then we can ask, what does this imply in terms of the in terms of the temporal designations that we make on the objects? We can also go a little further and ask whether or not the notion of a singular actual future is compatible with this quantum indeterminacy, and other questions of this kind, right? Which I think are quite interesting. And in quantum mechanics, the physical observables, or the quantities of interest, are represented by what are called operators, right? But insofar as I know, there is no time operator. So what does this mean? Can there be a time operator? As far as I know, certain arguments by Pauli and von Neumann prohibit such a notion, but this is probably up for debate and discussion. But if there is no time operator, then what does that mean? Is time then a physical quantity within the quantum formulation? Is such an idea even tenable in the first place? So I think these type of deep and interesting questions can be raised within quantum theory as well. Yeah. And so this basically sums up my talk. But I wanted to end with some questions that I think can be also asked of the Buddhist theories with respect to how time is explained in their philosophical schools, specifically how the Buddhist understanding of time compares to the Newtonian and the Einsteinian notion of time, whether or not within the different tenets of Buddhist philosophy there is a resolution to the twin paradox, how time is experienced by different clocks in different trajectories can be explained within the Buddhist philosophical understanding of time, and how does the relativity of time as explained by Einstein fit into the dependent origination, the theory of dependent origination as explained in Buddhist philosophies. With that, I will end the talk and thank you all for listening.
Great. So that was a wonderful recorded presentation. So we'll take a few questions from the floor now. I think even the younger audience is waiting for tea. But if anybody has any queries. Ben.
Hi, me again. Lotus Nangera, could you elaborate on why Nagarjuna said that if present and future depends on the past, then the present and future exist in the past? Why did he say that?
I thought I tried to explain myself, but all right. So he is saying that he is trying to refute the dependence, refute the arguments that is coming to him, where he is trying to refute the arguments wherein he that present and future exist in dependence on the past. So let's say if according to the first verse can be translated as I already told you, that it is somehow same as saying that present equals past if it is dependent, because both the relator has to be present in the same moment. That is how dependence work. Are you following me? See, your age is what? What did you say? Yeah.
So I said that my current age, not old, yeah, older. So now I'm 33 years old. It depends on me being 32 years old before.
Yeah.
It doesn't mean that it exists at the same time.
So I'm not talking about that dependence. Dependence in terms of existence. See, Nagarjuna is what? Yeah, Geshe, I would rather explain it. See, he is not actually refuting the conventionality of time. He is as Professor Kaveri also told reflected that he is trying when we try to look into the time, let's say present moment, we have to do it into past, into at least three different times. The present moment related to the past, the present moment related to the future, and a middle between that. So you cannot find the present moment intrinsically.
The time is also past when you were saying that that only equals 1% level you can't actually get sorry. So whenever you try to talk about the present is gone. So in that sense, you can't actually, in a very solid sense, can't stay in the present. Never. But what you were saying, this does not mean that what you were saying is wrong, because you were 33 years of age, but within uncertainty level. That is what I was also talking in my talk, if you remember, that every time when you argue about a physical process, you always talk about some uncertainties. But with that, you can't work in science. In science, you approximate that as an exact logical statement, and then you work on it. But then again, when you question that what is it that I'm talking about, then you need to go back to the process. And when you go back to the process, what you see is everything is spread out. Right? So in that sense only. So it is neither of you are absolutely correct. You can question it. He will not be able to answer it with the extreme satisfactory level to you. But if you then think that, okay, I am now right, then you will see that there is a wrongness in it as well. So it's always in the middle. Okay.
Statement from my side. Well, what I can understand with the notion of time, when I think from the perspective of memory or mind, so what I am with my memory right now is essentially the collection or the accumulation of past. So the present indicates the past. So present is the accumulation of the past. And what the mind thinks about the future is essentially the projection of this present, which I call the accumulation of all past. So essentially, in terms of memory and mind, the idea of present, past, or future is essentially the movement of thought backward or forward. So this is what I can understand. Sorry for the confusion if I...
I think what Benna asked, I think we have to stick to what he asked. What he asked is that the present moment, whatever age he, 33, and that he was 10 years old, or that he was 13 years old 20 years ago. So these two don't coexist, and this is reality. So I'm going to say that if they exist as intrinsically, that these two should be together, and then if they are dependent on each other, these two should be together. Why? So this question we should stick to that. We cannot give so this question asked, answer should be totally unrelated. So this question asks, so how if the present and the past when he was 20 years younger, so if these two are dependent on each other, what he is today is because of what he was 20 years ago. So these two are dependent on each other. So why is it that the two should be together? Why? This is the question. So in this regard, so basically the idea is that Arya Nagarjuna, as very clearly indicated by Professor Kavariji and the Dr. Lotus Namgyale, that if there's intrinsicality there, then the dependency is rejected. If the dependency is not there, then what exists should forever exist. What does not exist should never exist at all. So because of which, if the past exists, it should exist forever. And if the present should exist, it should exist forever, in which case the two should coexist at one point. If that is the case, then the dependency would make no sense. So this is where the two things are, two different entities, and the dependency is rejected if the two things coexist at one point and intrinsically. Yeah, thank you.
Thank you. My question was for Professor Arvind. If the quantum field is not unidirectional or linear, and we posit from whatever little I understood, I'm not a quantum, obviously a scientist, but we posit, and we are not able to fully understand how the unidirectional linear formation of time exists. Will science, from the science point of view, if you're able to solve for that, will we be able to go back in time potentially?
What I meant was that at the subatomic level, or in other words, at the quantum mechanical level, the unitary dynamics dictates that you cannot distinguish between the future and the past kind of thing. Whereas in the microscopic world, we can. So the answer, one of the answer out of many, is that why it is, if you ask, there is a coarse grinding. Means my observation are incapable of getting all the details of the microscopic constituents. So that's the answer. Okay. So if the question is that am I able to get the details of this one? It is kind of impossible. Means it is very difficult. For example, the number of subatomic particles is too huge. So such a question, whether can I go back or other thing, doesn't make any sense at the language of quantum theory.
Krishna, if I may just take the privilege of the chair, just because there are physicists here, just to ask you that there is so much money being spent on research on time, trying to arrest it and other things. So do you see any, sense in that, or Professor Cicero? And because there is a lot of energy going in, at least at the commercial level, trying to stop aging and all these kind of things. Do you see any sense in that, or really it's a bit of a futile exercise? I just wanted to ask.
Yeah, I mean, aging simply it indicates there is unidirectionality of time, because it's a kind of macroscopic phenomena. I don't know what is happening at the subatomic level. Okay, so of course we should try to understand that aging is a fact. I mean, at the conventional or whatever we say ultimate level, where in my view, I mean, if you be enlightened in such a manner, for that nirvana is it's meaningful. For me it is not meaningful, because I have not reached to that state. I can say in language, but that's sake of language.
Thank you so much. So thank you to the panelists and all the participants, and we will break for tea, and then we will come back for the very exciting student panel. Thank you. Thank you so much.
Hello. Thank you, everyone. And I believe you all must be very tired. Therefore, I will be quick. Now, I would like to request Ajirji to present souvenir and Tibetan traditional khatas to our respected speakers and to our chairperson. Professor Kavirigilla. Assistant Professor S. Aravindaji. And Senior Research Fellow, Mr. Lourdes Namgila. Before we recess for tea and refreshment, I would like to request all of you to kindly join us for the most appealing session, the student panel discussion, where the young minds will share their pretentious experiences, and we really appreciate your presence. Thanks so much. And the next moderator will be my colleague, Mr. Tinzi Legmela. Thanks so much, everyone.
which is a panel discussion on which the panelists will share their views or experience on today's conference topic. For this session, Associate Professor Bhartipuri will be chairing the session, and we have other 7 panelists who are Mr. Vishnu Vijayan, Ms. Chiring Dolgar, Mr. Ujwal Patak, Ms. Drishti Sherawat, Mr. Stanzen Lotus, Mr. Mohammad Aswad Khan, Mr. Dawat Singh. Now I request our chairperson and panelists to please come on the dais and take your respective seats. Before I proceed, I would like to share a brief introduction of our chairperson. Associate Professor Bhartipuri she's from Department of Humanities and Social Science at Indian Institute of Technology, Delhi, IIT Delhi. She has presented numerous papers at the international conference discussing about poetics and politics, difference in identity, literature, and history writing in the making, transmission of an idea called Tibet, religion, ideology, and utopia, theorizing violence and non-violence in France, Fanon, and Gandhi. Professor Bhartipuri has been invited for various national and international talks. Institute for International Relations, National Chengchi University has invited her in the year 2011 and 2012 for an international talk on religion in the public sphere of Taiwan, Indian tradition and modernity, sacred and the secular, etc. She is currently a visiting scholar at National Chengchi University and Tamkang University, Taipei, Taiwan. She is also a doctoral research fellowship at Indian Council of Social Science Research, New Delhi. I now request Associate Professor Bhartipuri to kindly take over the session. Thank you.
Thank you so much for that introduction. And as I stand here, I'd like to say how honored I feel to take a quantum leap from the time I was a small little child looking through a little hole in the wall of the Central School for Tibetan Children, wondering why they looked so happy. My father was in the secretariat and we would gallivant around the place. And it never occurred to me that time that I would then eventually meet Dawa Norbu, my supervisor, who would get a gallon of coffee on a Sunday and rubbish all the PhD drafts that I had made, only because he thought that there was a bigger and a more interesting journey. The journey still goes on as I now see a new harvest of very, very interesting young students. And it's just so nice to know that I will be chairing a session where there are these very ardent, very driven and very enthusiastic scholars. And there's Vishnu Vijayan, who's in his 3rd year of undergraduate studies studying physics at Hindu University at the University of Delhi. Ms. Chiring Dolgar, who has finished her graduation in life sciences from the University of Delhi in the year 2018. There's Mr. Ujwal Patak, who's woven together academic interests and his brilliance over very deep-rooted connections with Buddhist philosophy, and he has been reading a lot of science over his formative years. There's Miss Drishti Sehrawat, who has completed a high school education in Shalon Hills International School in 2021, and subsequently she is studying business admin from the Institute of Innovation, Technology and Management. And she would be graduating in 2024. Mr. Stanzen Lotus is with a bachelor's degree in BCom from the University of Delhi, and currently his interests in Buddhist studies have bloomed, as you can see, with his encounters with individuals, and you're so fortunate, who have shared their insights into various aspects of Buddha's teachings. He intends to pursue Buddhist studies, and he's pursued also graduation. He's done a postgraduate degree in MA Buddhist Studies from the University of Delhi. There are a diversity of concerns through which he looks, and it's really nice to have students with such a deep intention and interest in Buddhism. Mr. Muhammad Aswad Khan is currently a final year student pursuing BA Honours in Political Science at Galgotias University, and his academic journeys are very closely aligned to the principles which all of us really think are very valuable of selflessness and self-sufficiency and introspection and that he sees, in a sense, identified with concerns in Buddhist philosophy. He wishes to align himself with the true essence of Buddhist philosophy and engaging with the politics of emotion, involving interactions between people and a diversity of ministers and such public spheres. Looking forward to your work, Aswad. Mr. Dawa Sering is currently enrolled at the Indian Institute of Heritage, Noida. His primary objective is in attending this session is to gain a large, comprehensive understanding of philosophy of the esoteric Buddhism and its contemporary relevance. His intention is to, and he aspires to integrate principles of esoteric Tibetan Buddhism into his daily activities, and aims to apply these teachings as a means to facilitate his overall holistic development. It's a great honor to be sitting on with a variety of students who have such diverse concerns. And I would like to just give a little bit of my 2 bits on what is in this spectrum of looking at and trying to assimilate an understanding what is Buddhism or what is Buddha. I think in terms of really taking the concerns with a lot of philosophers, a lot of thinkers who have thought on Buddhist philosophy. We know that one way or the other, Buddhism is and Buddha had always been, in a sense, modern. I'm not sure about modernist, but really modern. And in that sense, the whole idea of whether Buddhism is a speculative religion or is it really ethics, I think one way or the other, right from the beginning, from the time of its inception, there was an intention of both changing the world, but also being able to live in the world, which is a very important fact of our existence. And it's definitely not quietist in that sense, and my own work abuts on this idea of the engagement of Buddhism in a diversity of concerns and how. So in that sense, when we look at the world as an illusion, and in that sense, we, in terms of really understanding a whole lot of concerns that have come up today, the boundedness by our own consciousness, which is, in a sense, I'm not sure how would it really be partial, would it be inadequate in our explanation of what is Buddhism. And to that extent, when we, we sometimes, and I think Professor Gill also made an observation in that sense, when we, and through Nagarjuna, also to look at that aspect of consciousness, when we look at it as reality, we are kind of falling victim to a kind of an illusion. And that beautiful poetry that was read out, that is it us who are in the passing, I think, the whole idea of change in the world that, and the idea that one way or the other, we are also getting changed by it is a dynamic in which we live. And I think no other times than now when we are talking about AI, when we are talking about a diverse range of things here. And in that sense, it looks like a process which is almost automatic, but is it not, is a big question. But considering that these causes and these consequences which come from our acts, from our own actions, if we really kind of make a choice of filtering out from that idea of stream of consciousness, and we think of how we need to traverse through our own selfish urges, which are our own very hurtful sometimes, and how do we really do all of that? And I think one of the things which is probably the most sublime thing in Buddhism is that when we do this, we are not only for ourselves, but for the world also. We are filtering a little bit of the hurt and the harm that we have always with us, because we are agencies of change and we are shades of gray which we don't ourselves recognize ever. But we also know that within the ambit of Buddhism, Buddhists have fought wars. It's not like as if, there's a lot of soul searching that needs to happen. But on the whole, when you look at that perspective, there's very little harm, so to speak, that Buddhism has done or that the world has, felt that. So it's not about redeeming any sort of religion or thought. But I think as students, I think what really merits our attention is that it really takes you towards critical consciousness. It takes you towards critical thinking. It takes you to that what is beneath the meaning of meanings. What is it that is actually in terms of the dominant myths that we live by? What is it that are there in terms of the impressions we have? Do we always live by official pronouncements? Do we stand up and say, I respect you, but could I ask a question here? Do we question, those are very important concerns. Do we just go by traditional cliches and, Buddhism has adapted? So how do we interpret that? And also the root causes of a lot of concerns of social context, of ideologies, and also of personal consequences that we have when we, refer to any constructs. And there's this very interesting thinker called Paulo Freire who talks about he indicates the process of what is analytical, or what is the how does an individual in a sense or a community acquire critical consciousness. And he says it's by becoming aware of one's own context and identity, and after that an individual begins to perceive the social and political contradictions of their own worlds. And I think one of the most important things which I possibly learned at across the table from Dava Norbu about, in terms of pedagogies as choices that we make. Do I choose as a philosopher trained to also look at a concern which is Tibet, which is grounded in my understanding of what could be ethics, what could be looking at environment. Also to discernibly look at it critically, not simply as somebody. So I think the critical friend, the friend who critiques, is a true friend. So in a sense, not just simply from that perspective that I need to lay out parameters in Buddhist thought, but to really, I think, and that is what hermeneutics did to Christianity in a sense, to bring out the idea of, interpreting texts. So transmission of knowledge, I think, needs to be perpetuated, in a sense, supported. But I think it's not about status quo, and we know Buddhism has dismantled that and has taken up that challenge big way, because it adhered to a different set of scholars, but scholars also constantly moved with it. And I think not taking stands in that sense is almost like being conformist. And I think, luckily, when you look at Buddhist texts, they don't even ascribe you to become like that. But one of the things which, as some of you are Tibetans here, Tibetan scholars, I think the idea of language and power, which I think is a way of accentuating your thinking, and in terms of what is, again, Paulo Freire comes up with, when he puts the question of legitimacy. And he says, why do we associate, legitimate knowledge with certain symbols? And why is this knowledge, in a sense, about our collective imagination? And when we look at, for example, professors in dark suits teaching about something on Brazil, but an indigenous woman cannot. So what does it tell you? It tells you about the shells of power. It also tells you, in a sense, what comes to us through thinkers about showing truth to power. So I think the impossible has to be reached through our teaching. And we have to, he proposes that in his valuable concerns with language and about dominant cultures, and how he says that you have to express yourself, you have to be able to express yourself in what is considered the legitimate way, and to articulate the thoughts that will serve, in a sense, to bring out more, different interpretations could be made for liberation, but I think the most beautiful of the understanding one gets is of Paiko Iyer, who talks about the boundaries of life that are responsible for the beauty of life. And in his episode where he talks about travel, where he discusses that as people we become something, the whole idea of becoming and being, we become when we travel. And the whole idea that, especially referring to an age of technology, when, there's the whole, he uses the idea of the ping pong for our own lives, that we are here and there everywhere, the ping pong as a metaphor for life. And most importantly, which comes to us through Buddhism, the importance of and the significance of impermanence, and and against that idea of being and versus becoming, or being and becoming, whichever way we want to look at. Now, really, this question did come up, and forgive me for being I wouldn't be able to, but it's just something that struck. I wouldn't take more than a minute. It struck me when I was listening to the scholars' very interesting papers. And when we're looking at this ontology of, being and becoming, I think of this very interesting prayer that His Holiness the Dalai Lama says is his favorite, and I find it extremely interesting and nice. He says, as long as space, yes, thank you so much. For as long as space endures, and for as long as living beings remain, until then, may I too abide to dispel the misery of the world. I think this is a quantum, and there's it's a lot of interest in quantum mechanics. So this is a quantum worldview, and I was wondering whether Dr. Ragpa's insight into this could help us to see if this is a window to the worldview. And if the probability of dependent origination actually is a kind of a congruent to explain our fragile existence in this connect. I think there's a lot that is going to happen with our young scholars. Each one of you gets 7 minutes. I have already got, I hope I have tagged time. But thank you so much for listening to my half-baked, but then Geshe-la wanted me to speak from the first-person perspective. I hope, it made some sense. Thank you so much. So I'd like to call Mr. Stanzen Lotus to start his paper, and or your comments. You get 7 minutes.
Respected venerables, guest speakers, and my dear friends, a very good afternoon. I want to express my gratitude to Geshe-la and Tibet House for giving me an opportunity to share my experience on this conference. I would like to begin my presentation by highlighting the purpose of knowing the main theme of this conference, that is ontological reality. From the Buddhist perspective, it is mainly to get rid of all the miseries and to achieve maximum happiness or lasting happiness. And from the quantum physics, it is mainly to achieve a better understanding in the development of physical matter. We see that Buddhist philosophy is mainly focused on subjectivity, that is, transforming the mind. But science focus is more on objectivity, that is, the development of material world. In the inaugural session, Venerable Geshe Gamang Samtila clearly mentioned that we have to know how to bridge the gap between the reality and perception. By understanding the reality, we can change our perception. As a Buddhist studies research scholar, I aspire to do comparative studies, but today I will talk about the topic more from the Buddhist perspective. So the happiness we seek in mundane life is not stable and lasting. But if we want a lasting happiness, we need to change our perception, because we have a misconception towards all phenomena that things truly exist. And to change our perception, firstly, we need to know what exactly ontological reality is. Ontological reality in Buddhist philosophy means to understand the nature of phenomena through analyzing it on a subtle level. The more we go closer towards an object, the more we can understand its nature. Buddhist philosophy describes the ontological reality or ultimate reality through the doctrine of emptiness. When I came across the word emptiness for the first time, emptiness in Sanskrit known as shunyata, I assumed it is as something literally empty, where there is nothing. If something is empty, it possesses nothing, as in an empty cup. Such an idea of emptiness as nothingness is common, and I understood in the same manner. However, emptiness in Buddhist philosophy has nothing to do with nothingness. As an individual who holds such a view that emptiness to mean nothingness falls directly into the state of nihilism. Emptiness' main concept is to draw attention towards dependent arising of all composite phenomena. It describes how things come into existence, how things are not independent, and how things have no inherent nature. Different Buddhist schools have different approaches in teaching the nuances of ontological reality. During the first session, Venerable Puja Daprala mentioned that except for all four major Buddhist schools, it is only Prasangika Madhyamika of Madhyamika school which refutes the existence of intrinsic nature of phenomena. But this does not mean that they reject objective existence. They say things do exist, but do not possess intrinsic nature. We learn from the Buddha's teachings that our afflictive emotions such as attachment, jealousy, anger, and so forth are triggered by mental perception, which is always under the influence of ignorance. Due to this, we see things as truly existent, and then grasping arises. A famous verse from the text Mulya Madhyamika Karika by Arya Nagarjuna says that ceasing of karmas and afflictions leads to nirvana. Karmas and afflictions arise from conceptual thought. They arise from mental elaboration. Elaboration ceases by emptiness. If an object is appealing, affliction of attachment arises. Whereas an object being repulsive, affliction of hatred arises. If the mind is not inclined towards either, it is of ignorance nature. All the afflictions can only cease if ignorance is eliminated from its root. Therefore, it is only through the wisdom of emptiness that one can eliminate the affliction of ignorance. Just like a child who wishes to go closer towards a rainbow and touch it, by reaching closer, it disappears. I learned that it is only by crossing the border of conventional reality one can understand the nature of phenomena ultimately. Likewise, if we try to analyze the ontological reality of things in life, we can get rid of all the miseries and achieve lasting happiness. In the morning, during the keynote speech addressed by Venerable Geshe Dorje Damdula, he mentioned that one should try to see the ontological reality to the most subtle level, to wake up fully and stop the tears of miseries. With this, I end my presentation. Thank you so much.
I'd like to invite Mr. Muhammad Aswad Khan to make his comments.
Good evening, first of all, to everyone. Honorable Jisha Law and respected moderator Tenzin, sir, chairperson Bharti Puri ma'am, and my fellow panelists. Here I am standing as a Buddhist philosophy student, you may also call me, because I've been attending these sessions, these conferences from last 3 conferences. So beginning with the first time, my experience on this panelist platform is very enthusiastic. Like, I want to say everything, but I have a limited time. So I would begin now. Leading to more holistic and compassionate view. Now what I came across about this conference on time subtle and the conference of gross matter and ontological reality. As we all know, the idea of atoms and dharmas in Buddhist philosophy or terminology has been a part of Buddhist philosophy for centuries. Likewise, Abhidharma, school of Buddhism, one of the major Buddhist traditions, have been followed from there, and a developed detailed system of the classification for this ultimate truth, to find out the soul, to find out the truthness. I came across with many of the dynamics for today's conference. I gained many deeper insights on this conference, interconnectedness of all the things and the illusory nature of self and the role of consciousness in shaping our perception in reality. This insight can guide us and many more people with a mindfulness of compassion, being compassionate and fulfilling the existence. Now, first talking about the ontological reality, as said by G. Dorji Damdullah, that we have two truths, that is conventional truth, and second one is ultimate truth. Talking about the conventional truth, which analyzes what our mind retains, and second world ultimate truth, in which we have to gain the retentions to our ultimate analysis. And comparing electrons, they are in a level of conventional level of more electrons to be discovered, and their behavior we analyze as it to go deeper with the studies. Now when we talk about the quantum physics, we have a profound impact on our present lives, like fields such as medicine, technology and communication, as said by Dr. Utkarsh Mishra sir. Now, taking forward, while quantum mechanism delivers into the mysteries of physical world of subatomic level, and Buddhist philosophy explores the nature of that reality. Beginning with the understanding of the atoms, as said by our inaugural sessions, solid, unchanging entities, but rather it is an interconnection between the soul and the phenomena in which we are going through. The Buddhist concept on this of emptiness further challenges our assumptions about reality, suggesting that atoms and all the other phenomena lack inheritance self-existent. This implies that a deeper reality lies beyond our limited perceptions, that our understanding of our universe is constantly evolving, which emphasizes our imperception, shunyata, emptiness, vijnana, consciousness, and samyukta, that is the interconnectedness. Buddhist philosophy can mutually illuminate each other with the quantum physics, providing empirical support to all the fellow beings and all the concept of that philosophy. Now coming to my speech end, that is wrapping up this information which I gained today in the conference of atomic physics and Buddhist philosophy, offers a fascinating thought of oneself and a provoking exploration of the nature of reality to gain the reality to itself to for the soul and for the people, of going good with the selflessness. As we came up with the two truths, in shaping our perception, we can move beyond with the conventional views and embrace a more advanced and a holistic understanding by our soul to this universe. From the book, The Universe in a Single Atom, by His Holiness, the 14th Dalai Lama, messages ourselves that oneness and interconnectedness is not only a philosophical concept, but also a concept of action. He encouraged us to recognize our shared humanity and to work together to create a more just and peaceful and sustainable world. Thank you so much.
I call upon Mr. Dawaseri to make his comments.
Good evening, everyone. As a student of history of art, I have tried to understand Buddhism through visual text in the form of art, such as painting, sculpture. Today's conference, delving into the intersection of science and philosophy, proved both intriguing and challenging for me. I find myself lagging behind almost all the time. It also reminds me of one of my aesthetics class when my teacher used to say in the class, some students see wonder happens, others wonder what happened. Since I neither come from science background and philosophical background, so today I will share my experience broadly and widely. The philosophical doctrine posits that nothing exists independently, rather every phenomena is intricately interwoven and contingent upon the existence of everything else, elucidating the intricate web of interrelatedness that governs the universe. The principle emphasizes that the existence and manifestation of all phenomena depend on the multifaceted interdependence. In essence, at the core of our being, science and religion converge harmoniously, transcending apparent disparities. The intersection of science and religion should be marked by harmony rather than the conflict, as the emphasis on reason, logic, and fundamental principles of cause and effect seamlessly align with empirical and rational foundation. So today's conference welcomes a confluence of scientific understanding and philosophical insight. The conference like these stand out as a possible mediator, as both science and religion ultimately aim to improve the well-being of all sentient beings, which promotes inner peace, joy, and harmony by combining wisdom akin to scientific inquiry with compassion reflecting ethical and moral values commonly linked with religious and spiritual beliefs. This perspective suggests that the wisdom and compassion should be seen as mutually supportive elements crucial for navigating the complex interconnectedness of our world, advocating for the integration of scientific knowledge based on reason and evidence with a moral and ethical guidance from religious principle to form a comprehensive solution to global challenges. This fusion resembles a symbiotic relationship, envisions a harmonious coexistence wherein scientific progress is not separated from ethical consideration, but is guided by the compass of compassion. In this comprehensive approach, individuals and societies are urged to appreciate the intrinsic value of scientific advancement while also recognizing the essential role of ethical consideration and compassion in guiding the application of such knowledge for the collective betterment of humanity. This holistic perspective advocates for nuanced understanding that goes beyond the surface level dichotomy between science and religion, suggesting that their convergence can generate a synergistic and transformative force capable of addressing the diverse challenges faces our shared global existence. So I finally express my gratitude to Tibet House for providing the opportunity to participate in this enlightening conference, emphasizing the significance of dialogue and collaboration of fostering a more integrated and harmonious world. I thank you all.
I'd like to invite Mr. Vishnu Vijaya to make his comments, please.
Distinguished speakers, respected representatives of Tibet House, and dear fellow panel members, good evening to all. It's a great honor for me to be here. As an aspiring quantum cosmologist, it gives me immense pleasure to share my views on philosophical aspects of quantum physics. So first, I will shed light on what made me interested in the particular topic of quantum physics and how it's interlinked to philosophy. So my basic interest lies on this field called quantum cosmology, which describes the cosmology, which tries to describe the cosmology using quantum scale. So I just wanted to answer the fundamental question of what exactly we are. And that cannot be done with the help of science only. So we need a philosophical approach for that. So that's the primary reason for me to choose this field. So let me dive into my talk. And what I will be doing will be just a summary of what is happening from morning. So it will be some point might be repetitive, and I think I will provide some new inputs which will be from my side, and I'm subject to correction. Please correct me if I'm wrong. I'm not an expert in either of these subjects. So yeah, so I am trying to explain few things like consciousness, philosophy in quantum mechanics, and reality, what exactly is reality according to my perspective, and some quantum mechanical stuff like entanglement. So in physics, how does philosophy come in? Both are actually looking on a larger scale, both are very independent subjects, and how these are interlinked in fields like quantum mechanics. So how does that actually happen? So when we do the physics, it's an often common saying, and it's the truth, mathematics is the silent language that universe speaks, and it's a key for physicists. So when we dig upon mathematics to understand the quantum world or even the cosmology, so we land upon results which are very counterintuitive. And giving physical interpretation to those mathematical results give rise to philosophy, that it's highly counterintuitive, and we need philosophy to describe that. So physics is simply the study of nature, and quantum physics in particular is the most counterintuitive branch of physics. And it explores the laws governing the subatomic world. And most often, the physical interpretation of quantum theories are highly philosophical. I will give an example, which is a Oppenheimer interpretation by Niels Bohr, Werner Heisenberg, and Max Born. We can describe them as the founders of quantum mechanics, or the pioneers in that field in around 1920s. So they were, it was it can be described as the best time to be alive. So there was a huge debate going on between them and Einstein. So we are not still sure who won the debate. So yeah, that's the Oppenheimer interpretation. That's the primary point where I begin. So from that, I will dive into what consciousness really is. So in Cosmos, it's one of the finest works of Carl Sagan. You can describe him as a cosmologist. He quoted, "With time, matter evolved into consciousness." And consciousness is something both science and philosophy is trying to understand. So this overlap between science, particularly quantum physics, and philosophy fascinates me the most. I found quite two interesting things were Buddhist philosophy and physics, both interlinks. As a matter of fact, any philosophy and physics both are interlinked in two things. First of all, Buddhist philosophy is a way of understanding the world and our place in it. It's based on the idea that everything is interconnected and that there is no such thing as a separate self. This is a point where physics and Buddhist philosophy overlaps the most, that both describes the fundamental unity of all things. And when we dig deep into physics, then that's the point that we land upon. It describes that everything is united. And let me go to the philosophy in quantum mechanics. So the highly philosophical nature of quantum mechanics or quantum physics was revealed many decades back, exactly around 1920s or 1930s, when fields started evolving. from fundamental experiments which happened around 2 centuries ago. I will give an example. Most of you might be aware of that. It's the YDSE, or Young's double slit experiment. So that led to the the starting point of the evolution of quantum physics. So the actual experiment happened in 1801. Sorry for being a little bit technical, but yeah, it started in 1801, but there was a slight modification which the physicists did. Actually, it happened in around 1961. They used electrons in place of photons, and they landed upon some very interesting results. Like by that time, like de Broglie proposed that every matter will have their own wavelength. So in 1801, we knew that interference happens with light waves or other electromagnetic radiation, and which gives give rise to optical phenomena like interference, diffraction, and so on. But this was surprising with the we discovered. We discovered the same phenomena with electrons, and we landed upon the most confusing conclusion that even electrons are self-aware, or we landed up in the conclusion that the consciousness, landed upon things like quantum consciousness and observer effect. Observer effect basically means when we observe something, it changes the reality. So there, I would like to shed a light upon what reality really means. So when we, in quantum mechanics, we often speak about wave functions and everything. So wave functions is just like the amplitude of de Broglie waves. So in reality, reality in physics is what we observe or what we perceive. But the act of observation can itself alter reality. So this is a counterintuitive thing in quantum physics. And it also poses other philosophical arguments such as future is predetermined and possibility of quantum consciousness and everything. So then we have a quite interesting discussion about time. Is it absolute or relative? When we talk about relativity and everything, it is relative, but quantum physics deals with the absolute picture of time. So yeah, and in entanglement also, it's also a highly philosophical thing. Like even if two interconnected particles, or the quantum state of each particle of group cannot be described independently on the state of the other, including when the particles are separated by a large distance. Even if they are not connected, somehow they align opposite. If one spin is up, the other spin is down. So this makes me happy to conclude my speech, that I'm very happy to see both science and philosophy merge together. And this is my personal belief that there are some aspects in science which the fundamental principle of all science is to explain the universe or explain what we are. So there are many aspects in science without which, without philosophy, we could not achieve the ultimate result that you are looking, like the unified field theory or field theory of everything. So I think philosophy and science should work together for the benefit of humanity. And this is my first conference attending, and it was a great experience. And I will end my talk by quoting from Sri Buddha, like, there is no wealth like knowledge and no poverty like ignorance. Thank you so much.
So much, Vishnu, and the rest of you. Sorry, I should have been less rude. I didn't remember to thank, but I would ask Ms. Sering Dolkar to please give her comments now.
Gangi tuksingye sunne tawa thamche pang peche dampe chuni tunzape kotamde la chasalo. Thank you, Professor Bhatiji. Good evening, everyone. First of all, I would like to pay my gratitude to Venerable Geshe-la and Tibet House for giving me the opportunity to share my experience related to today's conference. I feel honored to be part of this conference. From His Holiness' book Beyond Religion, when I first learned about emotions and ways of regulating the emotions, it introduced me to universal compassion and oneness of all human beings. It opened my eyes to look at the world in a broader perspective. As a human beings, we are all same. We all want happiness and do not want suffering, which Venerable Geshe-la and other scholars have already enlightened us. And delving more deeply into Buddhist philosophy, psychology, logic, epistemology at Nalinda Master's course offered by Tibet House, it has unfolded many layers of convergence and divergence between science and Buddhist philosophy. Both Buddhist philosophy and science have been developed for the well-being of human beings. But the difference is seen in the goal. Science delves in the development of external objects and Buddhist philosophy in the development of internal mind. Today, due to the kindness of His Holiness the Dalai Lama and programs such as organized by Tibet House, there have been dialogues between science and Buddhist philosophy where to jointly contribute to the welfare of humanity. Buddhist philosophy explores different levels of reality, manifest phenomena, slightly hidden phenomena, and very hidden phenomena. On the contrary, physics or modern science in general explores the manifest and some part of slightly hidden phenomena. As a student of Buddhist philosophy, it is intriguing to see the converging point of science and Buddhist philosophy, as Buddhism is seen as a science which can be accepted whether you are a follower of Buddhism or not. The final liberating path known as wisdom of emptiness in Buddhist philosophy, which espouses that conventionalities come into being through dependent origination of mere labeling. This is the key to explanation of subtle phenomena which is yet to be seen in the understanding of modern science. As physics, we know the scientific study of matter, energy, and fundamental forces that govern the universe. It seems to explain the nature of reality through empirical observation, experimentation, and the formulation of mathematical models. On the other hand, Buddhist philosophy, particularly Arya Nagarjuna, delves into the nature of existence, consciousness, and path to liberation from suffering. With today's conference, slight glance we have is that one grounded in empirical inquiry and other in contemplative introspection. However, as we explore the depth of both, we find the intriguing points of convergence. It is interesting to hear from Venerable Dr. Puja about the concept of emptiness. A phenomena lacking inherent existence can be aligning with some principle of modern physics, especially within the framework of quantum mechanics. As in the quantum world, particles don't have fixed properties until observed, and their existence is probabilistic rather than deterministic. This uncertainty echoes Arya Nagarjuna's assertion that nothing possesses self-existent intrinsic nature, but still lot to explore to observe the deeper meanings. As I mentioned already, divergence that primarily we can observe between the two disciplines is that physics tends to focus on external, objective reality, seeking into understanding the mechanics of the universe. In contrast, Arya Nagarjuna's assertion that nothing possesses self-existent, intrinsic nature, but still lot to explore to observe the deeper meanings. As a in the conclusion, the convergence and divergence of physics and Buddhist philosophy offers fascinating exploration of the nature of reality. As we continue to advance in both scientific and philosophical understanding, perhaps we will find even deeper connection that illuminates the profound mysteries of our existence. The dialogues between such disciplines organized by Tibet House invites us to transcend the boundaries of our current understanding and embark on the journey towards a more holistic comprehension of the universe and our place within it, especially to learn ontological reality of external phenomena can affect our internal state of emotions in today's world. Once again, I want to deeply express my gratitude to Tibet House, Venerable Geshe-la, and staff for the bringing such conferences. Thank you.
Thank you so much, Esteemed Dolkar. I'd invite Mr. Ujjwal Pathak to.
So it's been a long day and only brave one of us have stayed, I think. So a great philosopher, Socrates, once said, "I know that I know nothing." His Holiness the Dalai Lama was once asked, "What would you do if science disproves your religious beliefs?" He said, "I would read all the evidence and will really try to understand them, and in the end, if it was clear and proved right, I would change my spiritual beliefs." Good evening, everyone. My name is Ujjwal Pathak. I'm an undergrad student of political science. And since most of the things are already said from the morning, I'll just try to express my own views of what I've understood from the morning. So, time is funny, isn't it? It's like the elusive trickster. It's like the last piece of chocolate in the box that we always try to grab, but it always slips through our fingers. If only we could put time on a leash, take it for a walk, maybe even teach it a trick or two. But time has a mind of its own, and no amount of pleading or negotiation seems to alter its relentless march. In the grand tapestry of existence, time weaves a story that encompasses the subtle and the gross, the seen and the unseen, much like the dance of subatomic particles in the vast cosmic ballet. Now, quantum physics, where particles are like teenagers at a party, simultaneously everywhere and nowhere. It's like a universe decided to throw a surprise party, and the particles are the guests who show up at multiple locations at once. If Schrodinger had a cat at this party, I imagine it would be both alive and playing the piano simultaneously. Quantum physics, where reality is a kaleidoscope and we're just trying to catch a glimpse of the cosmic disco. It challenges our understanding of the tangible and the intangible, much like the teaching of Buddhism that challenge our perception of self and existence. It's as the universe itself is playing a cosmic game of hide and seek, inviting us to question the very nature of our own reality. Born in Kushinagar, where the air is thick with spirituality and the Wi-Fi is weak, I've always felt a personal connection to these teachings. The connection between Kushinagar and Buddhism is not just historical, it's a cosmic contract that binds us to eternal dance of enlightenment. Being with the monks, I always used to play with them, I always used to question them and the science both. And I think Tibet House in this regard, through this various conferences, has helped me in answering my own questions. Now, Buddhist philosophy in its profound insights suggests that reality is not fixed, objective entity, but rather a subjective experience shaped by our own minds. This concept of dependent origination or highlights the interconnectedness of all things, suggesting that nothing exists in isolation. There is a concept of emptiness or shunyata, as we say in Sanskrit, that finds resonance with the quantum view of reality as a field of infinite potential. According to Buddhist teachings, our perception of reality is distorted by our own biases and attachments. We cling to the things as being permanent and self-existence, leading to suffering and dissatisfaction. True liberation only comes from understanding the true nature of reality, recognizing the impermanence and emptiness of all things. Now, if we see the two words, subtle and gross matter, as far as I know, the specific usage of these terms in the context of modern science can be traced back to 17th century. In 1687, Isaac Newton wrote a book, Principia Mathematica, where he wrote about the distinction between gross matter and subtle matter, which he called ether. Newton believed that ether was a fluid substance that filled the universe and mediated gravitational and other forces. Whereas if you see in Buddhism, gross matter is also known as rup. Subtle matter is known as nam. In Buddhism, the cycle of rebirth or samsara is driven by the interaction between gross matter and subtle matter. Our actions, karma, in the gross material would create imprints on our subtle matter, which is consciousness, which then determine our future rebirth. What I'm trying to say is the things which we are finding now by spending billions and billions of dollars have long been known in the Buddhist philosophy. Now imagine a tree falling in a forest with no one around to hear it. Does it still make a sound? From an ontological perspective, the tree's existence is independent of human observation. It falls and the sound waves propagates through the air, regardless of whether someone is there to listen. Now consider this another statement. The apple is red. The apple's existence is independent of our perception of its redness. The apple is still red even if we are colorblind or in a dark room. The color red is an ontological reality that exists independently of our perception. This is related to again the concept of emptiness or shunyata. The Buddhist understanding of ontological reality is complex and nuanced. There's this book, Ontological Reality, Quantum Theory and Happiness in the Buddhist Philosophy, which is written by none other than our own Geshe-la. And it challenges our conventional notions of reality and suggests a more fluid, interconnectedness and interdependent view of the world. While it may seem counterintuitive at first, this view can lead to a deeper understanding of ourselves, the world, and our place in it. The parallels between quantum physics and Buddhist philosophy offer a fascinating glimpse into the convergence of science and spirituality. While they may approach the ultimate mysteries of existence from different perspectives, they both point towards a reality that is far more profound and interconnected than we may ever imagined. So let's embrace the paradoxes of time, dance with the quirkiness of quantum physics, ponder the mystery of reality, and absorb the timeless teachings of Buddhism. As we navigate this cosmic carnival, let's remember to savor the laughter, cherish the wisdom, and enjoy the cosmic rollercoaster ride. May our journey through the mysteries of time be filled with joy, insight, and a sprinkle of stardust. Thank you so much.
I'd like to thank you so much, Ujjwal. That was so beautiful poetically. Miss Rishti Sehrawat, you're next in line. Thanks.
Before beginning with my share of experiences, I would like to thank my teacher, Venerable Geshe Dorje Damdullah, and Tibet House for giving this opportunity to me. And I would like to pay my respect to the honorable guest, Venerable Professor Geshe Samtinla, and all the audience who are here offline as well as online. Before actually sharing my own experiences, I would like to share what I learned from the conference. Even though quantum physics is something which didn't go in my mind and just went over my head, still there were some things which are actually related from what my teacher taught during the retreats I attended. So there's this one question. When I was in Tushita, I attended one of the Nalanda Master's Courses classes. The students were putting up some questions, and there was this one question wherein someone was talking about partless particle. It said that the partless particle, as mentioned by Venerable Pujala in her speech, was that it exists independently. But from what I learned from my teacher and from what the four seals of the Buddha states, that all composite things are impermanent, all contaminated things are the nature of suffering, everything is of the nature of emptiness and selflessness, transcending sorrow is peace. The third seal of the Buddha's teaching states that everything exists with dependent origination. But the partless particle, which was stated in that question, was saying that it exists independently. So I was very much in confusion with this question. Then I asked someone in the retreat, and that person told me that this was according to the Vaibhashika school. So I still wasn't convinced why Mahayana school is actually not stating that it exists independently. Then today in the conference, when Venerable Pujara said that, she explained it very well, and I was so much intrigued by how she explained it, that if the center of the particle is partless particle, then the particle will meet the particles in the north and the south. The same side of the particle will meet the particles in the north and the south. Then there will be no center particle. So therefore the center particle wouldn't exist. So I was so intrigued by this. And there was this one more thing told by one of the professors on atoms. When we come to this world, our body is formed with the atoms. And when we grow, more and more atoms combine in our body, which comes from the waters, from the water we drink, from the food we eat. And then when we die, the atoms dissolve within this planet itself. We don't carry the atoms with ourselves. We are just, formed with the atoms. This was also one thing which actually was very intriguing for me. Now, now, from what I learned in Buddhist philosophy, I have not learned much from Buddhist philosophy. All I have attended some systematic teachings. I have a lot, and I need to learn more about Buddhist philosophy. There are many years and years I need to study in order to actually say that I have some realization. But there are some things which I learned from Buddhist philosophy which helped me with my day-to-day life. I feel like as a student, we are very pressured to get good grades, have high earning income, great careers, and many more. We have to compete with each other, and this competition doesn't stop. We compete in school for good grades. We compete for good colleges. When we start earning, we compete with our co-workers in order to prove ourselves and earn a promotion. And this is like how our majority of our life goes by in the competition. Majorly, we are always taught how to deal with the outside world, how to get high income jobs, how to succeed in a startup, how to be good at managing finance, because that is very essential for a company. This is what I have experienced myself and seen others experience throughout my student life. What I want to say is that we need to know and learn how to deal with the external world. But most importantly, we need to also learn how to deal with our inner self, how to deal with our emotions. As we are growing up as students, our hormonal changes are increasing, and we don't know how to deal with the anger we have on our parents just because they tell something which is good for us, but we believe it is not. So I got my personal experience is that I get very nervous when I have to speak, and I feel like this is what everybody would be noticing while I'm standing here. So even when I have to speak in front of my classmates, which I know from the past 2 years, I get very nervous. At the beginning, I used to get nervous to an extent that my body had zero energy. I was shivering and everything. I tried to, resist it. I tried to help myself with it, but wasn't able to do anything. Then as the time went by, I started learning Buddhist philosophy systematically with the help of my teacher, Venerable Geshe Dorje Damdullah. And so I was actually able to help myself with this nervousness. The reason why I'm standing here and not shivering. So how did I do that? I learned about the reasons why we experience emotions like nervousness and fear. I learned that we and others are not independently existing. These emotions which we experience, such as nervousness and fear, are also dependent on various factors. And if we tackle those factors, then we can actually help ourselves with this nervousness and fear. I learned that how our mind creates delusions, like making us believe that other people will laugh at me if I'm not saying good stuff. They will criticize me if I don't have much knowledge. And what if they don't like me at all? I'm pretty sure people here wouldn't say that, but out there when I'm in a student life, the students of my age make fun of others just because they don't have much knowledge. So I deal with this by again and again reminding myself that the situation which my mind is making me believe in has not happened at all. I'm not perfect. No one is. How good my presentation will be is completely dependent on how much knowledge I have about the topic, how my physical strength is at that time, how my mental state is at that time, and especially how much interest I have in that particular topic. It is dependent upon all these factors and many other factors. They all together make me present, whether it is good or bad. I was able to do this by the constant reminders. It didn't happen like I learned Buddhist philosophy and I just implemented in my life. It didn't happen that way. Even now, I still have to work a lot on this. It happened by the constant reminders I gave myself. Even when I'm not feeling the nervousness or fear, we have to give ourselves those reminders of how we need to focus on the causes and not on what we are perceiving. I tried to meditate on these. I tried to see how my nervousness was triggered actually. We need to generate constant awareness of not just what is happening around us in the world, but also inside us. This is something which we all know, but still we cannot help ourselves when we are in the situations. So there's this one verse of many taught by the Blessed One on dependent arising. All phenomena arise from causes. The causes are taught by the Tathagata. The cessation of causes as well is taught by the Great Seer. If we focus on how the outcomes we perceive and see are entirely dependent on its causes, we focus on the causes or reasons for the phenomena to exist in a certain way, then and only then we can tackle our all unwanted emotions easily. Just like a person can perceive a rope lying on the floor as a snake, and a person who knows that rope will not have the fear as the person who thinks that the rope is a snake. It all depends on our perception. So, similarly, when I believe that, what am I going to do in the presentation, how other people will think about me, and I believe all these factors to be the truth, then I will actually feel the fear. But someone who is more experienced in these things will not actually have the fear or nervousness while standing here and speaking. For example, my teacher Venerable Keynote. All I want to say is that if we actually learn about how the mind is working, how we are experiencing, and go to the reasons of how we actually are suffering with the unwanted emotions, then and then only we can actually help ourselves, and then only we can tame our mind. Thank you.
Thank you so much, Drishti. Am I allowed to make my comments from here? Okay. Thank you so much for sharing this, which has been a very transformative opportunity for many of us, and some of us we've heard online. But I think different inquiries that have come up from in connecting science and philosophy and taking this ahead very beautifully, and the idea of whether, what is it, the cosmic dance when we walk in a forest and we feel ourselves. And I think this, the last conversation that came about learning from Buddhist philosophy, or whether we are, some of us may be asked whether we are Buddhists, and yes, when we are being good. I think it's a big reminder for many of us who, and I would, very heartfelt thanks to all the venerables, to the scholars here, to the students who gave me this opportunity to sit on chair with you. But I think this is really a conversation towards a connected world, and a connected world where we feel connected with ourselves. And I think that's one of the most important journeys with which Buddha began. And on that note, profound thanks to this opportunity. Thank you.
Thank you so much, Professor Bharti Puriji, for chairing this session so pleasantly. And I also thank to all our panelists for sharing your view, experience, and your valuable insights on this topic. May I now request Geshe Doji Damdula to kindly offer a khatak and souvenirs to our distinguished chairperson and panelists. Chairperson for today's session, to last session, Associate Professor Bharti Puriji. Thank you. Mr. Vishnu Vijayanji. Miss Thiring Dolkarla. Mr. Ujjwal Patak, Miss Drishti Sherawat, Mr. Stanzen Lotus, Mr. Mohammad Aswad Khan, Mr. Dawat Ring, thank you so much, Keshila. Now, I would like to request our Secretary, Mr. Kunjabla, to kindly deliver a thank you note.
So on behalf of Tibet House, New Delhi, I would like to take the opportunity to thank all the speakers and chairpersons and our guest of honor, Professor Geshe Samdillah, and our keynote speaker, Professor Sisiroyji, and our chief guest, Professor A.C. Pandeyji, for accepting our invitation and for sharing your profound knowledge with us. I extend my heartfelt gratitude to Venerable Geshe Samdillah for always being there and giving your constant guidance to enhance our capabilities. I would like to thank my colleagues and our volunteers for all the efforts and enthusiasm into putting all this together. Last but not the least, thank you to all the wonderful audience and students for your active participation in the conference. We hope that you found this conference informative and enjoyable, and we hope to see you all again soon in our future conferences and seminars. If you wish to get regular updates of Tibet House programs, you can subscribe to our weekly newsletter by sending us an email mentioned on the last page of our program booklet, which you can find in your program kit. You can also visit our website, www.tibethouse.in, subscribe to our YouTube channel, follow us on Facebook, Instagram, and Twitter account. That is all for today. Thank you for joining us and have a great weekend. Thank you. So I would like to request everyone to come up on the dais. Let's take a quick group picture. Thank you.